هذا
طيب بعد
خلص هذا. Good morning.
Morning.
How are you? We noticed that you're online, so we just wanted to say good morning. في سؤال؟ وليش طيب هذا هلا؟
حابب يحضر المحاضرات كلها شعب
شايفنا؟
وسامعنا. بس لسه هاي
هيك تمام؟
هلا بعد هدول وهذا بنعطيهم بريك هون.
بنعطي بريك، اذا بدكم تعطوا بريك مش مشكله، اذا كنا متاخرين وبدكم تعطوا بريك ما في مشكله. ليش؟ لانه اصلا فيش حدا، الناس اصلا هيجي بريك قالوا لك تقدروا يعني. انا صرت اصلا اذا كنت بدي اختار الا بالبريستل انه تقول لي نعطي بريك ربع ساعه، هي البريك إلكم اكشولي. اذا ما حبيتوا تعطوا بريك ما فيش لنا مشكله.
بقول لك كلهم حاطين بس
ما بقول لك عشان بس انه ما بقول لهم والله احنا صعب نتعلم.
بعدين هدول مش رح نعرف فيهم لانهم امبارح اجوا صح؟
هلا بترجع يعني
لا بس
نعطيكي البيوغرافي تاعتهم، بتاخذي اللاينين منهم. عجبتهم حديث بس انه تو لاينز.
طيب
وين السيشن الاولاني؟ بدنا قمرس وأديل.
وبعدين هدول احنا لا احنا برضه بدنا نكمل فيهم صح؟
انتوا كل السيشن الاولاني
والله لك الدكتور احنا لازم نكمل.
السيشن الاولاني بخلص شفتي امتى؟
السيشن الاول
وين التشيرز؟ هون على الصفحه الثانيه اللي هي الساعه.
اذا لازم نكمل تقسيمها.
هذول موجودين.
بتسمع دقيقة
خلصوا
اللي تحت بقول لك تفضل بس احكي.
قسمتوهم كلهم؟
هو موجود. لا لسه ما قسمناش الاول ايش عشان لا لسه بدنا نكمل. هلا بدك تضل انا كنت هون فانت بدك تكون هون اول واحد.
عايشه نصيب هي بايدها عايشه نصيب. طب بدي هدول اديلي وطنبل.
ايش هذا اسمه؟ اديلي
خورس واديلي.
Can you hear me?
Yes. Good morning, Eleftherios. Mauricio.
Hi, Mauricio. How is it going?
Hi, good morning.
I guess they have not started this yet, right?
No, not yet. Probably there is some delay, I suppose.
Okay. So I'll wait in line until you guys are ready.
Yes, I think so.
Nice to see you, Mauricio.
Nice to see you.
دكتورة
Are you in Canada?
Yes, I am connecting from my home. Now
Okay, very early.
it's 2 a.m.
Okay.
That's all right.
Good morning, Professor Diamandis.
Good morning. How are you? You must be
Good,
right.
how are you? So you're in Canada?
Yes, I am in Canada.
حسيت. So what time is it now?
It's 2 a.m. here, but that's all right.
Oh, okay. So we're gonna begin in few minutes, like 9 exactly.
Yes, take your time.
Oh, thank you.
السيشن 1 مش معاك يا هنا رايحنا.
Huh?
طفيت.
ثانية واحدة. صباح الخير جميعا. أهلا وسهلا لليوم الثالث للطب المخبري الفلسطيني ال IPCLM 11. احنا كتير مبسوطين انه اليوم معكم. انا والدكتورة سهير رح نكون التشيرز لهذه السيشن. في عنا كتير محاضرات شيقة رح نسمعها، فأهلا وسهلا. بدنا نبدأ باللكشر الأولى لدكتور عبد الرزاق الهديلي اللي هو the head of biology and toxicology laboratory و director of research laboratory toxicology and environmental في الفرنش أكاديمي اوف فارماسي. وبالإضافة راح تكون معنا كمان الدكتورة نادية شولي اللي هي بالفاكولتي اوف فارماسي اوف مونستير تونيجيا. فأهلا وسهلا بالدكتور عبد الرازق والدكتورة نادية، وتفضلوا للمحاضرة.
تحية خاصة للأخوة في فلسطين الحبيبة، تحية خاصة للدكتور أسامة النجار نقيب البيولوجيين الفلسطينيين ورئيس الاتحاد العربي للبيولوجيا السلبية، وإن شاء الله أن نكون في صحة جيدة. شكرا على الاستضافة. خلال هذه المداخلة سنتحدث على موضوع حساس وحساس جدا، خاصة في تونس وكذلك في العالم العربي، هو فيما يخص المخدرات وخاصة مكانة المخابر في التشخيص والمداواة لهذه الآفة. وستقوم بتقديم هذه المداخلة الدكتورة نادية شوالي اللي هي أستاذة مساعدة في علم السموميات في مخبر السموميات بالمونفوري. ولك الكلمة الدكتورة نادية.
شكرا أستاذ عبد الرزاق الهديلي. I am honored to present you our study entitled illicit substances identified in the urine of 11,170 suspected drug users. According to the latest World Drug Report, 271 million people worldwide, 5.5% of the global population aged from 16 to 64 years old, are drug users. In fact, drug addiction and trafficking became an urgent public health problem that affects human health, social life, and economy worldwide. Arab countries are especially affected by the scourge of drug addiction. For example, in Tunisia, traffic and consumption of psychoactive substances have risen since the uprising of 2011, and drug of abuse became increasingly available, particularly to school students from street dealers and darknet. The steady increase of the illicit drugs is considerable challenge for analytical toxicologists by the frequency of positive samples, the new chemical structures of drugs, and analytical methods. So, an epidemiologic investigation to evaluate the prevalence of drug abuse in north of Tunisia was conducted using 11,170 urine samples of suspected drug users or dealers. The study was spanned from January 2016 to December 2018. It was a cross-sectional study conducted in the toxicology laboratory Mahmoud Yaqub Center of Urgent Medical Assistance, which is the national reference forensic laboratory in Tunisia. Biological samples, individuals suspected to be drug users or dealers were arrested by the anti-narcotics and criminal squads, then transferred to the forensic laboratory, where 30 milliliters of fresh urine sample were collected in dry polyethylene container, tightly wax sealed. Diluted specimens were excluded from this study, and drug seizures were also performed. Analyzing a procedure, we should start with the screening tests. If tests are negative, so the result is negative, the specimen doesn't contain any illicit drug. If it's positive, we should validate with confirmation tests. If the test is positive, so the result is positive, but if it's negative, the result is false positive. The first step of toxicological analysis is screening with drug strips to detect cannabinoids, cocaine, MDMA, benzodiazepines, buprenorphine, barbiturates, and opioids. Positive specimens are then analyzed with immunochemical methods using cobas analyzer, such as the enzyme multiplied immunoassay technique and fluorescence polarization immunoassay. It should be noted that all the positive results and at least 5% of the negative results obtained by immunochemical methods must be confirmed by specific methods like chromatography. So results obtained using an immunochemical method cannot be confirmed using another immunochemical procedure. So for confirmation, we used gas chromatography coupled to mass spectrometry, which is a very sensitive and specific method. Confirmation methods, many confirmation methods exist, like gas chromatography coupled to electron capture detector to detect benzodiazepines, gas chromatography coupled to mass spectrometry for the majority of products, gas chromatography coupled to a nitrogen phosphorus detector for the detection of opioids, cocaine, methadone, amphetamines, and barbiturates. The HPLC and LC-MS are used for the majority of illicit drugs. HPLC coupled to a diode array detector for amphetamines and opioids, HPLC with fluorescence detector for opioids, and TLC for opioids, cannabis, and cocaine. The decision limits or cutoff are illustrated in the table below. You can notice that the cutoff of immunochemical methods are higher than GCMS for all products. Our study showed that 48% from samples tested were positive for at least one drug of abuse. So we reported 55% of positive sample in 2016, 50% in 2017, and 40% positive sample in 2018. We also observed that 50% of samples tested monthly were positive for illicit drugs, almost 450 positive samples per month. The prevalence of positive samples were 1,800 positive samples per year only in north of Tunisia. So we deduce that approximately 50% of suspected drug consumers trapped by narcotic squads annually were positive for targeted drugs. Nevertheless, drug-positive samples decreased over years, from 50% in 2016 to 40% in 2018, which is in contrast with the large quantity of illicit drugs seized every year by police and judicial authorities. It must be attributed to the emergence of new psychoactive substances like synthetic cannabinoids, cathinones, alpha-PVP, mephedrone, etc., which are growing worldwide. The purity and composition of products containing NPS are often not known, so it's difficult to detect them by standard toxicology methods, which lead to false negative results. Let's turning now to socio-demographic characteristics of drug users. The current investigation showed that drug users were mainly male with sex ratio of 37, but this male predominance does not reflect reality because the number of women consuming illicit drug is much more important, and because of social and cultural norms, women are much less arrested than men. The age and civil status, we observed that median age was fixed at 29 years old. This age group is the most affected by illicit drug consumption in the world. 65% were aged less than 30 years old, and 91% were singles. We also observed that 80% were daily workers, but this doesn't reflect reality because highly placed people are rarely apprehended by the police, and this also explains the rare positive cases of cocaine and opioids recorded, less than 1%. The prevalence of illicit drugs consumption, we observed that the cannabis was the most consumed illicit drug with 95%, followed by benzodiazepines and buprenorphine, and polydrug consumption. And finally, we found cocaine, opioids, and MDMA less than 1%. So the drug detected were THC in the first place, followed by benzodiazepine and buprenorphine, cocaine and MDMA and opioids, less than 1%. The polydrug abuse represent 1.5%, but barbiturates were not detected. Cannabis was the most widely consumed illicit substances because probably its relative low cost and availability compared to other drugs. In fact, according to the report of International Narcotics Control Board in 2017, the largest quantities of cannabis were seized in Africa. It must be noted that cannabis comes from neighboring countries which produce cannabis, like Morocco and Algeria, and recently from sub-Saharan Africa. We also detect a new concern, the polydrug abuse, which is increasing significantly since 2016. The most observed combination was cannabis with benzodiazepine. It's a serious public health problem. In fact, in USA, simultaneous co-use of alcohol and marijuana was the most common combination observed, followed by crack and heroin. Samples positive for cocaine and MDMA was markedly low compared with cannabis, 1%, but rates are increasing over years, probably because the expansion of the global market of amphetamine and cocaine worldwide. In fact, according to the United Nations Office on Drugs and Crime, seizures of amphetamine across the world quadrupled between 2009 and 2018, while the global quantity of cocaine seized in 2017 was 1,275 tons, which is the largest quantity ever reported. The access to opioids like morphine and heroin was minor, less than 1%, and we suggest that it is because of the high cost and the unavailability of opioids in the region. And as already mentioned, VIP are rarely apprehended by the police. Conclusions: drug users frequency was fixed at 1,800 positive cases per year only in North Tunisia. Drugs of abuse were accessible to all social classes from all age groups. Cannabis was the most common used illicit drug. Cocaine and MDMA are expanding as everywhere in the world. And finally, to avoid underestimation of positive case, alternative biological methods such as hair samples must be used, and new methods must be developed to detect NPS. In our laboratory, new methods using LC-MSMS are under development. Thank you for your attention.
مع الشكر للدكتورة نادية الشوالي، نحن في استعداد لتقديم كل الإيضاحات التي والأسئلة مع الشكر.
شكرا كثير دكتور عبد الرازق ودكتورة نادية، محاضرة كثير كانت شيقة. في أسئلة هلا للحضور الأونلاين.
Hello, ladies and gentlemen.
دكتور عبد الرازق معنا؟
Is he online?
Is he online, Dr. عبد الرازق؟ لا.
Okay. So
Yes, I am online. This is Eleftherios Diamandis. I'm very pleased to be here. Can you please start my presentation? Can you launch it?
Sorry,
okay.
can you say that again, please?
Okay, our next speaker is Professor Diamandis. Professor Diamandis, he is a professor of laboratory medicine at the University of Toronto. He is also a medical biochemist at Mount Sinai Hospital and University Health Network. His research interests are in tumor markers, personalized medicine, proteomics, and neurodegeneration. He published close to 1,000 PubMed indexed papers. He's going to present his lecture entitled Clinical Applications of Proteomics. So please, Professor, you can start.
Hello, ladies and gentlemen. My name is Eleftherios Diamandis, and I work in Toronto. I would like to thank the organizers of the 11th Palestinian Laboratory Medicine Conference for inviting me to participate in this meeting. My lecture is sponsored by Abbott Diagnostics, and I would like to thank Abbott for the kind sponsorship. I declare that I have no conflict of interest with this lecture. My lecture is entitled Proteomic Technologies, and the learning objectives are: I would like to teach you the various proteomic technologies for ultrasensitive multiplex protein measurement in human biofluids. I would like you to understand the methodologies behind these different technologies, to compare the technical parameters of the technologies to each other, and to review the strengths and weaknesses of multiplex proteomic technologies that we have today. I would like to start by defining what is proteomics. Proteomics is a large-scale study of the structure and function of proteins. With proteomics, we try to identify proteins involved in the pathogenesis and understanding how their expression, structure, and function cause illness. We also want to use proteomics to find diagnostic and prognostic biomarkers and drug targets in illnesses including cancer, immune rejection after transplantation, infectious diseases, neurodegenerative diseases, and other diseases. We also want to study individual patients to identify markers that could guide the patient-tailored therapy management, something that is called precision medicine. As you can see from the right slide here, in the past, we used to treat all patients with the same drug and the same dose, aiming to derive some therapeutic effect, but also derive no effect or derive adverse effects. With precision medicine, the goal is to tailor the therapies to various individuals so that we can only get the desired effect. What is the clinical utility of proteomics? As you can see from my lecture, we want to use proteomics to develop, discover diagnostic biomarkers, prognostic biomarkers, predictive biomarkers, monitoring biomarkers, and identify biomarkers of efficacy and toxicity of novel therapies. Currently, there are many technical challenges in using proteomics. As you know, the genome is composed of about 30,000 genes, but alternative promoters, alternative splicing, and mRNA editing increases the complexity of the proteome so that the transcriptome has a complexity of about 100,000 transcripts. Moreover, in proteomics, because of post-translational modifications, the complexity is increased further to about 1 million proteins due to the post-translational modification of most proteins. One major problem with the proteome is its large proteomic dynamic range, which spans 12 orders of magnitude. I'm sure you're all familiar with albumin and immunoglobulins, which are present in serum at gram per liter concentrations. There are other components in serum that are present at milligram per milliliter or microgram per milliliter concentration. Yet, there are many other proteins that are present in the nanogram per milliliter concentrations, in the picogram per milliliter, femtogram per milliliter, attogram per milliliter. And this dramatic diversity causes a lot of difficulty when we want to study individual proteins. And I'm sure you're all familiar with the concept that proteins that have been present in biological fluids in the nanogram per milliliter and higher concentrations have already been studied extensively. And now, only proteins that are present at sub-picomolar concentrations are likely carrying the information that we need to identify. I cannot describe proteomics without first describing mass spectrometry, because mass spectrometry and proteomics go hand in hand. It has been said that the modern workhorse of proteomic technologies is mass spectrometry, and I intend to spend a few minutes describing this technology to you. What is mass spectrometry? Mass spectrometry is an amazing technique. The basis of mass spectrometry is the production of ions from the sample that you're interested to analyze that are subsequently separated according to their mass, how big they are, to charge, how charged they are, ratio, and then detected. Mass spectrometry is very similar to electrophoresis, only much more powerful. The resulting mass spectrum, which is obtained with the instrument, is a plot of the relative abundance of the produced ions as a function of their MZ ratio. I will elaborate later on this. And please remember that mass spectrometry has its roots in physics and was developed in the early 1900s. Mass spectrometry was a useful technique for clinical chemists in the 1950s and 1960s, but the real boost in its use in the clinical laboratories and in research really happened in the 1990s when scientists like John Fenn and Koichi Tanaka found ways of ionizing peptides and proteins by using either electrospray ionization or the so-called MALDI, matrix assisted laser desorption ionization. I put with these two who won the Nobel Prize in 2002, Alexander Makarov, who developed the Orbitrap, one of the most amazing mass analyzers that we have today. The applications of mass spectrometry are very diverse and include information about the identity of unknown compounds. We can do molecular weight determination, structural elucidation, especially of peptides, finding their sequence, and we can also do quantification. It's a very useful technique for diverse applications. The basic components of a mass spectrometer are three. We have the inlet, from where we can introduce the sample. Then we have ionization source, which generates ions from the sample of interest. Then we have the mass analyzer, which separates the ions according to mass to charge ratio, MZ ratio. And then we have a detector which detects the ions and develops the spectrum. In one of the most useful ionization techniques called electrospray ionization, the technology is coupled to liquid chromatography. And as you can see here, the liquid chromatography effluent, when it comes out, it reaches a needle, which creates a spray of droplets, as you can see here, which, when present in a high voltage, the liquid is evaporated, and then the remaining components of the sample are present as positively charged ions, which are ready for separation in the mass analyzer. This is called electrospray ionization and won the Nobel Prize in year 2002. In another way of ionizing the sample is to mix the sample, the green dots, with a matrix, blue dots, which then is hit by a laser to dissolve ions, the green ions from the matrix, with the help of the matrix assisted, that's why it's called, to develop cationic compounds, which are then inserted into the mass analyzer for separation. This is the discovery of Koichi Tanaka, who shared the Nobel Prize with John Fenn in year 2002, and is widely known as matrix-assisted laser desorption ionization. The heart of the mass spectrometer is the mass analyzer, which is a unit that is equipped with the ability to separate the ions produced by the ionization source according to their mass to charge ratio. There are many types of mass analyzers, including the Orbitrap that I mentioned, but I will have no time to explain for each one of these components how they work. Briefly, the mass analyzer is a device that separates gas phase ions generated from the ionization source based on their mass to charge ratio. This one is achieved by manipulating electric and magnetic fields in which the ions are present in a way that they are coming out of the mass analyzer one by one according to their mass to charge ratio. This process is carried under high vacuum so that the ions do not collide with each other and change their trajectories. Now, I will introduce you into one very basic and important concept of mass spectrometry, which is called tandem mass spectrometry. In tandem mass spectrometry, there are two steps. In the first step, as I said before, the sample is ionized and the ions are separated by the first mass analyzer according to their MZ. In tandem mass spectrometry, the process does not finish here, but the ions that are detected in the first mass analyzer are introduced into a fragmentation chamber and are broken down into smaller pieces. And these smaller pieces are separated again by a second mass analyzer and then are detected. As you will see from the spectra, this has important ramifications for our ability to detect and identify the molecules of interest. And this is the most common application of mass spectrometry. Is called LC-MS, liquid chromatography tandem mass spectrometry. As I already mentioned, the mass spectrum is a plot of the relative abundance of each one of the detected ions depicted as MZ. In this MS1 spectrum, all the ions that are detected by the mass spectrometer are displayed, and this is why it's so complex. But in the MS-MS spectrum or the MS2 spectrum, each one of these ions is split into different fragments, and the fragments are displayed also as relative abundance versus MS, and you can see that this is a much simpler spectrum. So with one MS run, we can get one spectrum for the total ions that are present, but we can get 700, 800, or 1,000 spectra for each one of the MS2 spectra. And these MS2 spectra, with the lines that you see depicting the MZ ratios, we can deconvolute them with computer to find out what this compound is. It's a very powerful technology for that purpose. So just to recap with mass spectrometry, the first step is to generate ions by either electrospray or MALDI technology. The second step is to move the ions through optics for separation. The third step is to introduce the ions and separate them according to their mass to charge ratio. And as I mentioned earlier, the mass analyzers are of diverse types, known as quadrupoles, time of flight, ion traps, orbit traps, etc., and then detect the ions by using an electron multiplier. In this slide, I depict the advantages and disadvantages of mass spectrometry. The advantages is that mass spectrometry is highly specific and sensitive, is quantitative, it has a high dynamic range, it can interrogate diverse molecules from metabolites to hormones to peptides to proteins to nucleic acids. And this is why we say that with mass spectrometry you can do proteomics, metabolomics, etc. And also mass spectrometry has the ability for multiplexing. The disadvantages of mass spectrometry include the expensive instrumentation, which is in the millions in many occasions. It requires technical expertise. It usually needs sample preparation, is not sensitive for complex mixtures, and is not usually automated. I will now go on and describe some non-mass spectrometry technologies which may have desired attributes such as, and they are all based on immunoassay, the so-called ELISA principle that we are all familiar with. We want high multiplexing, which means that we want to measure simultaneously hundreds to thousands of proteins in one reaction. We want ultrasensitivity, which means we are able to detect in the picogram to femtogram per milliliter range, a dynamic range in the order of 5 to 6 order of magnitude, and have minimal sample requirement without the need to prepare the samples before analysis. Do such technologies exist? The answer is yes. One such technology is the antibody arrays. Antibody arrays are nothing else but the typical ELISA, only done in a miniature fashion. You can see here the coding antibody, the target analyte of interest, the detection antibody, which is biotinylated, and the detection of the whole complex by using streptavidin coupled to an enzyme such as horseradish peroxidase emitting light or luminescence. You can see that this kind of arrays are assembled in formats like this one as dots, or they can be of the direct type in which the sample is biotinylated and then detected in a similar fashion. As you can see from this slide, the proximity extension assay is based on antibodies that are labeled with nucleotides. And during the interaction of antibodies with their target, the nucleotides come to a short proximity and they can form a duplex, which is amplified by PCR, as you can see in the slide. And this attribute makes this technology extremely sensitive. The advantages and disadvantages of this technology are as follows. The technology has high specificity and reproducibility in the area of 15%. It has high multiplexing ability. They can do 32-plex assays, and they have 12 panels reaching over 1,000 proteins. It has high sensitivity in the area of femtogram per milliliter range, and amazingly impressive low sample requirements in the order of 1 to 10 microliters, and you can only need 13 microliters to do over 1,000 proteins. Very impressive. We are using this technology for some time now, and we are starting to publish some important papers based on this technology. For example, I show here one of our papers that just came out in the Journal of Applied Laboratory Medicine, in which we discovered biomarkers of traumatic brain injury by using the proximity extension assay. Another very well-known multiplexing technology that now exists for about 15 to 20 years includes the Luminex immunoassay principle, which is based on beads that are coated with antibodies, and each one of the beads has its core identifying fluorescent or infrared dye, and the technology has about 100 different beads, so you can do multiplexing of about 100 analytes. Finally, I will briefly explain the principle of the single molecule array, also known as SIMOA. This is a relatively new technology and includes microbeads, as you can see here, which are coated with antibodies in which the immunocomplex is formed in the regular fashion, and the detection is achieved by using streptavidin beta-galactosidase conjugate. This assay is extremely sensitive, capable of down to single molecule detection, and is used increasingly in various formats. The advantages of single molecule array technology include ultra sensitivity in the range of picogram to femtogram per milliliter, high precision in the order of 10%, and the fluorescence can be detected even from a single molecule. The drawbacks of this technology include low multiplexing. The sensitivity is compromised with multiplexing so that they're capable of doing only 10 multiplex assays. And the multiplex assay that I mentioned is relatively new and needs to be evaluated further for clinical use. In this important slide, I include the technical comparison of the various technologies that I mentioned. The antibody array with simultaneous multiplexing of about 1,000 molecules. The sample volume is 10 to 1,500 microliters. The sensitivity in the sub-picomolar range. the dynamic range, and the precision is shown. The proximity extension assay, which is my favorite, although I don't have any commercial interest in it, it includes multiplexing of over 1,000 proteins with just 13 microliters sample volume, with 10 logarithmic scales in the range and up to 8% precision. The Luminex shown here at 500 simultaneous analytes, 13 microliters, picogram per milliliter, and the single molecular array, the simultaneous analysis of 12 proteins with 13 microliters sample volume and exceptional sensitivity. So in summary, the profiling of the proteome can identify diagnostic or prognostic markers and drug targets of human diseases. The new multiplex proteomic technologies enhance the sensitivity and dynamic range of protein detection in biofluids compared to mass spectrometry. The various multiplex proteomic technologies use microfluidics to measure hundreds to thousands of proteins in minimal sample volume. The technical reliability of the technologies vary across the platform, and further studies are definitely needed to make sure that the precision and reproducibility are enough for clinical use. And the multiplex technologies are useful tools for discovery studies, but researchers should perform independent validation of candidates using orthogonal methods because, as I mentioned in other places in the literature, there is a lot of false discovery with cancer biomarkers, and we should be aware of. I close this presentation by thanking my colleagues Claire Fiala, Annie Ren, Dorsa Sofai, and Caitlin Di Paolo for their help with the preparation of this lecture. Thank you very much for your attention.
Thank you very much, Dr. Diamandis, for this informative lecture. I think he's with us. So if you have any question, please do. Is there any question?
I have one question. One thing also we, in the past few years that started is using MALDI-TOF for bacterial identification. And this really is rapidly increasing in the clinical laboratories because the cost of doing the test is not very expensive. But as you said, the cost of the instrumentation is a lot. Do you have, my question for you is, do you have an idea about how far using proteomics have gone with regard to antibiotic resistance detection in patient samples?
Yes, it's not, your question is not specific to antibiotic resistance. I think the general question is mass spectrometry or other proteomic techniques coming to the routine laboratory? And the answer is yes. I know of a major company who is now putting together an automated analyzer based on mass spectrometry with random access capability. As you probably know, some of the things that we measure in the lab, like steroids and certain proteins, are not very specific or sensitive. And these companies are now taking over this analyze by designing fully automated mass spectrometry-based machines. And I think in a year or two, we will have automated random access mass spectrometers in the lab like we have for chemistry and immunoassay analyzers. So the technology is moving to the lab very quickly because they have some distinct advantages for certain analytes, such as the steroids, including sensitivity and specificity.
Other question? Yes, please.
I would like the audience to know that I posted this lecture on the YouTube. If somebody wants to see it again, we use it for educational purposes, they can find it on YouTube and.
Thank you so much, Dr. Diamandis, for the very interesting lecture. My question is also related to Dr. Musa's question. You said one of the disadvantages of mass spectroscopy is the complex, like mixture of complex compounds. So how do they, like bacterial cells are considered a mixture of complex compounds?
Sorry, I didn't understand the question. Can you repeat one?
Yeah. My question was, you said one of the disadvantages of mass spectrometry is it's not useful for using a mixture of complex compounds.
Yes. Let me explain. Mass spectrometry, we claim that it is extremely sensitive down to actually theoretically one molecule detection. However, in order for mass spectrometry to achieve this kind of sensitivity, the sample that is presented to the mass spectrometer must be pure. When you deal with serum, which is, as you know, is an extremely complex mixture, and you're looking for a specific component of the serum, the mass spectrometer has a lot of difficulty in identifying because of the millions and billions of other molecules that are present in the sample. So in that case, the ELISA technology or antibody-based technologies are far more sensitive and specific because they don't have the problems of matrix. So mass spectrometry, in order to deliver the best results, the samples must be pre-purified and pre-treated so that the complexity of the sample is reduced to as much as possible.
Okay, thank you. Thank you, Professor. Is there another question? Okay, thank you so much. So we will move for the next speaker.
Okay, our next speaker is Sundus Saoudeh. Sundus is very passionate about her research. She holds master's degree in molecular genetics and genetic toxicology from the Arab American University. For 2 years, she has served as a research assistant at Al-Quds Bard College, focusing on cancer research. She aims at pursuing her PhD in the field of oncology and bioinformatics. Sundus will talk to us today about the functional role of TET3 enzyme in breast tumor genesis. Welcome, Sundus.
Good morning. I would like to thank you for giving me this great opportunity to be part in this conference. I am very pleased to be here today to present to you our work titled Functional Role of TET3 Enzyme in Breast Tumor Genesis, supervised by Dr. Zaidoun Salah, and for the fulfillment of my master's degree at the Arab American University. I would like to start by giving a brief introduction, starting with cancer, which is a very complex disease. It is characterized by rapid and uncontrolled cell proliferation in a tissue. And this feature of uncontrolled proliferation has an effect on the normal gene function, normal gene expression, which in turn has manipulative effect on normal cell functions. And of course, normal gene expression correlates directly with normal cell functions. Cancers arise from sequential alterations that can activate oncogenes or inactivate tumor suppressor genes. According to the WHO, breast cancer has the highest morbidity and mortality rate among all cancers in women. It is described as a heterogeneous type of cancer, which means it is composed of different subtypes. It is said to be a manifestation of different malignancies in the mammary glands. Now, for some time, scientists have thought that cancers are a result of pure genetic events with accumulation of mutations resulting in the formation of cancers. However, for the past 2 to 3 decades, emerging evidence is suggesting that epigenetics plays a major role in the formation and progression of cancers. Epigenetic modifications are multiple. They are responsible for different processes, for different cell functions, such as DNA repair, replication, and so on. And one of the most important and most studied modifications is DNA methylation. It is very important in different mechanisms such as cell proliferation, apoptosis, differentiation. It is catalyzed by the DNMT's family of enzymes, which add a methyl group to position 5 of the cytosine. Regulation of DNA methylation is very important, and aberrant DNA methylation could result eventually in cancer by hypomethylation or hypermethylation. DNA methylation has been considered as a stable and persistent and heritable mark. However, there has been research that indicates that there are some transcription factors and related proteins that do not only protect sequences from methylation in the first place, but also they initiate active DNA demethylation. And contrast to DNA methylation, which is the addition of a methyl group, DNA demethylation is the removal of the methyl group from the cytosines. This process can be passive or active. The passive DNA demethylation has been known to scientists and was described. However, active DNA demethylation was elusive until sometime later, until they discovered the TET family of enzymes, which is short for 1011 translocation enzymes. They are a family of 3 members, TET1, 2, and 3. They convert 5-methylcytosine to 5-hydroxymethylcytosine, which can eventually be modified to be an unmethylated cytosine. They are differentially expressed in several tissues, as well as differentially expressed in different cancer types. TET3 is our main focus in this study. Studies have shown that the role of TET3 is different from one cancer type to another, and it is predominantly expressed in oocytes, zygocytes, and neurons. TET3 is the least studied member, and so our main aims in this project were to investigate the expression pattern and functional role of TET3 and to elucidate the effect of TET3 overexpression in breast cancer cell lines under different cellular contexts. In order to do so, first we had to produce cells that are overexpressing of TET3. So first we assigned the target gene, which is the TET3. We performed digestion using restriction enzymes, and then we ligated it to the choice of the lentiviral vector. This is a picture just showing the proof that digestion was successful using the restriction enzymes that we used. After that, we had to test for successful TET3 cloning. We did mini preps with bacterial transformation with the ligated products from before. After that, we had to choose the cell line in order to infect our target gene with. So we tested the expression levels of TET3 in different breast cancer cell lines. And after that, we found that the cell line MDA-MB231, which is the last to the left, showed the least level of expression of TET3, and so it was our choice of cell line in order to do the overexpression. After that, we did transfiction, and then we infected the cells with the target gene. We infected also the same cells with empty vector genes in order to serve as the control. We then validated our successful colonies and the overexpression by testing the expression level of TET3 in both the controlled cells and the infected cells with the TET3, and then using the HA tag, we also confirmed that. Then, of course, we had to study the effect of TET3 overexpression on MDA and B231 cell phenotypes. We studied different hallmarks of cancer. We studied cell proliferation, motility, and cell migration, and cell survival. First of all, we did an XCT cell proliferation assay to study cell proliferation, and we found that TET3 overexpressing cells result in an increase in cell proliferation over the time. After that, we did wound healing assay, and we found that TET3 overexpressing cells result in a higher rate in cell migration. As we can see from the images, over time, the wound closed faster with the cells that are infected with TET3. Later, we did the cell survival assay, and we also found that overexpression of TET3 in cells resulted in an increase in cell survival. Collectively, these results show that TET3 exhibits an oncogenic behavior. To validate our results and to correlate the phenotypes to genotype, we decided to study the effect of overexpression of TET3 in other genes, target genes like oncogenes and tumor suppressor genes. Now, interestingly, the results that we obtained from this experiment were different. The expression of some genes was elevated, while the expression of some genes was downregulated, indicating that TET3 overexpression, it's not just TET3 overexpression that plays a role in this, but also we have other factors that need to be further studied. And to correlate with the Palestinian patients, breast cancer Palestinian patients, we did immunohistochemistry. We found that TET3 enzyme overexpression in breast cancer has different localizations. And it is differentially expressed in different types of cancer, meaning that, for example, in B, DCIS is a very early stage of cancer. TET3 there is not highly expressed, while when compared with the invasive type of cancer, TET3 was highly elevated when compared to normal. Lastly, we had also to correlate it with, to correlate our results with clinical outcomes. We used the Kaplan-Meier online tool. We found that high TET3 expression predicts poor prognosis in breast cancer. All the tested patients here showed that who showed overexpression of TET3 in their breast cancer showed poor prognosis and less months to live when compared to normal tissues. This brings us to the conclusion. We have, of course, we found that different expression patterns of TET3 in different cell lines and not just in different in different cell lines and cancer types. Our results also show that TET3 has an oncogenic behavior, at least in the cell lines that we studied and in the environment and the context that we studied. We also have to note out that there are other factors that need to be further studied that play a role in regulating the expression of other genes. TET3 was found recently to have isoforms, and these isoforms play a major role in the effect of the overexpression of it on the different cancers. So we need to focus on that, which brings us to the future studies. We aim to clone the different isoforms of TET3 in order to have wider and generalized vision of the whole role of and behavior of TET3 in breast cancer. We would also like to study the function of this enzyme by maybe knocking out different isoforms of TET3 and see what effects they might have on the cellular phenotypes. Thank you.
Thank you, Sundus. Do we have any questions from the panel? تفضلي دكتورة.
Thank you for your nice presentation. It's really nice and informative.
Thank you.
Did you find anything about TIT3 in other types of cancer and have the same pattern of behavior?
So TET3, as I said, is the least studied, but when it was studied, it was, for example, studied in ovarian cancer, of course, in other labs, not in our country. It was found to be, the results that they found in that study was very similar to our studies. Overexpression of TET3 in ovarian cancer, for example, resulted in poor prognosis for patients. So that's one thing. And there are, of course, other studies, but they were very minimal, and none was done on breast cancer.
Thank you.
That's why we focused.
Thank you so much.
Thank you so much.
Any other question? Thank you. Our next speaker is Dalia Abu Hilal. She's a clinical laboratory technologist at Augusta Victoria Hospital. She has a master's degree in biochemistry and molecular biology and a bachelor's degree in medical laboratory science from Al-Quds University. Dalia today will talk to us about her master's thesis entitled Microsatellite Instability and Mismatch Repair Genes Variation Testing for the Identification of Lynch Syndrome among Palestinian Colorectal Cancer Patients. Welcome, Dalia.
Thank you, Doctor, for good morning, everyone. My name is Dalia Abu Hilal. I will present to you my thesis under the title of Microsatellite Instability and Mismatch Repair Genes Variation Testing for the Identification of Lynch Syndrome among Palestinian Colorectal Cancer. As we all know, colorectal cancer, like any other type of cancer, is an abnormal growth of cells that affect the colon and rectum. Colorectal cancer is the second most common cause of cancer and the second most common cause of cancer-related deaths worldwide and in Palestine. The etiology of colorectal cancer is divided between sporadic colorectal cancer and hereditary colorectal cancer, where hereditary colorectal cancer caused by familiar colorectal cancer, Lynch syndrome, and polyposis syndromes. Our focus today is on Lynch syndrome, which is the most common cause of hereditary colorectal cancer and account for 3 to 5% of all colorectal cancer cases. Lynch syndrome is caused by a germline mutation in one of the mismatch repair genes, MLH1, MSH2, MSH6, PMS2, and EpCAM. It is inherited in an autosomal dominant pattern and patients with Lynch syndrome have 50 to 80% risk of developing colorectal cancer throughout their lifetimes. Patients with Lynch syndrome have some distinct characteristics that distinguish them from other colorectal cancer patients. These patients have an early onset of the disease. They tend to develop other extracolon tumors. The tumors of these patients are located in the proximal right side of the colon and are poorly differentiated tumors. They have high microsatellite instability, and due to the mutation in the genes of the MMR gene, they have loss of MMR protein expression in the tumors. In this study, we aim to describe the clinical and pathological characteristics of Palestinian colorectal cancer patients, to screen these patients for Lynch syndrome, to mount a platform for the genetic defects associated with Lynch syndrome, to describe the clinical and pathological characteristics of Lynch syndrome patients, to compare them with other colorectal cancer patients, and to study the pedigree of the patients identified with Lynch syndrome. To do so, we recruited 176 pathologically confirmed colorectal cancer patients from 2 of the major hospitals in the West Bank that provide cancer treatment, Augusta Victoria Hospital in Jerusalem and Bet Jala Governmental Hospital. We filled a pathology questionnaire for all these patients that describe the disease characteristics. We retrieved formalin fixed paraffin embedded blocks from the pathology archives of these two hospitals for each patient to be used in the immunohistochemistry and the microsatellite instability testing. And we collected family history for these patients to form a family pedigrees. For the immunohistochemistry, we used two antibody screening panels using antibody for MSH6 and PMS2 for all the patients. Then for patients with loss of expression of any of these two proteins, we tested the expression of MLH1 and MSH2. We also tested the expression of these two proteins for 20 patients of the patient with intact expression. Then we continued with the microsatellite instability testing. We did DNA extraction from both tumor and normal tissues. We did touchdown PCR using fluorescently labeled primers in multiplex PCR settings for 4 of the microsatellite markers in R21 and R24, in R27 and BAT25, and singleplex PCR for BAT26. Then we did fragment analysis for the PCR product to be able to assess the status of these patients. Patients were divided between high microsatellite instability if 30% or more of the markers were unstable, low microsatellite instability if only one marker was unstable, and stable microsatellite if all of the 5 markers were stable. In regard to our patients, the ratio between males and females was 1:1 between all the 176 colorectal cancer patients. The age at diagnosis ranged between 16 and 87 years old with a mean age of 57.5 years. Patients were recruited from all over Palestine, including Gaza Strip, with the majority of our patients from southern governorates, mainly from Hebron. The tumors of our patients were mainly located in the rectum, and only 12% had proximal tumors. Also, patients were diagnosed at an advanced stage of the disease. 54 patients had stage 3 colorectal cancer. 43 patients had stage 4 colorectal cancer where the tumor have metastasized to other organs. The main organ was the liver. In regard to the mismatch repair expression using immunohistochemistry, 12 patients had loss of expression of PMS2 and 1 patient had loss of expression of MSH6. These 13 patients account for 7.4% of our study population. Of these patients, 54% had a loss of expression of PMS2 and MLH1. 46% had isolated loss of PMS2, and only one patient, which account for 8%, had loss of expression of both MSH6 and MSH2. In this figure, we can see the immunohistochemistry for one patient with intact expression of both PMS2 and MSH6. Whereas in this figure, we can see the loss of expression of both MSH2 and MSH6 in the one patient we had, and an intact expression of MLH1 and PMS2. And this patient had an intact expression of both MSH2 and MSH6 and loss of MLH1 and PMS2 expression. In regard to the characteristics of the patient with the deficient mismatch repair expression, the patient were mainly females. Their age at diagnosis was similar to the other patients with a mean age of 57.2 years. Here is the major difference between these patients and the other colorectal cancer patient. As we can see, only one patient had rectal tumor, and the other patients were equally distributed between tumors in the proximal and the distal part of the colon. The tumors of these patients were majorly moderately differentiated, and only 23% had poorly differentiated tumors. And these patients, the majority of them had stage 4 colorectal cancer. Then we continue with the microsatellite instability testing. We tested all the 13 patients for microsatellite instability, and we only tested 5 of the patients with proficient MMR for microsatellite instability. Of the patient with deficient mismatch repair system, 85% had high microsatellite instability, where 2 or more markers or more than 30% of the markers were unstable. And of the patient with proficient mismatch repair system, 80% had stable microsatellite status. In this figure, we can see the fragment analysis of the 5 markers for patients with high microsatellite instability. We can see the shift in the length of the tandem repeats of the microsatellites due to the loss of the mismatch repair system. In PAT 26, we can see a gradient in the length between 170 and 180 base pairs, whereas in NR27 and the other markers, we can see a distinct shift in the length of these repeats. As we can see in NR27, it shifted from 83 base pairs to 73 base pairs. In NR21, it shifted from 110 to 99 base pairs. In NR24, it shifted from 123 to 115 base pairs. And in BAT25, it shifted from 151 to 130 base pairs. In this figure, I show the fragment analysis for one patient with a stable microsatellite status. As we can see, the fragment analysis between the tumor and the normal tissue is almost identical. This shows that there is no change in the microsatellite status between the two tissues. Whereas this patient who had a high microsatellite instability, where all the 5 markers were unstable, we can see distinctly the change between the normal and the tumor tissues. We can also see that the tumor tissue consists of both the unstable and the normal allele, mainly because the tumor tissue don't only consist of tumor cells. For the family pedigrees, we were able to interview 9 of the 13 families. Of these 9 families, 4 of them reported multiple cases of cancer among their family members. As we can see in these 2 pedigrees, multiple family members were diagnosed with different types of cancers, whereas the other 5 families did not report any cases of cancer among their family members. We can see in the first pedigree, for 4 generations, none of the family members have reported any type of cancer, even though this patient have been diagnosed at the age of 48. The next pedigree is also very interesting because this patient was the youngest among our patients. He was diagnosed at the age of 16, and also none of his family members had any type of cancer. The limitation in our study, the regional distribution was mainly located in the southern part of the country, so we almost underrepresented the northern parts. And the patient recruited were diagnosed or were at advanced stage of the disease, because the majority of our patients were recruited from Augusta Victoria Hospital, where patients are usually referred for treatment and for surgeries. We suffered from lack of medical records for some of the patients, so we were not able to use all of our variables. We were unable to confirm the diagnosis for Lynch syndrome. We only screened these patients. So in conclusion, Lynch syndrome is estimated among 7.4% of the colorectal cancer patient in Palestine. We estimate that the true Lynch syndrome patients are lower, between 1 to 2% maybe, but we need to confirm this. The majority of the patients had loss of PMS2 and MLH1 expression. The patients with deficient MMR were mostly females with similar age to other colorectal cancer patients and who were diagnosed at an advanced stage of the disease. And the majority of patients with deficient mismatch repair system had high microsatellite instability status. Our recommendation is to further test these patients to determine the exact cause of loss of gene expression, to screen all newly diagnosed colorectal cancer patients for Lynch syndrome, because this will affect the future of their families. It might also affect the treatment choices. And we also recommend to early screen family members of these patients for colorectal cancer. We really hope to help in setting policies and guidelines that encourage family members to screen for colorectal cancer as early as 20 to 25 years of age, every 1 to 2 years, and yearly after the age of 40. Thank you. I would like to use this chance to thank Dr. Rene Abser, my supervisor in the thesis, to thank Birjala Governmental Hospital, Dr. Muhammad Akal, the pathologist there, and the pathology lab team, and Dr. Nidal Jibrini. I would also like to thank Augusta Victoria Hospital, Dr. Musa Hindiya, for all his help and support throughout this research, Dr. Marwan Qabaja, the main pathologist in this study, and my colleagues in both the pathology and molecular labs. Thank you.
شكرا داليا، كثير محاضرة حلوة. في أسئلة للحضور البانل؟ أنا عندي تفضلي دكتورة.
Thank you, Dalia, for this nice presentation.
Thank you.
It's really great. Actually, I have one question. You said that the fragment analysis was identical between the tumor and the normal tissue.
Yes.
So can you please explain more?
What to explain?
يعني ايش السبب انه كان identical بين
هو لا هلا بنحكي انه بالستيبل البيشنت عندهم ستيبل مايكروسيلايت ستاتس كان identical، انه هيك المفروض انه انت لما تقارن نورمال تيشو فيها المس ماتش ريبير سيستم شغال رح يكون عماله بيصلح الاخطاء اللي عمالها بصير خلال الريبليكيشن للدي ان اي زيه زي النورمال تيشو، فهو اكسبكتد انه يكون نورمال عشان نقدر انه لا انه نحكي انه هذا المايكروسيلايت از ستيبل وانه المس ماتش ريبير سيستم شغال صح وعماله زي ما بظبط في التيومر تيشو عماله بصلح بالنورمال تيشو.
I have two questions. The first question is just to make sure for testing all these patient samples, you got the ethical consent forms. You asked for consent forms from the patients to do the study, or did you get consent forms from the hospitals to do the study?
Yeah, we did the ethical committee from the university and from both the Ministry of Health and Augusta Victoria Ethical Committee.
Okay. And the other question is to go back to Doctora question. With regard to the fragment analysis, did you do a positive control for the samples? Did you have a positive control to make sure that the test is running correctly?
No, but we did sequencing for the 5 markers to be sure that we are actually using or we are replicating the right or the correct repeats or the region on the DNA.
Okay, good. Thank you.
Thank you.
Thank you so much.
Okay. Our next speaker is Hadir Nasser Abu Warda. She asked us to introduce her in Arabic. So Hadir حاصلة على درجة الماجستير في العلوم الطبية المخبرية وعلى درجة البكالوريوس في الكيمياء الحيوية من الجامعة الإسلامية بغزة. عملت سابقاً كمعيدة في قسم الكيمياء الحيوية وفي مجال البحث العلمي في مختبر الوراثة الطبية في الجامعة الإسلامية. Her presentation is investigating aneuploidy inducing effect of Nemacure, Roger, and Dorbes in human peripheral blood lymphocyte cultures. So please go ahead, Hadir. You are welcome.
السلام عليكم ورحمة الله وبركاته. يعطيكم العافية جميعا. عنوان الدراسة اللي سأتحدث عنها الآن إن شاء الله Investigating aneuploidy inducing effect of Nemacure, Roger and Dorspan in human peripheral blood lymphocytes cultures. هذه الدراسة نشرت مؤخرا في مجلة Environmental and Molecular Mutagenesis بإشراف الأستاذ الدكتور فضل الشريف. بداية الأورجانوفوسفات هو أحد المركبات الأساسية في البستيسايد. العديد من الدراسات السابقة أوضحت بأنه هناك علاقة ما بين الاستخدام المفرط للأورجانوفوسفات والعديد من المشاكل الصحية، من أبرزها الكانسر والزهايمر والبيرث ديفكت. في قطاع غزة الأكثر أنواع الإنسكتيسايد استخداما ما بين المزارعين هي الأورجانوفوسفات. من خلال تتبع سجلات وزارة الزراعة لمعرفة أكثر أنواع الأورجانوفوسفات المستخدمة للفيناميفوس والدايميثويت هي النيماكور أو الفيناميفوس، والروجور أو الدايميثويت، والدورسبان أو الكلوربيرفوس. على الرغم من أن هناك العديد من الدراسات التي تؤكد الجينوتوكسيك إفكت للفيناميفوس والدايميثويت إن فيترو، إلا أنه لا يوجد دراسات سابقة بتوضح تأثيرها من تأثير الاندكشن اوف انابلويد لهذه المبيدات سواء ان فيترو او ان فيفو. اما بالنسبه للكلوربيرفوس يوجد دراسات لكن عددها قليل بتبين بانه له انابلويد اندكشن افكت في الهيومن بريفرال بلاد ليمفوسايت كلتشر. لذلك كان الهدف العام من دراستنا هو أن ندرس تأثير هذه المبيدات الثلاثة أو المبيدات الأكثر استخداما في قطاع غزة على قدرتها على السلام عليكم ورحمة الله وبركاته. يعطيكم العافية جميعا. عنوان الدراسة اللي سأتحدث عنها الآن إن شاء الله Investigating Aneuploidy-Inducing Effect of Pneumococcal, Rugor and Durspan in Human Peripheral Blood Lymphocytes Cultures. هذه الدراسة نشرت مؤخراً في مجلة Environmental and Molecular Mutagenesis بإشراف الأستاذ الدكتور فضل الشريف. بداية الأورجانوفوسفات هو أحد المركبات الأساسية في البستيسايد. العديد من الدراسات السابقة أوضحت بأنه هناك علاقة ما بين الاستخدام المفرط للأورجانوفوسفات والعديد من المشاكل الصحية، من أبرزها الكانسر والزهايمر والبيرث ديفكت. في قطاع غزة الأكثر أنواع الإنسكتيسايد استخداماً ما بين المزارعين هي الأورجانوفوسفات. من خلال تتبع سجلات وزارة الزراعة لمعرفة أكثر أنواع الأورجانوفوسفات المستخدمة في قطاع غزة، كانت الثلاث أنواع الأكثر استخداماً هي النيماكور أو الفيناميفوس والروجور أو الدايميثويت والدورسبان أو الكلوربيرفوس. على الرغم من أن هناك العديد من الدراسات التي تؤكد الجينوتوكسيك إفكت للفيناميفوس والدايميثويت إن فيترو، إلا أنه لا يوجد دراسات سابقة بتوضح تأثيرها من تأثير الاندكشن اوف انابلويدي لهذه المبيدات سواء ان فيترو او ان فيفو. اما بالنسبه للكلوربيرفوس يوجد دراسات لكن عددها قليل بتبين بانه له انابلويدي اندكشن افكت في الهيومن بريفرال بلاد ليمفوسايت كلتشر. لذلك كان الهدف العام من دراستنا هو أن ندرس تأثير هذه المبيدات الثلاثة أو المبيدات الأكثر استخداماً في قطاع غزة على قدرتها على الانابلويدي اندكشن في خلايا الهيومن بريفرال بلاد ليمفوسايت كلتشرز. أما عن أهمية هذه الدراسة فتنبع أهميتها من أنه إيجاد علاقة ما بين الإكسبوجر للأورجانوفوسفات بيستيسايد والاندكشن اوف انابلويدي في الهيومن بريفرال بلاد ليمفوسايت كلتشر، فهذا بيساهم في تفسير السبب في زيادة الانسيدنس أو البريفالنس للبيرث ديفكت، من أمثلتها مثلا متلازمة داون في قطاع غزة، والتي تنتج من خلل في الكروموسومات مثلا الانابلويدي. ريسيرش ميثودولوجي لهذه الدراسة. بداية قمنا بهذه الدراسة في مختبر الوراثة ومختبر السيل كلتشر في الجامعة الإسلامية. تم أخذ موافقة بالنسبة للتراكيز اللي تم استخدامها لتخدم الأكتيف إنجريدينتس لهذه الأورجانوفوسفات، وإحنا المتوفر عندنا الكوميرشال فورموليشن منها، فكان من اللازم إن نعيد ونعمل سايتوتوكسيسيتي تيست لهاي التراكيز اللي تم اختيارها لثلاث أنواع من الأورجانوفوسفات النيماكور والروجور أند دورسبان بواسطة الMTTSA. في الجدول التالي بوضح التراكيز اللي تم استخدامها. طبعا استخدمنا ثلاث تراكيز من النيماكور، ثلاث تراكيز من الروجور، ثلاث تراكيز من الدورسبان. بالإضافة إلى ذلك المذيب اللي استخدمناه في تحضير هاي الأورجانوفوسفات هو DMSO، فاستخدمناه كسولفنت كنترول. استخدمنا التاكسول كبوزيتيف كنترول، أو يعني إنه هو معروف عنه unbloid inducing agents. في البداية تم فصل الهيومن بريفرال بلاد ليمفوسايتس باستخدام الليكوبريب ليمفوسايت سيبريشن ميديا، وبعد ذلك عملنا الMTTSA حسب يعني الخطوات المعروفة. الMTTSA كان إما إنه يكون على الفور بعد الإكسبوجر للبستيسايد أو بعد 18 ساعة من الانكيوبيشن، لتكون نفس الظروف اللي حنعمل فيها حيتم تجربة تقييم الانابلويدي في الهيومن بريفرال بلاد ليمفوسايت كلتشر. بالنسبة للتقييم اللي هي الانابلويد أو investigating الانابلويد inducing effect لهاي المبيدات، بالبداية عملنا كلتشر للليمفوسايت، تم الانكوبيشن 24 ساعة، فيما بعد كان التريتمنت في البستيسايد، وبعد هيك 18 ساعة انكوبيشن، وبعد هيك هارفست واستكمال الخطوات الفيش اناليسيز فلوريسنس ان سيتو هايبرديزيشن تكنيك كما هو معتاد، فرد السلايدات وهايبرديزيشن مع البروب، وبعد هيك اناليسيز تحت الفلوريسنس مايكروسكوب لكل تركيز من التراكيز اللي اخترناها كنا نعمل 2 cultures، ومن كل عينة كنا في كل سلايد نقرأ 400 خلية، ونقيم الخلية هل هي أنبلويد أم لا، من خلال اللي هي كما هو واضح في الشكل. يعني اللي بالنسبة للأوتوزوم الكروموسوم الواحد مفترض يكون فيه نسختين، مثلا في اللون الأخضر هاي نورمال ديبلويد سيل. أما إذا كان في عدد اللي هي غير طبيعي، مثلا بالنسبة لهذا الكروموسوم بالبروب الأخضر كان معطي 3 اللي هي 3 سيجنالز، هاي يعتبر كروموسوم جين أو في هاي الحالة ترايزومي. إذا كان اللي هي عدد أقل من اللي هي نسختين فإنه بيكون كروموسوم لوس أو مونوزومي. داتا أناليسيس تم استخدام ال SPSS سوفت وير، وبالنسبة لل MTTSA استخدمنا Independent Sample T-Test، وبالنسبة للفيش أناليسيس تم استخدام الكاي سكوير تيست، وجميع النتائج اعتبرناها ذات دلالة إحصائية إذا كانت قيمة البي فاليو أقل من 5%. أما بالنسبة للنتائج لهذه الدراسة، فالجدول الأول بوضح نتائج ال MTTSA بعد 0 تايم من الانكيوبيشن وبعد 18 ساعة من الانكيوبيشن للتراكيز المختلفة اللي احنا استخدمناها. من النتائج اللي هي بدل أو الجدول بيعطينا صورة بأنه السيلفيابيليتي أو السيتوتوكسيسيتي للبستيسايدز المستخدمة ما كانتش يعني أو السيلفيابيليتي لم تقل اللي هي بشكل واضح عن ال DMSO solvent control، إلا أنه في بالنيماكور بعد الانكيوبيشن 18 ساعة كان في انخفاض في السيلفيابيليتي. وعلى الرغم من أنه في انخفاض وذات دلالة إحصائية، إلا أنه هذا الانخفاض لا يؤدي إلى أحداث excessive cytotoxicity، يعني حسب الإرشادات المعمول فيها لتقييم السيتوتوكسيسيتي. فلذلك تم اعتماد هذه التراكيز، وفيما بعد اللي هي قمنا بدراسة تأثيرها أو مقدرتها على إحداث الأنبلويدي في الهيومن بريفرال بلاد ليمفوسايت كلتشر. ففي الجدول التالي بيوضح اللي هي الفريكونسي للأنبلويدي والكروموسوم لوس والكروموسوم جين في الكالتشرز الخاصة بالنيجاتيف كنترول. نيجاتيف كنترول طبعا مزارع مش معالجة بأي شيء، DMSO مزارع معالجة بالDMSO اللي هو solvent control، وتاكسول البوزيتيف كنترول، وتراكيز 3 من النيماكور. هاي باستخدام بروب مخصص لكروموسوم 21. وفي دراستنا احنا استخدمنا كروموسوم 21 وكروموسوم 16 لأنها هي من أكثر الكروموسومات اللي بيحدث فيها أنبلويدي. بالملاحظة في الجدول نجد إنه جميع التراكيز بالنسبة للتاكسول والنيماكور أدت إلى زيادة في الفريكونسي للأنبلويدي، وفي بالنسبة لل5% ملي جرام من لكل مليليتر من النيماكور أدى إلى زيادة تركيز بشكل والاختلاف كان ذو دلالة إحصائية عن ال DMSO. بالنسبة للكروموسوم لوس، من الملاحظ بأنه جميع نتائج الكروموسوم لوس لجميع التراكيز المستخدمة كانت أعلى من الكروموسوم جين، وفي بعض منها كان اللي هي significant أو الاختلاف ما بينه وبين ال DMSO كان significant. بالنسبة للجدول التالي هو بوضح نفس الشيء الأنبلويدي والكروموسوم لوس والكروموسوم جين بالنسبة للروجور والدورسبام مع المقارنة مع DMSO، هاي باستخدام بروب مخصص لكروموسوم 16. هان نفس الشيء انه في زياده في الفريكونسي الانبلويدي، لكن ما كانش في اي زياده ذات دلاله احصائيه. وايضا بنلاحظ بان الكروموسوم لوس كان اكثر بكثير من الكروموسوم جين. بالنسبه للدسكشن، طيب الآن بالنسبة لمناقشة النتائج، النتائج اللي حصلنا عليها وهي إنه جميع التراكيز تؤدي إلى زيادة في الفريكونسي للأنبلويدي، بالإضافة إلى ذلك بأن الكروموسوم لوس أكثر من الكروموسوم جين. هذه النتائج كانت تتوافق مع نتائج دراسات سابقة تمت على هاي الأنواع من الأورجانوفوسفير، وتمت على الهيومن سيل لاينز أو كالتشرد هيومن ليمفوسايت، يعني تقريبا في نفس الظروف. بالنسبة للكروموسوم لوس اللي لاحظنا بأنه في زيادة عن الكروموسوم جين، فهي أيضا اللي هي ما تم ملاحظته من خلال نتائج دراسات سابقة. وزيادة الكروموسوم لوس يعني أن هناك ميكانيزم لإحداث الأنبلويدي غير عن الميكانيزم المعروفة اللي هي non-disjunctional ميكانيزم أو event. مثلا في الوضع الطبيعي يتم انقسام الكروموسومات أو انفصالها، وفي الخلايا الناتجة بيكون في عدد متساوي من الكروموسومات. في وضع النون ديسجنكشن في إنه إذا في خلل في الانقسام ففي خلية بيكون فيها نقص، وبالمقابل خلية بيكون فيها زيادة أو بيكون في تساوي بالكروموسوم لوس مع الكروموسوم جين في نفس الكالتشر. لكن يبدو أن هناك ميكانيزم آخر بيحدث في يحدث في أو يسبب الأنبلويدي غير عن الميكانيزم المعروفة. أحد الفرضيات اللي بتفسر هاي زيادة الكروموسوم لوس هو تكوين المايكرونيوكلاس، والمايكرونيوكلاس هي نواة صغيرة بتكون بجانب النواة الرئيسية يعني في النواة وفي الخلية. وهاي المايكرونيوكلاس أحد أسباب مكوناتها هو وجود تأخير في انفصال السنترومير للكروموسومات، وبالتالي اللي هي بتنفصل الكروموسومات بوضع غير طبيعي، بحيث إنه في خلية بيكون فيها نقص والخلية الأخرى بيكون فيها زيادة، وهاي الزيادة بتكون داخل المايكرونيوكلاس على شكل كروموسومات مدمرة أو ممكن هول كروموسوم. إحداث التفسير المايكرونيوكلاس إنه هي ممكن تكون فرضية اللي سببت لزيادة الكروموسوم لوس، بيدعموا بإنه في دراسات سابقة أوجدت بإنه الإكسبوجر للأورجانوفوسفات بيستيسايد بيزيد من الفريكونسي للمايكرونيوكلاس. وهذا أيضا بتوافق مع ما وجدناه خلال اللي هي دراستنا، بأنه على الرغم من أنه لم يكن أحد أهدافنا أن نشوف المايكرونيوكلاس، إلا أنه لاحظنا بأنه في زيادة في الفريكونسي للمايكرونيوكلاس خاصة في النيماكور والروجور تريتد كالتشرز، يعني مثل ما هو واضح شكل هاي النواة الرئيسية وهاي المايكرونيوكلاس. سبب آخر أو تفسير آخر تفسير آخر لزيادة الكروموسوم لوس هو ممكن يكون في سبب limitation للفيش تكنيك، منها signal overlap أو hybridization failure. في الختام احنا بنحكي إنه جميع التراكيز المستخدمة من الأنواع ثلاثة من البستيسايد أحدثت أنبلويدي، وأيضا إنه الكروموسوم لوس كان أعلى من الكروموسوم جين. التوصيات بإنه نزيد الانفستيجيشن على عينات أعداد أكبر لتأكيد الأسوشيشن ما بين الإكسبوجر للأورجانوفوسفات بيستيسايد والإندكشن للأنبلويدي.
Okay, thank you, Hadir. Is she with us? She's online. Or is there any question? Please, Dr. Rania.
يعطيك العافية هدير. Thank you على informative lecture. It's really a very nice lecture. I have like two questions. اختيارك كان للpesticides اللي you have investigated كان based on إنه هاي البستيسايدز مستعملة في غزة، وكمان اختيارك للconcentrations لأنه يعني في دراسات إحنا كمان عملناها وعملنا real measurements للorganophosphates بس على human samples، ولقينا real association بين الريسك للليمفوما وبدوس relationship يعني dose dependent relationship مع الكانسر ريسك. could you please إنه give me an idea ليش اخترتي هدول الأنواع بالذات، وكيف اخترتي الconcentrations، وهل في غزة في دراسات كمان على يعني serum samples؟
يعطيكم العافية جميعا. شكرا دكتورة رانيا على سؤالك اللي هو احنا اخترناها طبعا لأنها أكثر أنواع الأورجانوفوسفات المستخدمة في قطاع غزة حسب سجلات وزارة الزراعة في آخر 3 سنوات في قطاع غزة. التركيز كانت بناء على التركيز المستخدمة في دراسات سابقة. هم استخدموا الأكتيف إنجريدينت لهاي الأورجانوفوسفات، وإحنا بناء على التراكيز اللي هم استخدموها إحنا اخترنا التراكيز اللي راح نستخدمها بدراستنا. وأنا وضحت إنه إحنا بعد اختيار هاي التراكيز لأنه إحنا استخدمنا الكوميرشال فورميليشن عملنا لها السيتوتوكسيسيتي، فالتراكيز اخترناها بناء على دراسات سابقة. هيك بيكون وضح
و it will be nice يعني إذا بتروحوا للسكند فيز من البروجكت اللي فعلا تعملوا real measurements على بما إنه هاي pesticides مستعملة بهاي ليفل بغزة، انه تروحوا على real human samples بالذات الناس اللي بتشتغل بالاجريكلتشر وتعملوا measurements للليفل of organophosphates وتشوفوا انه هدول الناس قد ايه عندهم يعني they suffer from any type of cancer لانه هي risk factor لكثير من انواع الكانسر. ويعطيك العافيه وجد شكرا على المحاضره الحلوه.
الله يعافيكي، شكرا على الإضافة. إن شاء الله رح نعمل بالإضافة اللي حكيتيها.
Okay. Our next speaker is Professor Abdelraouf El-Maname. He is a professor in microbiology in the Islamic University in Gaza. He's going to present antimicrobial resistance of bacteria contaminating mobile and fixed phone at the European Gaza Hospital. So you are welcome, Dr. Abdelraouf.
السلام عليكم ورحمة الله وبركاته. شكرا لكم للاستضافة في هذا المؤتمر القيم ونرجو لكم التوفيق إن شاء الله. عنوان البحث لهذه المحاضرة هو Antimicrobial Resistance of Bacteria Contaminating Mobile and Fixed Phone at the European Gaza Hospital، وهو من إعداد كل من حنان فياض ومحدثكم دكتور عبد الرؤوف. الهواتف المحمولة والهواتف الذكية على وجه الخصوص هي واحدة من أكثر الأشياء التي يحملها الناس معهم في حياتهم الشخصية وحياتهم المهنية في هذه الأيام، ويمكن للأشياء الجامدة بشكل عام ذات الاتصال اليدوي المباشر أن تشكل أو أن تكون بمثابة مخازن للميكروبات تنتشر من خلالها مسببات الأمراض إلى أيدي مقدمي الرعاية الصحية أو ما يعرف بالهيلث كير ووركرز، ثم إلى المرضى، ثم إلى الزوار أيضا للمشاكل. تشمل الأمثلة على هذه الأشياء مثل الأجهزة الطبية مثل السماعات وغيرها من الملحقات، ويتصدر المشهد في هذه الأثناء الهواتف النقالة. قد تعمل الهواتف النقالة أو المحمولة للعاملين في مجال الرعاية الصحية كمستودعات للعدوى كما ذكرنا في اللوحة السابقة، وخاصة في المستشفيات. ويرتبط تلوث الهواتف المحمولة للعاملين الصحيين ارتباطا وثيقا بتلوث بيئة الرعاية الصحية وعدوى المشاكل، وهذا يعني يتزايد وجود evidence عليه في الأبحاث يوما بعد يوم. لابد أن نتذكر بأن العبء العالمي للهيلث كير اسوشيتد انفكشن او ما يعرف بالاتش اي اي عمال بيتصاعد وفي ازدياد، وبيساهم بشكل كبير في زياده المرضى والوفيات. ايدي العاملين في القطاع الصحي تلعب دورا هاما في نقل الامراض المنقوله في المستشفيات، وقد تشكل الهواتف المحموله خطرا على انتقال البكتيريا المقاومه للمضادات الحيويه، والجميع يعرف ان المستشفيات هي بيئه خصبه لهذه الانواع من الميكروبات. وهناك ادله متزايده كما ذكرنا على ان الهواتف النقاله والهواتف حتى الثابته تشكل مصدر لتلوث ببكتيريا مثلا الستافيلوكوكس اوريوس، وهي خاصه الميثيسيلين ريزيستنت ستافيلوكوكس اوريوس، وايضا العديد من الجرام نيجاتيف بكتيريا اللي من صفاتها انها مالتي دراج ريزيستنت جرام نيجاتيف باسيلاي. وعلى هذه المقدمه نستطيع القول بانه اعطاء بيانات تخص مدى وانواع الميكروبات اللي موجوده على الموبايل فون وعلى الفون بشكل عام في المستشفيات قد تكون ذات قيمة تساهم في المجهودات التي تحاول أن تقلل من الهيلث كير اسوشيتد انفكشن. أيضا السياسات المستشفيات والإجراءات المتخذة في المستشفيات قد تستفيد من مثل هذه الدراسات ومن مثل هذه البيانات. الهدف الرئيسي كان من هذه الدراسة الحقيقة هو كما ذكرت تحديد أنواع البكتيريا بعد تحديد مدى تلوث الهواتف النقالة والهواتف الثابتة تحديدا للعاملين في القطاع الصحي في مستشفى غزة الأوروبي. بالإضافة إلى ذلك قمنا بجمع بعض العينات كما سنرى بعد قليل من الزائرين لهذا المستشفى. قمنا أيضا بالتعرف على الانتي ميكروبيال ريزيستنس للبكتيريا. أهمية هذه الدراسة تكمن بأنه احنا بنقول دائما أنه مشكلة موصفة بشكل جيد يعني هي نصف محلولة يعني، وهذه الدراسة كان هدفها الرئيسي بالفعل أنه تزود صانعي القرار ببيانات حول مدى تلوث ونوع الميكروبات، وهذا يعطي صانع القرار يعني إمكانية اتخاذ القرار المبني على الدليل أو المبني على البرهان، وهنا مكمن أهمية هذه الدراسة. طريقة العمل اللي اتبعناها في هذه الدراسة جمعنا 230 عينة موبايل فون، 59 من الممرضين، 52 من الأطباء، 52 من العاملين في النظافة في المستشفى، و50 عينة من الزوار في المستشفى، بالإضافة إلى 51 تليفون أو هاتف ثابت من محطات مختلفة من المستشفى، مستشفى غزة الأوروبي. وأيضا قمنا بعمل استبانة أو كويشنير، لكن لن نعرض نتائجها لضيق الوقت في هذه الدراسة. المسحات أو العينات كانت عبارة عن مسحات 3 سم 3 سم من اسطح الموبايل من خلال استخدام ستيرايل سواب ويتد وذ نورمال سلاين. هذا السواب تم نقله الى الميكروبيولوجي وتم زراعته على اوساط مختلفه لعد البكتيريا الكلي ولعد الفطريات ولعزل انواع محدده من الميكروبات مثل الستافيلوكوكس اوريوس، الجرام نيجاتيف بكتيريا والانتيرو. تم التعرف على الميكروبات من خلال الكونفنشنال مايكروبيولوجيكال تكنيك زي البايوكيميكال تيست، وبعض الاحيان لجأنا الى استخدام الاي بي اي 20 اي للجرام نيجاتيف بكتيريا تحديدا. بعد ما عزلنا وعرفنا الميكروبات قمنا بتحديد اللي هو البروفايل الانتي ميكروبيال ريزيستنس بروفايل لهذه الميكروبات، وتم حساب المار اندكس او المولتيبل انتي بايوتيك ريزيستنت اندكس لكل بكتيريا تم عزلها من هذه العينة. وكانت النتائج كالتالي: حوالي 87.1 من العينات اللي تم عزلها احتوت على ميكروبات، يعني اما فطريات او بكتيريا. وطبعا هذا الامر يعني متوقع ان يكون نسبه حتى اعلى من ذلك ان تكون يعني محتويه على الميكروبات، لان هنا نقول وجود او عدم وجود ميكروب، وهذا سطح يلامسه الجلد بشكل مستمر، وبالتالي متوقع ان يكون موجود عليه ميكروب. وعزلنا من العينات كل من الجرام بوزيتيف والجرام. كان اهم العزلات اللي عزلناها الكواجوليز نيجاتيف ستافيلوكوكاي، شكلت تقريبا 33.3 من العينات، والستافيلوكوكس اوريوس شكلت 18%. ايضا سودوموناس ايريجينوزا شكلت حوالي 10.2%. الانتيروكوكس كانت 13.7%. الاشريشيا كولاي 4.3%. الكليبسيلا 6%. والاسينيتوباكتر 14.5%. انا يعني يمكن في اللوحه السابقه قللت من شان وجود نسبه مرتفعه من التلوث على الاسطح، لكن في هذه اللوحه نؤكد على اهميه انواع الملوثات. نحن نتحدث عن اسينيتوباكتر، ولو شفنا النتائج تبعت الانتي ميكروبيال ريزيستنس بعد قليل حنشوف انه فيها مالتي دراج ريزيستنت، الستافيلوكوكس اوريس كذلك الامر، الانتيروكوكس، السودوموناس ايرينوزا. كل هذه الاسماء هي اسماء لامعه كنوزوكوميال باثوجين او هيلث كير اسوشيتد انفكشن، وبالتالي هنا تكمن الخطوره في تلوث الموبايل فون للعاملين في القطاع الصحي او حتى للزائرين بشكل. ربما يمكن كان في عمليه تحليل لبعض النتائج، وحاولنا نشوف اللي هو الجوب ديستريبيوشن، يعني توزيع المهن ومدى التلوث. لقينا انه بالفعل في وجود يعني significant correlation او significant difference ما بين النيرس والفيزيشن والكلينر والفيزيتور. الفيزيتور كان نسبه التلوث عندهم 100%، عفوا 96%، بينما الفيزيشن كان هم الاقل 75%. هذا بعطينا مؤشر انه في تفاوت ايضا في عمليه الهايجين براكتسز ما بين الديفرنت بروفيشنز في المستشفى. اختلفت ما بين الكلينر وما بين النيرس، ما بين ايضا الفيزيشن، بالاضافه للاختلاف الكبير مع الفيزيشن. اذا بنلاحظ هنا الديبارتمنت او توزيع النيجاتيف والبوزيتيف على الديبارتمنت، لو طلعنا على طبعا النسبه الاعظم احنا قلنا من الموبايل فون كانت بوزيتيف، وبالتالي حنجد انه كل الديبارتمنت فيها نسبه عاليه من البوزيتيف. لكن لو لاحظنا بنطلع على السيرجيكال ديبارتمنت وبنطلع على الاي سي يوز، بنتكلم على 92.5 من الموبايل فون اللي اخذت من العاملين في هذه الديبارتمنت كانت بوزيتيف، وتلاها قلنا اللي هو الباراميديكال ديبارتمنت، الامرجنسي روم، كلهم يعني كلهم احتووا على نسب مرتفعه من الكونتامينيشن، وهذا يعني بشكل خطوره كبيره على العاملين في القطاع، عفوا على المرضى وعلى الزوار وايضا حتى على العاملين في القطاع. ايضا هنا بنشوف ان مدى وجود الفروقات ما بين الديبارتمنت وما بين الجندر والوظيفه. لقينا انه الديبارتمنت في فروقات ذات دلاله معنويه في عدد البكتيريا الموجوده او المتواجده على الموبايل فون وبالنسبه للوظائف، لكن بالنسبه للجندر ميل وفيميل ما كان في اي فروقات ذات دلاله معنويه. اذا هنا نسجل في هذه اللوحه بانه هناك فروقات ذات دلاله احصائيه معنويه بين الاقسام المختلفه وبين اللي هم الوظائف المختلفة في المستشفى، لكن الميل والفيميل لم يكن بينهم فروقات ذات دلالة معنوية. أيضا في الفنجل كاونت يعني كان في النسب مرتفعة الحقيقة، لكن لم نجد فروقات ذات دلالة معنوية لا في الجندر ولا في الديبارتمنت ولا في الجوبز. لو طلعنا على المار اندكس، والمار اندكس هو يعني اندكس يتم حسابه من خلال عدد الانتيبيوتيك اللي كانت ريزيستنت بالمقارنه مع كل الانتيبيوتيك اللي تم فحصها للميكروب. غالبا في اعتبار بانه اذا كان المار اندكس اعلى من 0.2 فهذا يعني مولتيبل دراج ريزيستنت، اذا اقل من 0.2 بيكون لا مش مولتيبل دراج ريزيستنت. نلاحظ اللي اكثر من 0.2 حنلاقي انه معظم العزلات السودوموناس ايريجينوزا الايكولاي والكليبسيلا سبيسي والاسنيتوباكتر الستافيلوكوكس اوريوس الانتيروكوكس الغالبيه العظمى كانت above 0.2. هذا بيعطينا مؤشر قديش الدراج ريزيستنس في العزلات اللي تم الحصول عليها من الموبايل فون. ايضا هنا نتحدث عن نسب الريزيستنس اللي موجوده والمار اندكس سبيسيفيكالي للكليبسيلا على سبيل المثال هنلاقي انه 0.7 وهو الاعلى على الاطلاق، الاسينيتوباكتر 0.6، سودوموناس ايريجينوزا 0.5 والانتيروكوكس 0.4. يا جماعه احنا بنتكلم هنا على عزلات مش من مرضى، عزلات من موبايل فون من مستشفيات وتمتلك هذا المار اندكس المرتفع. هذا مؤشر خطير للغايه وبينم على انه البيئه في المستشفى بيئه خطيره، وايضا الموبايل فون بتشكل يعني خطر حقيقي على كل من المرضى والعاملين في القطاع. الريزيستنس للايزوليت بشكل عام كان اعلى ريزيستنس اجينست اموكسيسيلين، تلا اللي هو الفيبراسيلين والامبيسيلين، لكن الليست ريزيستنس كان اجينست ستريبتومايسين وللكوليستين. ولاحظوا الكوليستين اللي هو يعتبر by many as the last resort for carbapenem resistant enterobacteriaceae معطينا حوالي 11.1% كوليستين ريزيستنس. الريفامبيسين والتيكوبلانين ايضا كان فينا ارقام متواضعه لكنها تؤشر او تنذر بخطر شديد في المستقبل. ونقفز الى الكونكلوجن مباشره، وفي الكونكلوجن نستطيع القول بانه كل من الموبايل فون اللي يمتلكها الهيلث كير وركرز والفيزيتورز وكمان الفيكس فون في مستشفى غزه الاوروبي كان فيها نسب معينه من التلوث وتلوثت بجرام بوزيتيف وجرام نيجاتيف بكتيريا. النتائج اظهرت بانه اعلى مستوى للريزيستنس كان ضد الاموكسيلين 100% وبيبراسيلين 95% و89.1 للامبيسيل. والليست ريزيستنس كان زي ما ذكرنا في لوحه سابقه هو كان ضد الستريبتومايسين والكوليستين الريفامبين والتيكوبلانين. يعني هذه الانتي بايوتكس او الانتي ميكروبيالز ما زالت يعني فعاله بنسب مرتفعه قد تصل الى 85 الى 90%. من ال 117 عزله اللي تم الحصول عليهم 83.5 عزله بالمئه، يعني 96 عزله تم تصنيفهم على انهم MDR من خلال حساب اللي هو المار اندكس اللي حكينا عنه قلنا above point. الهاي بريفالنس ريت للريزيستنس باترن تم ملاحظتها في كل من الجرام نيجاتيف بكتيريا للجنتاميسين للميروبنين للاميكاسين وتازوباكتام بيبراسيلين وسيفوكسيتين بالاضافه الى الترايميثوبريم سلفاميتازول ودوكسي سايكلين. يعني خياراتنا آخذة بالفعل بالنفاذ لهذه المضادات. أيضا لدينا من الاستنتاجات أو من النتائج اللي رغبنا في إبرازها إنه الموبايل فون بهذه النسب من التلوث يعني احنا بنعتقد انها كان act as a vehicle for the transmission of antimicrobial resistant bacteria للهيومن population. وانا اقول هنا human population سواء كان للعاملين في المستشفى او للمرضى المنومين او حتى للزائرين، وبكل سهوله في ظل غياب يعني infection control practices من السهل جدا انه حتى هذه الميكروبات تنتقل من المستشفيات الى خارج المستشفيات الى المجتمع. ايضا كان يعني واضح لنا انه الهيلث كير وركر بيستخدموا الموبايل فون فور educational purposes. هذا من خلال الاستبانه اللي احنا ما عرضنا نتائجها. طبعا هذا الاستخدام هو استخدام طيب وجيد، لكن للاسف يعني عندما يكون في مسيوز للموبايل فون يمكن ان يسبب هازارد كثيره للبشر. الوجود ريزيستنت ميكروب تم اكتشافه بشكل لا لبس فيه على الموبايل ديفايس لكثير من الاطباء والنيرسز في الانتنسيف كير ديبارتمنت، وانتم عارفين قديش المرضى في هذه الديبارتمنت بيكونوا فولنربل تو انفكشن، وبالتالي بنعمل عمليه كومبليكيشن احنا لهؤلاء المرضى وبنقلل من فرص شفائهم وبنزيد من المكوث في المستشفى، وهذا ايضا يؤدي الى تكلفه اعلى في المستشفى. توصياتنا يمكن الصوره بتعبر عن معظم التوصيات اللي هنتكلم فيها، انه cleaning للموبايل should be يعني one of the policies. screening للموبايل بشكل عام، يعني ممكن الانفكشن كنترول كوميتيز في المستشفيات انها تعمل راندوم تشيك على الموبايل للعاملين في القطاع الصحي، عشان يكون في عندنا نوع من الرقابه واشعار العاملين باهميه عمليه تنظيف هذه الموبايلات. ايضا اذا في امكانيه انه نستخدم ما يسمى بالهاند فري موبايل فون، يعني باستخدام الاوامر الصوتيه اذا كان الموبايل فون ضروره من ضرورات العمل، فنستخدم الاوامر الصوتيه بدل اللي هو اللمس، حتى نقلل من الحاجه الى تبادل الميكروبات بين ايدي العاملين وهذا السطح المهم اللي هو سطح الموبايل. ايضا نحن بحاجه الى يعني تطوير انظمه باستخدام وتنظيف او تعقيم وتطهير الموبايل فون، خاصه في المناطق الحرجه زي الاي سي يو زي السيرجيكال يونتس. ايضا كمان لازم يكون في عندنا حملات يعني قويه لتوضيح انه الموبايل فون قد يعمل كناقل للامراض المعديه سواء كان في المجتمع او في المستشفى. الهواتف النقاله يجب ان، وخاصه للعاملين في القطاع الصحي او تلك التي قد يعني يظن انها قد تعرضت لكونتامينيشن، يجب ان تحفظ بعيدا عن الاطفال وعن ذوي المناعه المنخفضه. ايضا ننصح بريجولار كليننج، تنظيف بشكل منتظم للفون باستخدام suitable cleaning fluid. وربما لو قرأنا الانسرت اللي موجود مع الموبايل فون او التعليمات هيعطينا يعني كيفية التطهير لهذه الموبايل. ايضا نتائجنا في هذه الدراسة بتحتم علينا انه نعمل maintaining او maintenance ل good hygienic practices by the members of the above mentioned group اللي ذكرناهم كلهم، اللي هم الفيزيتورز والمرضى نفسهم، بالاضافه الى العاملين في القطاع الصحي. هذا الكلام عشان نمنع اللي هو السبريد من الانتي ميكروبيال ريزيستنس بكتيريا للهوسبيتال سيتنج والكوميونتي. في النهايه يمكن نحن محتاجين ايضا الى مور ريسيرش، ديبر ريسيرش، عشان نقدر بالفعل نعمل نوع من الكورليشن ما بين الانكريز للانفكشن والاستخدام الخاطئ للموبايل فون. وفي الختام اتقدم لكم بجزيل الشكر وبارك الله فيكم والسلام عليكم ورحمه الله وبركاته. السلام عليكم ورحمه الله.
Thank you, Dr. Abdurraouf, for this wonderful presentation. Is he with us? Is he online, Dr. Abdurraouf? No. Unfortunately, he is not with us. So if you have any question, you can send messages and we can deliver it. Okay, thank you. Now we have a break, yeah? Okay. ناخد 15 دقيقة break وبنرجع إن شاء الله at 11:15.
هذا هو بيحكي على الفلسطيني بيحكي على الكوتا، بس على الجرامي بدل يكون بيكون 25.
انت البرزنتيشن تبعتك الكلهم 29 هي اصلا 1 2 3 السؤال بلاش اخربش لك شيء.
ما كنت تصير داخل الجرعه الثالثه انت ما خدتهاش.
ممتاز. هذا عنوانك. اوكي خلص. ايه بس ليش تستمر؟
شوف عربيها
كيف F5
شو صحيح عادي. ايش بجربي؟
مش عارفة ليه مش عم بتحرك.
وين الماوس؟
صح؟ مش عارفة.
سلامات فادي كيفك؟ اخبارك؟
طب نجرب البرزنتيشن الموجود
طبعا هو اصلا جنني البرزنتيشن تبعك عشان تكون في الصورة.
ما هو بتعرفي ليش؟ لأنه بعمله على الماك والماك كمبيوتري
يا
بيختلف لما يجي على الويندوز.
هي راح يصير.
لا
يا زلمه هيك
لا فاتح موجود. لا شو الصورة؟
خلاص تمام.
وين
هيها
صبية
سعد.
بصراحه
تعال شوفوا. قاعدات كل شيء تمام. يلا نعم. طيب شو نعمل يعني؟
جنبك من برا. ليش لا يعني؟ تعال تعال. ايش؟ لا خليك.
لا دي من الكمامة، احكي لي دي من الكمامة.
دي من الكمامة.
مش تنعدم من الكورونا.
خلينا ننعدي.
أحلى شيء.
الحاجة الأيام على حساب مش على حساب المؤسسة.
اللي بحب يتصور لحاله يتصور. في ناس بحبوا
ريم جاهز؟ ريم جاهز؟
بس أكبرها. يلا خلص هيك جاهز.
صورة هون وصورة هناك عشان انزلها في الكتاب. دقيقة بس بعد إذنك أنا وياها ثانية بس.
يلا طلع عليكم.
الحين ها تاخدش الشيك بعدين يا احمد. يا اخي احنا حرين، احنا لازم يكون في ايموشنال بالصوره. يلا ايش يعني يمين شمال لازم اوقف هيك؟
يعني هيك مع بعض.
طب ايش
هيك
مش عارف هيك.
لا عن جد. يلا واحد
وين طلعنا احنا؟ ما
انا بدي اتصور هون عشان ايش؟ وقتها من وراي عشان هي حاجه تنزل على البروفايل. عدل البروفايل ضحك. طلعت حلوة؟ هذا شغال. خليني اطلع على احمد. ما هي لقطني. لكم الحجاب مش مرتب، واحد يقول لي انه الحجاب مش مرتب.
عيدوا كل الصور.
ايه
يلا
طب قول يلا بالنص انت تبلد.
تخوت علي على صورة بالليل.
طب ايش رح كمان؟
يلا 1 2 خليكم.
رانيا بدها تحرك كل شيء.
مثلا ايوه الحلقه
قد نطلع لكم الساعه.
يلا يلا تعالي دورك.
يلا تعالي.
اخذ شكل على الصورة. بعطيك اياه. يلا. ليش ما اجيت اول يوم؟ ايه كنت لابسه سوتي جديده. ما اجي اول يوم ليش؟
هلا خذ انت انا باخذها وحده
فضحتوها للبنت.
تمام.
تعالوا له معي.
تعال. نعم. لبنان. بدك تصورني انا لحالي.
وانا بعدك لحالي.
هلا اعطيتني اياها هون منيحه كانت لبروفايل.
حلوه
بروفايل الجامعه.
كمان واحده للبروفايل. خليك نظبط مسكه من فوق.
لا هيك
يلا.
ما فيش عندك بروفايل الا للجامعه.
شو ما تبعتهم بنزل على الموقع.
يلا يلا نواف. مصري.
من هون. لا من كأني الكل بتطلع علي. طب استنى افتح هذا. يعني انت ما كنتي فاتحه الكمبيوتر؟ مش مبين التمثيل ابدا. لازم من هناك. مش نافعة مش نافعة، أنا مش نافعة. سوينا. خلاص بكفي بس يروحوا الكل. مش الحال. انت ما كنت فاتحه الكمبيوتر، ارجعي افتحي الكمبيوتر.
لا حلوة ممتازة هاي فيري نايس. لا ابدا
انت بتعرفي الصورة انا ببعث لها.
هاي كثير حلوة. انا عندي الصورة الوحيدة بيقولوا لي يعني خش الصورة الوحيدة.
النسيانين المايك كل شيء طالع
لو راح
صورني انا بس بعد
يلا يلا.
انا بس صورة هون. مزبوط منديل مزبوط منديل.
كل واحد وانت بتروحي على الجامعه
Thank you.
اجرب الوقف. طب يلا
The rule of I know.
مع الناس يا
sorry. خلاص انا بديش اتصور بس بدي اشوف الوضع.
ايش اعمل؟ اوكي.
انا جاهزه في الحال بس ايه بدي اطلع فوق.
سلام ايديك.
يلا خلص خلي بس نخلص. يلا لازم نبلش. لا طب البحث هلا يعني تقدروا المحاضرة؟
يلا
يعني طالع واحد
هذه لايف ولا
لايف؟ لا لايف. هو اونلاين معنا؟ لا
احكوا لنا اذا نبدا.
يا ريت تبلش البحث خلينا نبدا عشان ما نتاخر اليوم. طب خلينا نبلش البحث خالص.
الصوت كاميرات كله جاهز. يلا دكتور
يعطيكم العافية. Welcome back. We would like to welcome again Dr. Khorsa Adeli. He was with us yesterday, so many thanks for your commitment to our union, our medical technology union. Today, Dr. Adeli will talk to us about technological advances in laboratory medicine, predicting the lab of the future. Welcome, Dr. Adeli.
Hi, everyone. In this presentation, I'll be talking about technological advances in laboratory medicine and predicting the lab of the future. I will be sharing my slides. There have been numerous advances over the past few decades, particularly in the last decade in lab medicine and in vitro diagnostics. And I have a few minutes to talk about this quickly. I'll summarize as much as I can. Now, before I begin talking about technologies and technological innovations, what I want to do is pass on an important message from IFCC, and that is, in view of the IFCC organization, every one of us, every lab professional should be involved in transforming the lab through innovation. So truly cultivating a culture of innovation in all areas of lab medicine and clinical lab diagnostics. It's important that every one of us, whether it's a clinical scientist, lab physician, bench technologist, supervisor, are involved in continually innovating and improving lab processes, as well as, of course, technological development. So there have been numerous innovations over the past couple of decades across many areas of the lab. And this diagram talks about organizational changes and innovation, process improvements, business funding changes that have significantly improved resources for lab medicine, particularly in vitro diagnostic industry, strategic changes, as well as marketing communication technologies and improvement in that. And of course, in terms of scientific developments, biomarkers development and innovations continues to advance significantly. And of course, technology in terms of in vitro diagnostic technology and many new methods and new tools that have been developed in this area. Now, focus today, the next few minutes is on technology. So looking at in vitro diagnostic technology, you see a number of innovations, particularly in the past 1 or 2 decades, in the area of tandem mass spectrometry and nuclear magnetic resonance, in the area of automation and robotics, the introduction of artificial intelligence, machine learning, and big data analysis to assist in lab analysis of lab data. Many innovations, of course, in the area of genomics and genetic testing, development of many applications, electronic apps, and new ways to do medical diagnostic data management, microtechnology, which has been the basis of developing many point-of-care assays, and related to smartphones based diagnostic tools that are continually being developed. So there are many areas of development and innovation that's really transforming lab medicine as we speak. So in terms of impact, well, these technological innovations have had major impacts. For example, a key advance is shortened turnaround time and real-time results being obtained and delivered to patients and practitioners, availability of more effective tests, biomarkers developed for earlier diagnosis and therefore better management of patients, omics area, of course, both genomics, proteomics, metabolomics, many areas that are really significantly advancing, and they are helping to develop new biomarkers for both diagnosis and monitoring of disease, and improved assessment of natures of errors. And this is in relation to process improvements in the lab that's helping to improve assessment of errors in the lab, pre-analytical, analytical, post-analytical errors. Now, in tandem mass spectrometry is an old technology, but it's been around for decades, but it has increasingly been used in clinical labs. And we actually, in our hospital, began using this technology almost 18 years ago. And this has involved the use of multiple mass spec. Now we actually have 8 mass spectrometers in our clinical chemistry lab, and it's used in many areas. So this is a growing technology in many labs around the world. This slide talks about a range of different types of mass spectrometer that are being currently used in both for detection of small molecules as well as large molecules in the clinical field. Now, this slide talks about some of the processes involved. Usually, you require a sample, of course. Usually, it's a serum sample. It could be a urine sample, or in some cases, tissue samples. And these usually, after an extraction step, either multi-mass spectrometer or LC-MS has been used to basically develop profiles on these samples, both for small molecules, in the case of LC-MS, usually targeting small molecules, and multi tends to look at proteins, larger molecules. So many different tools, mass spec-based tools that are being used and continuously being developed. And many of these mass specs are actually being automated now. Now, in our clinical lab, we are actually applying it, and many others are applying it to steroid hormone analysis, toxicology, and profiling various drugs, therapeutic drug management, metabolic disease, and of course, in newborn screening is a major tool in newborn screening. Now, there are a number of future applications are actually coming already. For example, point-of-care based type of mass spectrometers actually are being developed, where it could be miniaturized and used in small handheld devices. This is actually, there are some prototypes already in development. And so this is actually will significantly increase the power of this technology in clinical diagnostics. Another area of innovation, of course, is automation, and you're all aware of this. It's increasingly helping labs to process samples more effectively, and robotics are being introduced and already are here. And actually, this is particularly important in large reference labs where there are thousands of samples being analyzed hourly. So this is a significant, of course, improvement in many areas of clinical lab testing. Microtechnology, as I mentioned, is the basis of sort of many new point-of-care devices, the so-called lab on a chip concept that is being applied to many areas. Usually, some of the major, the current usual developments recently have been focusing on a combination of reagent-coated microbeads and arrays of reaction vessels, usually using microfluidics to develop assays. And the examples are, for example, single molecule counting or digital immunoassays, as well as PCR testing using this technology. This type of technology underlies an emerging generation of ultra-sensitive immunoassays that can detect very low levels of specific target proteins, for example. Now, this type of technology has led to development of many point-of-care devices and so-called smartphone-based diagnostics that are currently being used. There are a number of publications in this area. We're actually just publishing a review article as well on the use of these point-of-care devices, sort of the new generation of point-of-care devices that are based on microfluidics and some of the newer technology. Also, another major area that's rapidly changing our field of lab medicine is sort of big data analysis and data mining. And because we all sit on huge data resources, every lab has millions, if not billions of data points that can be mined and to obtain new information. And so the application of big data analysis is really very important in the field of lab medicine. And lab medicine has been referred to as a domain which offers a unique opportunity to analyze extremely large, rich, and complex data sets of information concerning medical laboratory test results. And finally, the application of artificial intelligence is going to improve the power of many of these tools as well. AI methods are rapidly being applied in clinical medicine, but also in clinical diagnostics. And they show promise in many areas of healthcare, including diagnostic apps, as well as improving diagnostic power. There is significant potential advantage to use of AI to, for example, reduce errors at different stages through the lab process and patient care process. AI has actually been referred to as the sleeping giant in healthcare, and this is true. It's thought to definitely in the next decade or so really revolutionize many aspects of patient care and diagnostic processes. Some examples of AI-powered diagnostic tools are shown here, such as WebMD, one of the most famous symptom checkers on the net, and it's now becoming AI-powered. Boy Health, which is an application that uses algorithms to diagnose and treat illness based on symptoms. So a patient can provide information on their symptoms, and it actually can produce algorithms to provide a diagnosis without the need for a physician. So there are many others, such as ADA, the AI doctor, Babylon Health app. I do not have time. I actually have a whole slide set on this particular topic. Hopefully at another opportunity can be presented. So lab medicine and in vitro diagnostics are going through major innovations and major advances. And truly, we have an exciting future ahead of us. So, and thank you for your listening. This was a short and quick presentation, but hopefully it was helpful. Thank you very much.
Thank you so much, Dr. Adeli. Do we have any questions from the audience? Okay, next.
Our next speaker is Professor Tomris Osben. She was with us yesterday, and welcome back, Dr. Osben. She's going to present blood and non-blood sources of cell-free DNA from non-invasive cancer. So please go ahead.
like to express my thanks to the organizers of the IPCLM 2021 to be held in Ramallah, Palestine. I also express my thanks to IFCC and Abbott for visiting lecturer program. And the title of my presentation, Blood and Non-Blood Sources of Cell-Free DNA for Prostate Cancer. And I will present the results of our studies. Circulating free DNA in blood of prostate cancer patients, results of our study. Blood plasma is the most frequently analyzed biological fluid for circulating free DNA. But blood testis barrier lowers the passage of the circulating free DNA released from the prostate tissue to the blood. Low circulating free DNA blood levels are seen in the early stages of prostate cancer, and increasing levels are observed in the late stages of the disease, and therefore blood is an appropriate source to monitor metastatic prostate cancer after prostatectomy. The aim of our multi-center cohort prospective study was to evaluate the total circulating free DNA level and tumor-specific ctDNA mutations, methylations as biomarkers in the plasma of prostate cancer patients, and to investigate their clinical relevance as a diagnostic and prognostic tool. These are the exclusion criteria of our 96 prostate cancer patients. We collected blood from the control subjects and 96 prostate cancer patients having histologically confirmed diagnosis of prostate cancer before surgical radical prostatectomy operation. And further samples were collected from the same patients at 6 and 12 months following radical prostatectomy. And the blood was collected in ENTA-containing tubes and centrifuged within 1 hour, and plasmas were kept frozen at -80 degrees. These are the data of prostate cancer patients, median age, prostate-specific antigen, Gleason score, and tumor clinical stage. Circulating free DNA was extracted from plasma of the patients using a Kyogen circulating nucleic acid kit and Promego automatic extracted. And we measured the total amount of circulating free DNA using two different methods. One is fluorometric qubit, and the other one spectrophotometric nanodrop. We compared the results we obtained using these two methods with the quantitative PCR, which is the gold standard for quantitation of circulating free DNA. These are the results of qubit and nanodrop. So when we compare our results of the healthy subjects and prostate cancer patients, and nanodrop is red and qubit is blue, nanodrop overestimates with respect to qubit because of the interferences of proteins, nucleic acid, and organic contaminants. So our data show that automated circulating free DNA extraction and quantification by using fluorometric qubit seems to be the best approach to quantify cfDNA levels in the plasma samples of prostate cancer patients. And we perform quantitative PCR tests for the quantification of circulating free DNA and compare our results with the qubit and nanodrop. All PCR-based methods are sensitive to DNA fragmentations. So we use two primer sets. The primer set 115 base pair amplicon alu 115 amplifies both shorter and longer DNA fragments. On the other hand, 247 base pair amplicon alu 247 amplifies only longer DNA fragments. And we also evaluated DNA integrity, and qPCR ratio of one DNA is not indicates DNA is not truncated. The ratio of alu 247 to alu 115 is if it is less than 1, DNA is completely truncated into fragments smaller than smaller. So then we compared our log PCR results with log nanodrop results, and then this is the correlation we obtained. So, and then we compared also PCR results with the qubit single strand and double strand, as you see in these graphics. And then we obtained our statistical analysis indicated that the comparison between the four methods, qPCR, nanodrop, qubit single-strand DNA, and qubit double-strand DNA, demonstrated that there is a significant correlation between our values. And after this analysis, we did ctDNA hypermethylation analysis in prostate cancers. And we did the qPCR quantification performed targeting the methylation patterns of 4 gene sites that have been shown to be involved in prostate carcinogenesis: GSTP1, RASF1, RARB2, PTGS2. So our results indicated that hypermethylated sites at the baseline correlate with the clinical severity of the tumor. Increased hypermethylation at multiple gene sites occurs during progression, indicating early biochemical recurrence after radical prostatectomy. Recent research, also confirmed by our studies, indicates that epigenetic analysis of a selected panel of genes give valuable information of tumor progression at the time of the diagnosis and also on the tumor recurrence. Our data showed a direct correlation between cfDNA concentration and cancer progression and tumor stage. Patients having high cfDNA concentrations at the baseline had worse disease-free time and overall survival in comparison to those with a lower cfDNA concentration. Therefore, cfDNA detection can be used as a prognostic and predictive tool for the classification, clinical management, and follow-up of patients with prostate cancer. And this is our publication in Clinica Chimica Acta based on our results. cfDNA in seminal plasma of prostate cancer patients and benign prostatic hyperplasia patients. Seminal fluid originates from prostatic secretions, and it can be used for PCA diagnosis. So far, no research has been dedicated to cfDNA assessment in seminal plasma of prostate cancer patients and benign prostatic hyperplasia patients. So, seminal plasma cfDNA can be analyzed through cost-effective procedures such as fluorometric and electrophoretic techniques. And they may provide useful information for PCA diagnosis, differential diagnosis between PCA and benign prostate hyperplasia, tumor characterization, prognosis, determination of therapeutic strategies, and follow-up of the patients. We included 33 PCA patients, 30 BPH patients, and 21 healthy age-matched control subjects into our study. And we obtained seminal fluid samples, and we analyzed them within 2 hours of collection. And we have extracted cfDNA, and then we applied fluorometric qubit assay for cfDNA quantification. These are the results of, these are the control subjects results, and this is BPH patients results, and this is the prostate cancer patients results. And here we see the same results on the graphic. So average seminal fluid circulating free DNA concentrations were 428 in prostate cancer patients, 77.4 nanogram microliter in benign prostatic hyperplasia, and 25.4 nanogram microliter in control subjects. So a statistically significant difference existing between the patients, and so these results, our study indicated that these seminal fluid cfDNA measurements are able to distinguish PCA and BPH patients with optimal accuracy. A similar cfDNA fragment size distribution pattern. Fragment size evaluation of seminal cell-free DNA we perform using microfluidic electrophoresis using the Agilent 2100 bioanalyzer. Here we see the device. And the size distribution of cfDNA in semen of prostate cancer patients with lanes 1 to 6 indicate that electrophoresis patterns were different between prostate cancer patients and healthy individuals. Distinct characteristic necrotic DNA pattern fragmentations we observed in prostate cancer patients compared to the healthy individuals presenting a high molecular weight DNA in prostate cancer patients. We publish our results regarding the fluorometric quantification and electrophoretic pattern characterization of seminal plasma cfDNA, which allows discrimination between PCA and BPH patients and HMH healthy individuals. We demonstrated that seminal fluid cfDNA concentrations are significantly different between PCA patients and benign prostate hyperplasia patients and can be adopted as a useful biomarker source for the differential diagnosis between these two diseases, avoiding unnecessary biopsies and therapeutic monitoring of PCA patients. So future trends, and this is our publication in the journal Critical Reviews in Clinical Laboratory Sciences, liquid biopsy with cell-free DNA, new horizons for prostate cancer, future trends. With further advances in technology and reduction in cost, it is possible that liquid profiling, liquid biopsy become routine clinical tests. In the future, instead of extensive imaging and invasive tissue biopsies, liquid biopsies could be used to guide cancer treatment decisions and even screen for tumors that are not yet visible on imaging. Thank you for your attention.
Thank you, Professor Osben, for this keynote presentation. She's online with us, so if you have any question, please do. Is there any question? Is she with us? Okay. Hi, Professor Osben. Actually, I have one question. You compare the use of qubit and the nanodrop. So my question is, what is the minimal concentration that can be measured by qubit? And is this related to the late stages of prostate cancer or any cancer?
Okay, qubit is more sensitive than nanodrop because in nanodrop there are some contaminants, and you can use it, and you are able to detect also as low as the concentration of cfDNA using qubit. Of course, PCR is more sensitive, but the other one, qubit, in a very quickly you can obtain and measure low levels of cfDNA. But the problem is for blood, we need to collect more than 10 milliliters of blood from the patients because the number of the amount of cfDNA in blood is low, because in the blood, 5 liters of blood, the amount of cfDNA, especially in the beginning of the disease, it is very low. So you need to obtain a lot of to get a lot of blood from the patients. This was a problem. But on the other hand, in order to measure the lowest levels of cfDNA, you need to use some at least 10 milliliters of blood from the patients. And the PCR is more sensitive But on the other hand, then you need to use primers for specific genes to measure the amounts of. So it is more practical to use qubit instead of PCR. If you are able to obtain and measure the amounts of cfDNA using qubit, then you go further studies, more sensitive studies with using PCR. On the other hand, in blood, since the cfDNA levels are so wide, ranging very widely, from less than 1% to 90% in metastatic cancers. This is why we use different body fluids. For example, why we use seminal fluid, because it is very near to the prostate tissue. And then we were able to measure higher cfDNA levels using semen. And also, instead of blood, you can use different body fluids, only cerebrospinal fluid and saliva, different body fluids. Urine is not so efficient because it is acidic pH is destroying cfDNA, but the other body fluids are used also instead of blood. I hope this answers your question.
Okay, thank you. Thank you so much.
Okay. Have a nice meeting. Thank you.
Thank you.
Okay, our next speaker is Dr. Aisha from Aisha Nasif. She's a medical doctor. She's the president of the Scientific Council of Medical Laboratory and member of the Advisory Board on Medical Specialty Council. And she's the founder of the Libyan Association of Clinical Pathology. Dr. Aisha, today she will talk to us about the setting a quality standards for Libyan medical laboratories, prerequisites for good health as third sustainable developmental goals. Welcome, Dr. Aisha.
Assalamu alaikum. Hello, I would like to welcome everybody, and I am thankful for Dr. Osama Najjar, the organizing and the scientific committee, for providing this chance to present this talk about setting quality standards for Libyan medical laboratories as a pre-requirement for good health, the third sustainable developmental goal. My presentation will involve 4 parts. The first part is about role of medical laboratory, their importance, and its relation to health services and good and sustainable developmental goals. The second part deals with accreditation of medical laboratories and their importance and its relation to quality. Third part involved assessment of the current status of quality and accreditation in Libyan medical laboratories and the national efforts to establish total quality management system. The last part is a conclusion, a recommendation, and perspective. Emergency Care Research Institute, interested in patient safety, evidence-based medicine, and technology decision support, published a special report 2020 where they ranked diagnostic error as #1 concern for patient safety. Laboratory results affect around 70% of medical diagnosis. More than 30% of medical errors causing serious harm are diagnostic. Most catastrophic, around 2/3 of diagnostic errors lead to death or permanent disability. Most costly, diagnostic errors leads to more than around 30% of payout for all medical malpractice. Laboratory services are necessary for diagnosis to confirm the initial clinical evaluation and for their use in treatment and the prognosis of patients. It should be accurate and communicated in a timely manner. Unfortunately, diagnostic failures are frequent, costly, and harmful, and these errors are mostly encountered in vascular cancer and infection, according to the Society of Improvement of Diagnosis in Medicine. These consequences can be very severe due to delay in the treatment or inappropriate treatment, additional costs with waste of resource, time, and efforts, with poor patient outcome. Unfortunately, the consequences can be real. This motivated young boy, which appeared in national TV of America, was admitted to the hospital because of gastroenteritis. He had a leukocytosis, which overlooked by care providers, and he discharged. 2 days later, he died because of septicemia. According to SEDM, in the United States of America, around 12 million outpatient or cases experience diagnostic errors annually, and this leads to 100,000 deaths and costs around 100 billion per year. Medical laboratories could improve health services, as most of causes of errors are diagnostically related, as published by Coveris, and it's due either to delay in test ordering, or non-performance of the test, or no delivery of the result, misinterpretation of the results, and failure in communication, or failure to follow up with the patients. Total quality management system and good performance of laboratories could drive excellent medical services and improved outcome by providing patient-centered services. Most laboratories are closely related to good health, the third sustainable developmental goal. Totally, there are 17 SDGs as agreed for 2030 agenda by the world leaders in 2015 at the United Nations General Assembly. These goals aiming to fight poverty, have clean energy and water, good marine and land life, and good health and education, along with other goals. These goals aim to transform our world by acting on people, planet, peace, partnership, and prosperity. We are concerned with good health. As a third SDG, leaders agreed to fight epidemic and communicable disease, to provide universal health coverage with safe medicine and vaccines, and preventing chronic disease. It's very evident that these goals cannot be achieved without good medical laboratory services. So, unfortunately, what's about the case in Libya? In 2019, the Arabic SDGs indicators shows that more than 1/5 of Libyan children had short stature, and more than 1/3 of adults have obesity. These two problems are the manifestation of more serious underlying medical problems. In Libya, medical laboratories have many problems. It's mainly due to lack of identification of current and future needs and desired outcome. We all know that COVID highlighted affected all science, technology, engineering, and medicine field. But now more than ever, it highlighted the importance of diagnostic services for good health. It has been found that this problem is attributed either to gap in clinician knowledge, or it is just related when we have inaccurate results or misapplied results or delayed, so they are not active. Gap in clinicians are not always sure of what to order and why. They are not all aware of window detection. They are not always sure of what to do with the results. They ignore the importance of predictive positive value of laboratory tests, and the impact of demographic and comorbidities on result interpretation. By this, we finished the first part presentation. The second, about the role of medical laboratories and its relation to good health and SDG. Second part is about the importance of accreditation. This year, the World Accreditation Day, their theme was accreditation supporting the implementation of SDG. SDGs. It's a global initiative established by IAF, International Accreditation Forum, and International Laboratory Accreditation Corporation to promote the value of accreditation of medical laboratories, and third SDG, good health. It is a good coincidence as we are currently in Libya. We are working in quality and accreditation for medical laboratories, and it is the time for all Arab world to present their reports on recommendation of progress in SDGs. An accredited competency of and the quality of laboratory can be assured by setting a recognized standard and then evaluation by assessors and then accreditation as a final process. An accredited laboratory has the capacity and authority to carry out the tasks entrusted to it. We have many types of laboratories for calibration, inspection bodies, proficiency testing, reference material, but here we are interested in medical testing laboratory, which using ISO 15189. Among the recognized regional accreditation body presented in the executive committee of ILAC and IAF is the Arab Accreditation Cooperation, ARAC. ILAC, or the International Laboratory Accreditation Corporation, it is an international organization for accreditation body. Its objective is to reduce risks and to ensure that certificate may be relied upon. ILAC follows ISO 17011 and deals with mutual recognition agreement. International Accreditation Forum, IAF, aims to have single worldwide program of conformity assessment is being used with a mutual recognition arrangement. ILAC and IAF are working together to ensure that a product tested once, accepted everywhere. As we are concerned with medical labs, the international quality standard, as we said, it's ISO 15189. It's based on 17025 and 9001. It includes technical and quality requirement. Quality management system medical labs ensure good medical services and good health. It covers all phases for laboratory testing, the pre-analytic phase with all the phase steps, analytic and post-analytic phase. ISO deals 15189 deals mainly with patient and with the sample and with report by ensuring professional competency, validity of test method and validation, conformity assessment and maintenance, test environment, and quality assurance data. Accredited labs reduce costs, enhance confidence in the results, and ensure customer satisfaction, provide accountability and patient safety, and ensure commitment to excellence and quality, and provide opportunities for continued education and training. Accreditation briefly could provide a very good competitive advantages to accredited labs. Quality laboratory services are essential for good health. In 5 NOPS model of Harvard, it highlighted the importance of quality to realize the performance. In health system building blocks, again, it emphasized quality to achieve goals. Coverage of care is not on the 3 dimensions by providing the services to the targeted population at affordable cost is not enough. The quality, the 4th important factor as a determinant of good health is the quality of these services. It's important to perform a quality gap analysis. A quality gap analysis, a management technique in which standards are assessed against the actual delivered performance. By identifying quality lab, health institute can do what they need to improve performance. So it's becoming very evident that quality, accreditation, and SDGs are closely related. According to SIDM, a medical labs follow-up could help in early identification of persistent abnormal results in a third of cases tested for creatinine. Among these cases, more than 80% of cases have chronic kidney disease. This early diagnosis could help in good management of these patients. Establishment of total quality management system is mandatory and very hard in the same time. Achieving a 99% level of quality means accepting 1% of error. In France, it means 14 minutes without water or electricity and 50,000 parcels lost by postal services, 22 newborn falling from midwives, and 600,000 lunches contaminated by bacteria, and 3 bad landing at Orly, Paris, or airport. From these statistics, we could estimate the presence of a very big high number of diagnostic errors. Accreditation is a laborious process which has several phases and multiple tasks. It started by request for accreditation, and then document filled and report evaluation, then impartial evaluation, then issuing of certificate and accreditation. For quality, we are finishing the second part, and for accreditation, and we are starting a third part regarding current status of quality and accreditation in Libya. For accredited quality lab, we need to set a standard and need a methodology and accreditation bodies. In Libya, the Minister of Health, he issued a decree in 2008 for accreditation of medical laboratories in 3 years. In 2010, Libyan quality standards were issued, adopted from Arabic standards. Then in 2013, core Libyan quality standards adopted from Libyan standards, prepared in 2010, and from expert opinions at a workshop in Bab al-Bahr Hotel 2013. 2021 year, the Center of Accreditation of Health establishment in Libya, he formed a committee for setting of Libyan standards as adopted from GCI Arabic standard, from Gahar in Egypt, Lebanon, ISO, WHO, and maybe Turkish. And this will be, the final draft will be issued within 2 to 3 months, hopefully. Fortunately, Libyan Accreditation Center and Center of Libyan Accreditation Center and Center of Accreditation of Health Establishment work together to start medical laboratory total quality management system and accreditation process. LIBAC mainly concerned with licensing, calibration, measurement, and CAHL is mainly with medical services, quality, safety, infection control, community services, along with the blood bank, of course. Members of Libyan Association of Clinical Pathology are working on both committee of CAHL and LIBAC for setting of the quality standard and accreditation. This is the LIBAC committee. They are working. First document was licensing document by studying and rewriting of all requirement. This taken from required by WHO, Center of Accreditation, Libyan Accreditation Center, Ministry of Health, and all related bodies. They are mainly concerned with the legal status, facility organization, safety, and required and quality infrastructure. Licensing include an administrative and technical requirement for public and private, and it's mainly covers staff, facilities, safety, and customers requirement. We know that licensing is a pre-requirement for registration and accreditation. Second, they are working in manual of safety in medical laboratories. They are relying in WHO, in Occupational Safety and Health Administration of America, and National Examination Board in Occupational Safety and Health of the United Kingdom. They are taking in their account the quality environment, health, safety, which drive continual improvement and ensuring control and compliance by monitoring quality according to ISO 9001 and environment and handling of biohazardous material, occupational health and facility safety at once. The third one, they are working classification medical laboratories for levels, and this is taking the recommendation of WHO, which divide these laboratories into different levels according to the laboratory analysis and test performance in each lab, or according to the safety requirement. Fourth job is description and specification of jobs of staff in medical laboratories, from general director, clinical pathologist to the all staff and assistant, technical and assistant staff. We will try to work this with Ministry of Health and Ministry of Labor. Unfortunately, since 10 years and even before, we have fragmentation and absence of coordination of efforts, which make our job very difficult, but hope we can. The second committee is formed by Center of Accreditation of Health Establishment in Libya for setting of quality standarding in health establishment. It covers mainly 15 items. Where in Libyan Association of Clinical Pathology works in item number 8 for diagnostic and auxiliary services. We are covering mainly items concerned with governance, patient-centered services, contracting, patient safety, analytical process with pre and post analysis phases, documentation, and reporting. Also, another standards for a blood bank is being prepared. It covers quality and continuity of services, personal training, surveillance and error reporting and records and documentation. Sorry. We are arriving to the fourth phase of our presentation. It's regarding conclusion, recommendation, and perspective. Diagnostic errors, diagnostic failure are frequent, costly, and harmful. And establishment of total quality measurement system in medical laboratories are mandatory. Third, accreditation is preferable after quality measurement system establishment. Fourth one, maybe along with these two committee work, we may start by adopting the 5 A's technique, started by awareness, acceptance, advocacy, activists, such as health workers and doctors, to reserve their rights and have continuous quality training, and then assessment. Fifth objective may be to start a robust education and training programs for medical laboratories personnel. Lastly, to establish a clinical laboratory advisory and quality council, where efforts can be all grouped together, and we can transfer knowledge between different sectors. It could include the representative from Parliament, from Presidential Council, from Ministry of Health, Education, Planning, and from Libyan Association of Clinical Pathology and Medical Specialty Council, in order to ensure that we all work together to have and to realize this objective of having a total quality management system and accreditation of medical laboratories in Libya. Thank you very much for your kind listening. And really, I am grateful to Dr. Osama Najjar for his kind invitation and follow up. And I hope next year we can all meet together in next activity. Thank you very much. Assalamu alaikum wa rahmatullahi wa barakatuh.
Thank you, Dr. Aisha. For the sake of time, I think we will move to the next presentation.
I'd like to welcome our next speaker, Dr. Reem Al-Dweik. She's a master's student in biochemical sciences at the Hebrew University of Jerusalem, and she's investigating the impact of genome organizing on cancer cell aggressiveness. She's also a lab technician at the Hebron Doctorate Central Laboratory. Her presentation is the role of meiosis and kinetochore genes in inducing chromosomal instability and transformational capability in cancer cells. So you are welcome.
Okay. Hello, everyone. Thank you for having me today. Hope you really enjoy my presentation. So my project is about the role of meiosis and kinetochore genes in inducing chromosomal instability and transformational capability in cancer cells. So let's get started. Cancer is a heterogeneous disease with an altered transcriptome contribute to its altered behavior compared to normal cells. Chromosomal instability and transformational capabilities are among the most important hallmarks of cancer. Chromosomal instability is a source of genetic variation with a constant shuffling of the genome, leading to dysregulation of gene expression. It is classified into numerical chromosomal instability, which is a gain or loss of a chromosome, and structural chromosomal instability, which is a gain or loss of parts of chromosomes. The majority of these errors results from defects during chromosomal segregation and spindle defects, including the lagging chromosome, the mass between two dividing cells here, the stretching bridge, which is called anaphase bridge between the dividing cells during anaphase in cell cycle, and monopolar spindle orientation, multipolar spindle orientation during metaphase of the cell cycle. Those four features are going to be used to assess chromosomal instability phenotype in our study. There is chromosomally stable cell line, which has the same number of chromosomes in each daughter cell, and chromosomally unstable cancer cell line that often makes mistakes that results with two different daughter cells. So why we choose meiosis and kinetochore genes? Because we are interested to study the biological processes that inherently linked to genome instability. Meiosis, the reductional cell division, which occurs during reproduction that involves meiotic recombination and crossing over. This point is the similarity with genome instability, where genetic information is switched between homologous chromosomes, as we can see here. On the other hand, we have the kinetochore that has an important role in mediating chromosomal segregation, and the balance between all kinetochore components is crucial to maintain genome stability and correct ploidy. These properties of meiosis and kinetochore genes has led to intriguing idea that their overexpression may drive genome instability in tumor cells. Then, My lab has performed a bioinformatic analysis to explore this relationship between the overexpression of meiosis and kinetochore genes and chromosomal instability in cancer. They found a big list of meiosis and kinetochore genes that indeed enhance chromosomal instability, and out of this list, we choose DMC1 protein, which is a meiotic recombination protein required for DNA double-stranded break, SMC1 beta, a meiotic recombination specific component of cohesion complex that is required for cohesion maintenance. SEMP-A is a centromeric protein that is required to ensure proper chromosome segregation. The aim of our study is to experimentally examine whether overexpression of meiosis and kinetochore genes, 1, induce chromosomal instability, 2, drive transformational properties of cancer cells. So what we do is we took our meiosis and kinetochore genes, tagged them with GFP protein to monitor GFP construct to monitor their expression. Then they were transfigured into 3 cancer cell lines: HCT 116 stable colorectal cancer, HT29 unstable colorectal cancer, and MCF7 unstable breast cancer. And as a negative control, we overexpress GFP protein. We performed Western blot analysis to check if our meiosis and kinetochore genes were properly overexpressed and detected on the right molecular size. As we can see here, after incubating them with anti-GFP, they were indeed on the right size by Western blot. Presented are immunofluorescent images of the localization of the GFP construct. 1 second. Localization of meiosis and kinetochore GFP fused protein expression. In our negative control, we can see the EGFP expression nicely presented in the nucleus and in the cytoplasm, where our meiosis and kinetochore genes were presented in the nucleus where they usually act and present. Important to mention that cells were synchronized by double thymidine block to increase the number of mitotic cells. Therefore, we performed cell cycle analysis to verify whether our cells that were transfected with meiosis and kinetochore genes advanced with a similar kinetics compared to cells transfected with our negative control EGFP. And we can see it clearly with a very nice similar kinetics. Also, to verify if our method for enriching cells, which is double thymidine block synchronization, did indeed enhance the number of mitotic cells in G2M phase. We can see that clearly by the comparison between the unsynchronized and synchronized cells. For example, with HCT 116, the stable colorectal cancer, it is 11% here compared to 65 and 67%. Okay, so in order to check if overexpression of meiosis and kinetochore genes enhance chromosomal instability, we assess the phenotype by counting the number of chromosomal segregation defects during anaphase, including lagging chromosome, as we can see with cells transfected with SEMP-A, this mass between the dividing cells, and also cells transfected with DMC1 here, and the anaphase bridges that it is shown with SEMP-A and DMC as well between the dividing cells during anaphase compared to the normal divided cells with our EGFP, the negative control. Also, we counted the number of spindle orientation defects during metaphase, including monopolar spindle orientation, which is nicely presented here, and the multipolar, including tripolar spindle orientation and quadripolar spindle orientation, deviated from the bipolar spindle orientation. It seems to me that cells are playing dice here somehow. We have 1, 2, 3, and 4 poles. Okay, so here I presented the quantification result of a chromosomal missegregation and the spindle defects, where we can see in HCT 116 a significant increase in chromosomal missegregation defects and spindle defects by the significance here, indicating that the stable colorectal cancer enhance chromosomal instability phenotype, and on the contrary, HT29, the unstable colorectal cancer, we notice a less severe phenotype in terms of the defects in chromosome segregation and spindle defects, because we believe this cell line has already acquired a degree of genome instability before genome transfiction. Then, to test if the overexpression of meiosis and kinetochore genes promote invasiveness and transformation of cancer, we tested the ability of transfected cells to generate colonies in soft agar assay. And then after 3 weeks, we measured the area of the colonies. We saw that the overexpression of our meiosis and kinetochore genes enhanced the size of the colonies in both cell line, in the stable HCT 116 and the unstable HT29 colorectal cancer, as we can see by the significance here compared to the negative control in terms of the area of each colony, indicating enhanced cancer transformation properties in the stable and the unstable cell lines. To sum up, overexpression of meiosis and kinetochore genes in stable cancer cell line has the ability to promote chromosomal instability. The same overexpression has a smaller effect in cell line that already acquired a high degree of genome instability before genome transfection. However, both are capable of driving the transformation and proliferation of cancer. So we can say that the meiosis and kinetochore genes are used by cancer cells as genome destabilizer and transformational catalysts. So what we are planning to do in the future, we are planning to study the chemotherapy influence on chromosomal instability by itself, and then to study the chemotherapy influence on chromosomal instability in addition to overexpression of meiosis and kinetochore genes as inducers for chromosomal instability. So are we going to have more response to treatment or more resistant to treatment? Using the two cell line, the stable and the unstable colorectal cancer. Last but not the least, I'd like to acknowledge and express my appreciation to my PIs, Dr. Michal Kluchten, Dr. Natalie Palasha, for their persistent encouragement, support, and also my lab managers, members, my research colleagues for their continuous support and guidance. And thank you for listening.
Thank you, Reem, for this nice presentation. If you have any question, do we have questions? Okay. So no questions.
Okay.
Thank you.
Okay. Our next speaker will be Professor Ferrari. Professor Ferrari is well known for our union. Today, he will talk to us about expanding space for next generation sequencing diagnostic applications. So welcome, Dr. Ferrari.
Good afternoon. Before starting, I would like to thank the organizing committee for the kind invitation to this VLP program of IFCC. The title of my today presentation is Expanding Space for Next Generation Sequencing Diagnostic Applications. Today, I cover some words regarding what happens after the completion of the Human Genome Project, the NGS technologies, how to transfer NGS to the diagnostics, the clinical application, the most important clinical application, and some conclusions. The genomic revolution started when the human genome has been completed, and from that time, we increased very much the knowledge regarding our genome. We increase also a lot of the knowledge regarding the function of the cells. And both this activity request money for both for research in this field and also for doing or for offering the diagnostic test to the people. I would like to outline a few points that, in my opinion, are the most important. First of all, after the genomic evolution, we start to identify new mechanisms, new ethiopathologic mechanisms. This means that we have much more knowledge regarding the diseases. There is a reclassification of several diseases. There is new opportunities for prediction and prevention for several disorders. There is also a lot of novel therapy applications. And finally, we moved in the era of personalized medicine. The NGS is a convergence of chemistry and bioinformatics. For sure, we are very experts in chemistry and biochemistry. This is our background. But we are less expert in bioinformatics. This means that in these last 10 years, we learned a lot how to manage large cognitive components coming from the information from the genome to support the diagnosis for the patients. Few words regarding technologies. In this moment, the most important instrumentation are related with the sequencing by synthesis method. They are more or less 90% of the market. There is also a new approach for the single molecule sequencing that more and more will increase the knowledge in the genome that we interrogate. But what is really important is to see in the right part of this slide that the list of future technologies are really very long. This means there is an important pressure from the industries, an important pressure from the researcher to apply new technologies that will be easier to be managed, cheaper, and more reliable. With the sequencing, we may do a lot of activity. For sure, we may study the different genomes. We may study also the expression, the transcriptome sequencing. But what is still the most popular for the diagnostic is targeted sequencing. I mean that we do a lot of amplicon deep sequencing for the diagnosis. We utilize also the whole exome sequencing, the microsatellite marker development, the new CRISPR-Cas9 sequencing, and also metagenomics. You can see that the possibility is really very huge. I can say that for some of these methods, there is already some development for clinical application. For other, we are still at the research phase. It's important to outline how this testing is processed. I would like to say that is not different from any other parts of laboratory, because there is the pre-analytical phase, which is a very important indication for testing and the counseling. How to select the patient, how to select the test, which is the best test for answering the clinical problem. Then there is the part of the laboratory, the classical sequencing analysis. I would like to say that the wet part, the analysis of the patient sample, in some way is the most robust, the most reliable, because now the instrumentations in which you run our samples are really very, very robust, very, I would like to say, accurate. What is really still more difficult is the analysis of the digital data. Why? Because we have when we align our sequencing that we test with the genome. Now we may detect some variations. This variation should be called in some way. We have annotated these variants, what means a specific variance, and then we have to classify and prioritize these variants. And this part is not so robust as the previous one. Finally, there is the post-analytical phase in which we have to communicate the results. We have to do the counseling, and there is the integration to the clinical decision making. Few words regarding interpretation. As I told you, there is the phase of the variant annotation and classification and prioritization. But what we can have is that sometime, if we look on the right or on the left of the slides, we are in a good situation. There is some mutation could be clinical relevant, other could be benign or likely clinical relevance. This means that the probability that our results are reliable is really very high. But there are some variation of unknown significance. This means that really there is still a gray zone in which we are not able to solve completely all the diagnostic problems. The other parts is for sure the parts of the bioinformatics, because in this last 10 years, we shift towards data analysis rather than the technical components. It means we need a very robust pipeline for the interpretation. We need the infrastructure or working cloud for this evaluation. And then really now we have to manage a so big amount of medical data that is really amazing. Finally, there is the clinical approach to these variants. The first question is which variants are really clinically actionable? This is really the question, because is the question that our patient asks to us for solving the clinical problems. Then we continuously develop evidence-based scientific standards for the evaluation. There is some challenges because there is a risk of over-interpretation sometimes, and this is really a problem. When we study a genetic test, for sure we have to evaluate 2 points. One is the accuracy and the other is reproducibility. These are really important. Regarding the genetic testing, for sure we may do the test during the life for the pre-implantation after the postnatal life. And also for the reproducibility, we have to approach with the classical approach. We need the reference material, we need best practice of bioinformatics for the interpretation, and we have to develop guidance for this interpretation. Also for the accuracy is very important, the biological references. As I told you, many different materials with different metrics, and also to have some rare disease specific material. And this is really important to evaluate the accuracy of our test. The other parts for the reproducibility, the best practice is mandatory. We have to normalize all the variant calling. We have to develop several bioinformatics pipeline. We have to have, as I already told you, reference material, specific reference material. And then we have to move in standardization and to analysis of archived sequencing data. During the journey in diagnostic for genetic disorders, we start from the clinical assessment, how to return the testing. Clinical assessment means that we are starting from all the clinical parts. The phenotypic assessment is really important. Then there is a selection of the test. Which test is the best? We have to do whole genome, whole exomes. We have to do panel, targeted panel. We do trio versus proband, and so on and so forth. There is also the management of the variant, as already told. How we manage these variants, how we interpret these variants. There is also the development for the accuracy of the best practice. And then at the end, we have to return the testing. It's really important to have the electronic records of all this data. There is I make this comment at the end of my presentation, a role for artificial intelligence in this interpretation. And then at the end of all this journey, there is the clinical decision making. Some words regarding the clinical utility. We may do genetic diagnosis in all the different parts of the life. In the past, but still for some very small genes, we may use still the old Sanger method with to detect single variants. But there is now a large room for NGS. Large room means we may approach several times with multi-gene panels for several disorders, but in some cases we have to do the whole exome or the whole genome. And I would like to say that as much we move from the left to the right, we increase the complexity of our test. Some words regarding how is complex to do a diagnosis for genetic disorders. The first point is the locus heterogeneity. So for many genes, you have to test several genes for study one single disease. You see on the right of this slide that for some disorder, for example, for cardiomyopathies, you study more than 50 genes. For other, for ciliopathies, more than 100 genes. This means that to have the right information in these patients, we have to make a large study. There is also the problem of allelic heterogeneity. In some cases, like Duchenne-Becker muscular dystrophy, the same genes, different mutation, you may have a different phenotype. There is also pathogenic variants with varying clinical consequences. You know that you know very well the example of cystic fibrosis with different mutation in which the phenotype is very variable. And then at the end, there is the complication or the phenotypic overlap. What I mean that for some genes are present in more than one single different disorders. This means that it's not easy to detect the right genes for the right people. How to approach the genomic testing? The genomic testing, we have to take into account two problems. One is the genetic heterogeneity. We have to interrogate a single gene. We have to interrogate a huge amount of genes, more than 500, for example. The other is the phenotype. The phenotype is very specific, or the phenotype is non-specific. For sure, as much if we move from the left to the right, we increase complexity. For sure, if we study cystic fibrosis, it's a single gene with frequently specific phenotype, easy to do. If we go to the opposite, to the intellectual disability, there are a huge amount of gene, frequently, very frequently, the phenotype is non-specific. This slide is complex. We have no time to enter deeply, but I would like to make two comments for the laboratories. The green part is what we do in laboratory. The blue part is what we do in the clinical. This means that we have these two parts that should be merged. And you see that in yellow, there is the multidisciplinary approach. When we have this information, we have to merge this information and try to reach the final diagnosis. If we don't work as a team, we will not be able to solve all the problems. Another important task that is very related to the databases, that for single disorders, the probability to detect the gene is very different. For example, if we look for the connective tissue, for the osteogenesis imperfecta, now we have a huge amount of information that the probability to detect the gene is 100%. If we move, for example, in autism spectrum disorders, is around 8.5%. This means that these databases should change every day. This number will change every day. And then we have in mind all this information for the right counseling to the right patient. An example regarding the Charcot-Marie-Tooth disorders, this is neuropathy. You see that how complex is, for example, this problem. In this part, in the upper part, is the genes involved in the dominant diseases, dominant heredity. This is for the recessive heredity. You see that there are among the different phenotypes, CM2, CM1, HMN, HSN, there is overlap between the different genes, both for dominant, both for recessive. This is really very important because when you apply for this type of test, you should have all this information. The other points that you see that how deep now is information that we have is that, for example, we have also the mutation that are more related to the single phenotype. You see that this is the body, and there are several genes related to different phenotype with this problem. If there is the problem in different parts of the body, the pink is dominant. The blue light are the recessive mutations. There is also one mitochondrial mutation. And you see this is only for the head and neck localization. You see that when you have some information, you have to put this, for example, there is a problem of the eye, yes. There is a problem of the bowel, yes. There is a problem of this bone, yes. There is a problem of the arms of the foot, yes. This means that we have to put together and to build the test for detecting the right gene for the right person. You see that how much deeply we are now able to make this type of study. Is important also for therapy. There is no doubt that now we may have also information that may change the therapy. This is an example in which there are two fraternal twins that they have a neurological disorder named responsive dystonia that usually is treated with levodopa, but they didn't improve after this treatment. Then doing a whole genome sequencing, we identified that these two brothers, they have a compound heterozygous mutation, also in SPR gene, that encode for septiactorin reductase. And then supplementing levodopa with the 5-hydroxytryptophan, we improve very much the clinical situation. This means that how the genome sequencing is important also for the treatment. It's very important also now there are a lot of applications in neonatal intensive care units. We need very fast protocols, for example, 2 or 3 days for solving the very severe neonatal disorders that may help some young patient for new therapy that may solve the problem. This is a slide that may summarize what we can do in the genetic disorders with the NGS. Now we are able more or less to approach all the problems. We may study the chromosomal unhappy detection, for example, in prenatal phase, or now also the subchromosome deletion duplications. We may do at the end of the story also the whole fetal genome sequencing and diagnosing single gene disorders. We may do fetal methylome and fetal transcriptome. Now we are able really in prenatal phase to study completely the fetus and to solve a lot of different problems. Now we move in the second last part on speaking also in cancer genomics. Cancer genomic increased very much in the last 10 years. So the information that we have are really very, very strong. And then you see that now we have different technologies from the classical genomics that are already described, like whole genome or whole exomes. But as I told you at the beginning, there is also the transcriptomic, like RNA sequencing, or the epigenomic, like G sequencing and bisulfite sequencing. And applying all these different technologies, something are more easy, some other are more complex, we may do data analysis. You see, you may evaluate all the different genome, different expression, different methylation, for example. And then we have to integrate and interpret all the Looking now at the potential of genomics in oncology, now we may say that we may detect germline risk. What is hereditary in this field. We move sooner or later to the screening of the healthy people to detect very early cancer. Now there is the selection of the treatment, diagnosis, and also how to approach the cancer patients, depending on the genome information. There is also new progress in the treatment, and at the end of the story, we'll be able in several cases to cure or to have our patient in full remission. Few words regarding also the viral diagnosis. In the last years, also now there is an incredible increase of the knowledge in the viral diagnosis. Now we are able to discover novel viruses. Now we have the classical example of the COVID-19 in this era that is really a problem all the world. We have the detector of the pathogenic viruses. We have to able to examine antiviral drug for the resistance. We may study phylogenic analysis of the virus, also to study viral epidemiology, how important now the sequencing in the COVID era, and at the end, the safety quality control. What is now the most popular for sure for the clinical application is what is called microbiota study. I would like to say is we are in the era of the metagenomics. And now we have a clear information, how to have information regarding the microbiome is really very important. You see that is now we have a very strong evidence-based data regarding the inflammatory bowel disease and diet. You see that the mechanism in which with a good Mediterranean diet is easy to have a balance in immune function. If we have a Western diet, is much easier to have the loss of tolerance and then the clinical problem. Also, we have a lot of information regarding the gut microbiota that is very involved in the post-metabolism interaction. Is really important for inflammation, obesity, diabetes, insulin resistance, and then is now we have data that modifying the microbiota really may improve very much also the metabolism of a single person. Finally, there is also more recent indication that there is a proposed link between the gut microbiome and systemic autoimmune diseases. There are examples for autoimmune uveitis, rheumatoid arthritis, type 1 diabetes, and multiple sclerosis. This is a new era in which we may really approach another genome, the microbiome, for doing this type of activity. And what is behind this point? This is an interesting paper that summarizes what we can do. For sure, in a single person, when we have a problem, we will do metagenomics, microbiome analysis, we may do transcriptomics, different tests, we may study epigenomics, and also the genomics. We start from the people, from the chromatin, from the transcript to the cells, and at the end of the DNA. I show you an example. This is what we may develop, for example, new therapeutics. This is the systemic sclerosis of the skin, and this is lupus nephritis of the kidney. Two different disorders, but studying the gene expression profiling, they have the same, in the single cell, they have the same profile. What can happen is, for example, you study the skin, and then you may have a novel cellular subset with a potential therapeutic target that really is effective and approved, and then you apply the same therapy for another organ, for another disorder, but with the same gene expression profile, and then you have an already developed therapy. These are the classical examples. For example, this is osteoarthritis, this is rheumatoid arthritis, two different disorders. But and then you may study, for example, the epigenetic of this profiling, and then you may identify novel therapy. Or you may study early stage or late stage of the epigenomic profiling of this disorder, the rheumatoid arthritis. And then two different profiling of epigenetics, two different information regarding novel predictors of disease progression on severity. The future of the precision medicine will be that in the single patient, for example, we study epigenetics for having epigenetic signature, and we need the treatment A. Then we may study, we enrich T cell with the same specific TCR cell receptor specificity, we have another treatment. And then we may also detect mutation like a loss of function mutation in a drug metabolite gene, another treatment. This means put together all the data, you solve the problem. Finally, I would like to say that all this information, transcriptomic, genomic, proteomic, you have to put together in a knowledge-based categorization of candidates, and then there is data integration to identify disease-associated nodes and agencies. This means that the big data is the future, and I would like to outline a few points of how to utilize artificial intelligence. This is, for example, the patients, we have information, we have the record, we have to pool all this data, and then you have new information regarding phenotype association of these genetic variants. But we have also to the record also to manage this genetic variant, but a neural network, and then moving in this network, you may have other information to the patient. And finally, also, we may also modify or study this different information, different omics. In other words, you may modify deep fake for omics data fusion. You have to evaluate all this data, and then you have the reconstruction of the right omics. This means that artificial intelligence will help very much for our future to solve the clinical problem, because more and more we have a huge amount of data. I would like to thank very much for this hospitality. This is an FCC about visiting lecture program, and then we are very grateful to be able for the support. If you need some more information, you may visit the website of the FCC. And I would like to thank very much for your attention.
Thank you, Professor Ferrari. Do we have him with us online or?
Yes.
Thank you so much for this wonderful talk. Do you have any questions from the audience? No. I have one question for you, if you don't mind. We started doing the NGS oncology panels, and one of the things that we are facing problems with is the quality of the samples. Can I raise one small question technically, if you can just give us a small idea about how to deal with the bad or with the low quality FFPE samples that we receive from our patients?
Thank you very much for the question. For sure, your question is a key question. There are several approaches for that. My suggestion is that you have to try the different technology or the different protocols to select and to extract the DNA, for example, or RNA from your FFP. There is no doubt the two tricks are, first is the quality of the sample that you are able to obtain from your anatomic pathology. The second is that there are still different protocols, and then you have to try in your hand which is the best. Finally, for sure, this is intrinsic in the complexity of this test. For sure, the analysis for the cancer sample should be much deeper than in comparison with the genetic one, because there is a lot of interference, and then you have to do it. But I would like to say that in the last 3 or 4 years, particularly, also the kits that are available improve very much and now are much more robust than in the past.
Thank you.
Okay, I have another question, if you don't mind. You talked about the metagenomics and also the amplicon-based NGS. So when should I decide to use the amplicon-based or metagenomics? I think there's a big difference between metagenomics and amplicon-based.
Yes, for sure. These are two different applications. I don't know if you means regarding the classical microbiome. For in this moment, we may have different approaches. I would like now to focus my comments regarding microbiome. In microbiome, the majority of the tests are utilizing the classical 6S RNA, in which we may define, I don't know, some dozens of different species. Metagenomics is a broad approach for the test in which you really do the full metagenomic analysis for the different strains, and then you increase very much the species that mutate, like hundreds of those. And second, you may also study genes that are involved in the function of the bowel, for example, for gastroenterology. This is really very much complex. I'd like to say that at the diagnostic level now, the majority utilize this approach, but I think that in the future, increasing information in the databases will move to the metagenomics. Regarding the amplicon is related more to the classical genetics. Today, in this moment, you utilize much more frequently the capture methods because it's much robust. But for example, for a single gene or small gene or small target genes, also amplicon is probably easier to be utilized. It's probably cheaper and then it is reliable. I think that any single test, probably with the experience or with the doing the test during the time, you really may select which is the cheapest, the fastest, and the more reliable for your application.
Okay, thank you very much.
Thank you. Thank you to you.
We have another question.
Dr. Maurizio, how are you?
Hi, my friend. How are you?
Osama is talking to you. I want to thank you for this lecture and your continuous participation in our conferences. And I am happy to see you in a good will and to continue in a good health and a good will all the time. Thank you.
Okay, me too. I'm very happy to meet you again. You know that I'm very friend of you and your society. And then, as you know, I am always happy to meet you. And then if you need something for molecular, you may write me or call me as you like. And compliments for as usual, for your very nice Congress. In this difficult moment, particularly.
Thank you very much.
Bye.
يسلموا ايديكم. Thank you so much. This concludes the session. بنشوفكم بعد الغداء.
المخدرات والتحليل. فيعني بيحصل لي الشرف انه يكون معنا اليوم العميد ناجح مع حفظ الالقاب والتسميات. العميد المهندس ناجح سمارة مدير المختبر الجنائي الفلسطيني حاليا، وهو بدأ الأمر بجزء من التسعينات حسب التاريخ الطويل اللي له في هذا المجال. هو حاصل على شهادة البكالوريوس في الهندسة الكيماوية من جامعة بولندا من 95، وترقى في صفوف العمل مع الشرطة الفلسطينية، وحاصل على كثير من أو العديد من الدورات في مجال العلوم الجنائية. هيحكي لنا اليوم عن ال establishment of the first Palestinian forensic science laboratory. The floor is yours, مهندس ناجح. أهلا وسهلا. In English, عميد, what's the meaning of عميد?
Brigadier.
Brigadier. Okay, welcome, Brigadier.
شكرا لك دكتور أمجد، وبشكر جميع القائمين على هذا المؤتمر لإتاحة الفرصة لنا إن احنا نعرف على المختبر الجنائي الفلسطيني، وهو المختبر الأول في فلسطين الذي يقدم خدمات في العلوم الجنائية ويقدم خدمات لقطاع العدالة بشكل عام في فلسطين. راح أبدأ هذا التعريف، يعني البرزنتيشن كلها تكون قصيرة لتعريف الجمهور المحلي والدولي بهذا الخصوص. راح نبدأ في فيلم قصير احنا عملناه لمدة 4 دقائق عن المختبر، وبعدها نعطيكم نبذة كمان قصيرة عن خدمات اللي بقدمها المختبر بشكل عام والجهات اللي نتعاون معها والأمور اللي بتهم المجتمع بشكل عام الفلسطيني، وكيف إحنا بنقدم هذا الخدمة وقديش تأثيرها على الجمهور وخدمة قطاع العدالة في فلسطين. ممكن تشغيل الفيديو بس.
المختبر الجنائي هو بعتقد يعني حلم كبير لكل منظومة العدل في أي دولة في العالم.
المختبر الجنائي الفلسطيني هو إدارة من إدارات الشرطة الفلسطينية، ويعمل تحت إشراف السيد اللواء حازم عطلة مدير عام الشرطة، وذلك بتكليف من السيد وزير الداخلية. حاليا لدينا في المختبر 5 أقسام.
قسم إدارة الدليل في المختبر الجنائي، وهو القسم المعني باستقبال وتخزين الأدلة، استقبال الدليل من الجهة طالبة الفحص بحيث يتم تفقد الدليل من حيث سلامته وسلامة تخزينه، ويتم التأكد من سلامة هذه الإجراءات. بعدها يتم تخزين الدليل لحين تسليمه للجهة طالبة الفحص.
يقوم قسم كشف التزييف والتزوير بالعديد من المهام والخدمات التي تساعد في النهوض بقطاع العدالة ومساعدة قطاع العدالة. نذكر من هذه المهام قرنة الخط اليدوي والتواقيع، نقوم كذلك بفحص العملات، فحص الوثائق والمستندات، بالإضافة إلى فحوصات في الطباعة.
قسم فحص الأسلحة النارية وآثار الأدوات. عندنا في القسم بنقدم الخدمات المتعلقة بالمقذوفات النارية والظروف الفارغة وربط بالسلاح المشتبه فيه من مسرح الجريمة. كمان فحوصات متعلقة باستعادة بناء مسرح الجريمة. في هذا القسم خدمات منها فحص الأسلحة النارية وأمانها، معرفة سلامة السلاح الناري بهدف ترخيصه.
قسم فحص المخدرات والآثار الكيميائية. طبعا نقوم بهذا القسم بإجراء الفحوصات التحليلية للمواد المخدرة بكافة أنواعها، منها النباتات، العقاقير الطبيعية والعقاقير المصنعة، بالإضافة إلى السلائف الكيميائية. هنا جهاز GCMS. طبعا هذا الجهاز بيقوم على مبدأ كروماتوغرافيا الغاز، بنفحص عليه كافة أنواع المخدرات. التقنية الثانية جهاز GCTD20. طبعا هذا الجهاز نفحص عليه الغازات والحرائق. قسم الفحوص البيولوجية، هذا القسم قيد الإنشاء، حيث نقوم بالتدريب مع خبراء كنديين ذوي اختصاص في مجال العلوم الجنائية.
تم تمويل المختبر الجنائي من قبل أصدقائنا في الحكومة الكندية. يعد المختبر الجنائي الفلسطيني من أهم ركائز قطاع العدالة في فلسطين، حيث تم افتتاحه في أواخر عام 2016، وذلك لتقديم المساعدة للجهات التحقيقية أو أقسام التحقيق في الشرطة الفلسطينية والأجهزة الأمنية، وذلك لتعزيز قدراتها في التحقيق وتقديم الأدلة اللازمة للإجراءات المقاضاة في المحاكم والنيابات. شكرا لكم. طبعا أول صورة طبعا احنا زي ما حكينا في اخر هذا الفيديو والمختبر لتقديم الخدمات للناس اللي بيشتغلوا في التحقيقات الجنائية. وطبعا احنا بشكل متأخر بفلسطين أنشأنا هذا المختبر نتيجة إعاقات كثيرة كانت بسببها الاحتلال، لأنه احنا لاحظنا من بداية نشأة السلطة الفلسطينية على أراضي فلسطين كان في إعاقات لتطوير هاي المؤسسات والسماح لها باستخدام تكنولوجيا حديثة وعالية في التحقيقات الجنائية. فللأسف يعني كمان إحنا أكثر من مرة دمروا لنا المختبر الجيش الإسرائيلي ومنعونا من استخدام أجهزة حديثة في التحقيقات. لكن في بداية 2010 تم السماح لنا بإنشاء هذا المختبر وتم إنجازه خلال 5 سنوات لنتيجة الاحتياج الضروري لتأهيل طواقم وتكون عالية، تأهيل عالي لهم بحيث انه يكون مسموح لهم انهم يشتغلوا في مجال العلوم الجنائية. فيجب توفر الخبرات الكافية للوقوف امام المحاكم ويكونوا معهم شهادات حسب المعايير الدولية للقدرة على تقديم الشهادات في هذه المحاكم. فاشتغلنا بشكل مكثف ودقيق جدا على بناء القدرات البشرية عندنا. أهلنا 19 خبير بتخصصات المختلفة اللي تم ذكرها بالفيديو يحملوا شهادة الخبرة الدولية، حيث تم عمل فحوصات الكفاءة لهم من خلال مؤسسات دولية ونجحوا فيها واجتازوا هاي الامتحانات والفحوصات، وبناء على ذلك هم حصلوا على شهادة الخبرة من وزارة العدل. وعندنا حاليا احنا 19 خبير وهم النواة الأولى للخبراء جنائيين في فلسطين. طبعا احنا بدأنا من حيث انتهى الآخرون، مش مبتدئين في هذا المجال. المختبر الجنائي في السنوات الأخيرة حقق إنجازات كبيرة في الجرائم والتحقيق فيها، وكانت لها صدى كبير عند الناس المختصين وخاصة مجلس القضاء الأعلى والنيابات. خبراءنا كمان حصلوا على شهادات عليا من جهات مختصة سواء في الاتحاد الأوروبي أو في الولايات المتحدة الأمريكية، وخضعوا لفحوصات في مختبرات خارجية، ويعني وهم يعني مؤهلين بشكل عالي للعمل في المختبر الجنائي. حاليا المختبر طبعا بشهادة النيابات والمحاكم حقق قفزة نوعية في إجراءات المقاضاة في المحاكم عندنا، وهذا هو الإنجاز اللي يعني اللي بلمسوه اللي بيشتغلوا في هذا القطاع وبيعرفوا قديش الفرق كبير حاليا بين العمل في إجراءات المقاضاة وبين السنوات السابقة. ساعد هذا الحكي على توفير جهد كبير للناس المختصين وخاصة للنيابات اللي هي بتباشر التحقيق في جميع الجرائم، وتوفير الوقت والجهد لهم، بالإضافة إلى أنه السرعة في إجراءات المحاكمة اللي بتتم حاليا تختلف عن السابق. بالإضافة إلى أنه أصلا هو يعني استخدام التكنولوجيا في التحقيقات هو الأساس منه للمحافظة على حقوق الإنسان والوصول لمحاكمات عادلة وعدم الوقوع في الأخطاء، لأنه عدم وجود أدلة إثبات حقيقية ومقنعة لدى القضاء بتؤدي إلى اتهام ناس ممكن يكونوا بريئين أو عدم الوصول للحقائق في الجرائم الكبيرة خاصة. يعني المختبر الجنائي طبعا سد هاي الفجوة بشكل كبير. حاليا احنا بنغطي فحوصات وخدمات لأكثر من 90% من أنواع الأدلة الجنائية اللي ممكن تجمعها الأجهزة الأمنية أو أجهزة التحقيق اللي بتشتغل في مسرح الجريمة. جميعها بنقدر احنا نفحصها ونصدر فيها تقارير فنية ونقدمها للمحاكم. طبعا احنا حتى نشتغل بهذا الموضوع لازم نكون او حرصنا على ان نطبق جميع متطلبات أنظمة الجودة والمعايير الدولية بهذا الموضوع. فمختبرنا حصل على شهادة الاعتماد حسب المواصفة الدولية الايزو 17025 المختصة بالمختبرات الجنائية، وتم اعتماده من مؤسسة المواصفات والمقاييس محليا، وحصلنا على هذه الشهادة منهم للسنة السابقة، وحاليا يتم إن شاء الله تجديدها لأن سنويا لازم تجدد، وهذه بتعطينا الثقة والمصداقية للعمل مع المحاكم، بالإضافة إلى أنه إحنا جاهزين نتعامل مع أي محاكم دولية ممكن أنها ترفع قدامها قضايا تخص الشعب الفلسطيني عالميا. فزي ما حكيت انه احنا جميع هاي المتطلبات احنا بنطبقها، بالاضافه الى انه بيجي عندنا كمان احنا ناس شركات مختصه عالميه بيعملوا عندنا اوديت كل سنه، بيشرفوا على جميع الاجراءات الفنيه والاداريه وسير العمل داخل المختبر، وبيعطونا شهادات او تقارير لهذه المؤسسات الدوليه بخصوص النظام الجوده المعمول فيه عندنا حاليا. اساس العمل زي ما حكيت عندنا احنا نظام الجوده، وهو دستور لانه اللي بيتعامل مع ادله جنائيه لازم يتعامل بدقه عاليه جدا لكي نحافظ على الادله اللي بتجينا وما يتمش فيها اي عبث او تغيير او تغيير النتائج اللي بتتم فيها. فبنطبق نظام الجوده اللي هو بيحرص يعني في البنود تبعته حرص كامل على عدم القدره على تغيير اي نتيجه او العبث فيها او تغيير محتوى اي قضيه. هذا بخصوص الجوده. طبعا احنا كمان احنا ملتزمين بجميع قوانين السلام العام المحليه، وعندنا بروتوكولات موقعه مع جميع الجهات المحليه حسب القانون الفلسطيني. سلطه البيئه عندنا احنا بروتوكول تعاون معهم للمحافظه على البيئه، بالاضافه الى وزاره العمل وجميع القوانين المختصه، لان هذه كمان هي جزء من متطلبات نظام الجوده والايزو 17025. جميعها طبقناها في المختبر ومعمول فيها، بالاضافه الى ان احنا كمان عندنا اتفاقيات مع شركات محليه او مع شركه بير زيت بالاخص للادويه بخصوص التخلص من المواد المخلفات الكيماويه، وهذا كمان ضروره للاعتماد. هذا بخصوص الجوده والسلامه العامه. كمان احنا بنشارك في خاصه في موضوع كشف التزييف والتزوير والمحافظه على البيئه، بنشارك مع مؤسسات كثير هنا التعاون، بالاضافه ان احنا بنقدم تدريب، يعني قدمنا لمئات الموظفين السلطه في الوزارات خاصه وزاره الخارجيه، وزاره العدل، وزاره الداخليه، وقدمنا لهم تدريب في مجال الكشف عن التزييف والتزوير، واهلناهم بحيث يكونوا قادرين على كشف اي خلل او تزوير في اي وثيقه رسميه حكوميه. بالاضافه ان احنا بنشتغل كمان على يعني موضوع اللي هو مقارنه الخطوط والتواقيع، وهذا عمل مهم. كمان في مئات القضايا بتيجينا احنا وعندنا ناس مؤهلين بشكل عالي بهذا الموضوع، حلينا مشاكل كثير بهذا الخصوص. كمان في عندنا احنا تعاون مع الجامعات وعلى راسها زملائنا في جامعه النجاح، وعملنا احنا وياهم اكثر من بحث مع الدكتوره بسمه بخصوص المخدرات واثرها وتركيبتها كمان، وان شاء الله راح يصدر قريبا ابحاث بهذا الخصوص في مجلات عالميه كمان. كمان احنا بخصوص التعاون بخصوص الاقسام الجديده وتوفير خدمات اخرى بهذا الخصوص، حاليا نعمل على تاسيس اللي هي الخدمات الفحوص البيولوجيه في قسم جديد راح يعمل نتيجه الحاجه له. طبعا في معظم دول العالم في توجه بهذا الخصوص انه الكل بركز على الجينات، على الفحوص الجينيه للتوصل الى الجناء وجمع ادله بيولوجيه من مسارح الجريمه. بدانا السنه الماضيه في تاسيس هذا القسم وقطعنا شوط منيح فيه، ان شاء الله يعني نتوقع في نهايه العام القادم راح نكون قادرين على تقديم هاي الخدمه في الفحوص البيولوجيه كمان لقطاع العداله، وراح تعمل كمان نقله نوعيه للمختبر الجنائي عندنا، وراح تضيف خدمات جديده وتساعد في التحقيقات الجنائيه لجميع العاملين بهذا الخصوص. طبعا احنا وقتنا قصير يعني بدناش ناخذ اكثر من وقتنا، يعني يمكن الكلام كثير عن الموضوع. انا ما حركتش فيهم كثير يعني نسيتهم انا هذول الصور. على كل حال يعني هي صور يعني كانت تحكي عن طبيعة عملنا يعني وكيف بيتم العمل في الأقسام، وبعض الصور من داخل المختبر كيف يتم التعامل مع الأدلة الجنائية وفحصها. طبعا في نحن نظام الجودة هي كلها تتعلق في يعني عندنا معايير و إجراءات موحدة للعمل عندنا ثابتة لا يمكن تغييرها، الموظف ما بيقدر يغيرها، ملتزمين فيها، وهي الجزء الأساسي من عملنا. طبعا احنا في عندنا كمان نخرج بعض المرات على مسارح الجرائم الكبرى، خاصة جرائم القتل. في عندنا فريق مختص بيطلع من رام الله على جميع المحافظات بيشارك في جمع الأدلة بالجرائم الكبرى يعني، وبنجمع الأدلة ونجيبها على المختبر يتم تشخيصها وتحليلها وإصدار النتائج فيها. أي كمان زي ما حكينا نقدم تدريب للوزارات ولجهات كثيرة كمان. صور كثيرة يعني. أنا بشكركم على حسن الاستماع. حبينا نعرفكم عن مختبرنا جديد، طبعا هو المختبر الأول والوحيد بفلسطين. إن شاء الله إحنا رح نستمر في بناء القدرات عندنا، وبنشتغل حسب المطلوب، حسب المعايير الدولية وحسب أفضل الممارسات اللي بتتم في الدول الثانية. إحنا على علاقة جيدة مع مختبرات اللي في المقدمة في العالم، سواء في أوروبا أو في قارات أخرى، وبنتواصل إحنا وياهم ومشاركين في مجلات علمية دولية، بالإضافة إن إحنا نحضر المؤتمرات اللي بتخص العلوم الجنائية بشكل دوري كل سنة، وبنشوف شو التطورات القائمة على هذا المجال، من شأن نبقى كمان إحنا في المقدمة نخدم هاي البلد ونقدم لها أفضل الخدمات لمواطنيها. وشكرا لكم، وشكرا لإتاحة هاي الفرصة لنا احنا نعرفكم عن المختبر الجنائي. طبعا هو مختبر جزء منه طبي يعني، يمكن بيتعلق في الشغل تبع معظم المختبرات والناس اللي اشتغلوا في المؤتمر هون يعني. فعشانك حبينا احنا نكون مع زملائنا نشاركهم، وممكن يستفيدوا منا ونستفيد منهم في خبراتهم طبعا للمختبرات الأخرى والجامعات القائمة هون في المستقبل القريب. وشكرا لكم.
شكرا عميد
حدا بحب
المهندس.
يسأل ولا فيش أسئلة؟
بدنا نسألهم في أسئلة ولا لا يا جماعة الخير؟ إذا حدا بحب يستفسر عن فحص مخدرات، كيف يدلف عن الطريق. يعني المخدرات على فكرة من الفحوصات اللي كثير مش سهلة، وبجوز الصبح كانت في محاضرة بتحكي عن الماس سبكتروسكوبي والنيو سينثيتيك دراجز. ريلي ذي ار نايت مير، لأنه في كثير ناس بيلعبوا فيها وبتتغير مع الوقت. فإذا فيش حد عنده سؤال احنا بنتشكرك بريجادير. طبعا شكرا على المعلومه هاي، احنا ما احناش خبراء في هدول. شكرا جزيلا، يعطيك العافيه. اهلين، يا اهلا وسهلا. السلام الله يخليك، حياك الله يسلمك.
Now we are going to our next speaker, Asma Walid al-Najjar from Khan Yunis. She finished her master degree from Al-Jamia Al-Islamiyya 2021. Asma, she will talk about, just a moment, in vitro anti-cancer activity of novel series of uric acid hydroxides derivatives individually and combined with olive leaves extracts. So Asma, the stage is yours, you can start.
وبركاته. أتشرف اليوم بكوني بين ثلة من الباحثين والعلماء في المؤتمر الدولي الفلسطيني 11 للطب المخبري. وأبدأ بملخص بحثي الموسوم بعنوان In vitro anti-cancer activity of novel series of uric acid hydroxide derivatives individually and combined with olive leaf extract. يعد الكانسر من أهم وأكثر التحديات التي يواجهها العلماء والأطباء في عصرنا الحديث. فبالنظر إلى منحنيات الإصابة في السنوات الماضية نجد ازدياداً في عدد الإصابات. فبحسب موقع جلوبوكان للعام 2020 وصل عدد الإصابات في العالم إلى أكثر من 19 مليون إصابة، كما وصل عدد الوفيات إلى حوالي 10 مليون حالة وفاة. من جميع الفئات العمرية، بينما يتوقع أن تصل حالات الإصابة في العالم في العام 2040 إلى أكثر من 30 مليون إصابة وأكثر من 16 مليون حالة وفاة من كلا الجنسين. على الصعيد الفلسطيني وبحسب تقرير وزارة الصحة الفلسطينية للعام 2020 فقد احتل الكانسر المرتبة الثالثة ضمن أكثر الأمراض المسببة للوفاة بعد الكارديوفاسكولار والدايابيتس ميليتس ديزيزز. أما فيما يخص السيرفيكال كانسر فقد احتل المرتبة الخامسة ضمن أكثر أنواع الكانسر شيوعاً بين النساء في قطاع غزة في الفترة ما بين 2009 إلى 2014 بمعدل حدوث 21.9 لكل 100,000 نسمة. وبالحديث عن الكانسر تريتمنت فقد انتشرت أنواع مختلفة من الكانسر تريتمنت حول العالم، فبجانب التراديشنال ثيرابي ظهرت أنواع أخرى من التريتمنت منها الاميونوثيرابي والادجوفنت ثيرابي والتارجتد ثيرابي، لكن اللي بيحدد نوع التريتمنت هو التايب والفيس للكانسر. مع مرور الوقت بدأت تظهر مشاكل وعيوب مختلفة للكانسر تريتمنت وبالأخص للتراديشنال تريتمنت، منها ظهور الدراج ريزيستنس والتوكسيسيتي لبعض الدراجز بالإضافة إلى السايد إفكت، مما دفع العلماء للبحث لإيجاد حلول جديدة وإيجاد علاجات جديدة أكثر فعالية وأمان. سلك العلماء استراتيجيات مختلفة في البحث، فمنهم من شق طريق الكيمياء للبحث عن مركبات جديدة ومن ثم تقديم الأنتي كانسر إفكت لها. ومن ضمن المركبات التي وجدوا أن لها خصائص طبية متنوعة منها أنها تعمل كأنتي كانسر ايجنت هي مركبات الأسيد هيدرازايد ومشتقاتها. شق آخر من العلماء فضلوا أنهم يتجهوا لجانب الطبيعة والبحث بين الأعشاب والنباتات، فوجدوا أن مستخلص أوراق الزيتون يمتلك خصائص طبية متنوعة ومنها أنه يعمل كأنتي كانسر ايجنت، وهذا يرجع إلى طبيعة غناء بمركبات البوليفينولز المتركزة في الأوراق. فريق ثالث من العلماء قالوا إنه إحنا بدنا نعمل كومبينيشن ما بين الدايتري كومباوند والنيو كانسر دراجز أو الكونفنشنال دراجز، وفعلا كان في إيفيدنس لوجود سينرجستيك أنتي كانسر إفكت. ومن هنا كان هدف الدراسة العام وهو تقييم الأنتي كانسر إفكت لسلسلة جديدة من مشتقات حمض الفوريك هيدرازايد منفردة ومدمجة مع مستخلص أوراق الزيتون. أما بالنسبة للسبيسيفيك أوبجيكتيف فكانت تقييم الأنتي كانسر إفكت لسلسلة جديدة من مشتقات حمض الفوريك هيدرازايد على خلايا سرطان عنق الرحم من نوع هيلا، من ثم اختيار المركبات الأكثر فعالية، ثم أخذها وعمل كومبينيشن مع مستخلص أوراق الزيتون وتقييم الأنتي كانسر إفكت على خلايا الهلة، ثم دراسة أي ساينز للأبوبتوزيس من خلال عمل كروموزومال كوندنسيشن لا لتريتد سيل من خلال تجربة الهوتشست ستين، ومن ثم دراسة تأثير أي سمية للمركبات على الخلايا الطبيعية من نوع الليمفوسايت. أهمية الدراسة: تكمن أهمية الدراسة بالتزايد المستمر لعدد الإصابات بالكانسر في قطاع غزة، بالإضافة إلى ظهور مشاكل مختلفة للكانسر تريتمنت وبالأخص الكيموثيرابي وما ينتج عنها من سايد إفكت من جانب، ومن جانب آخر وجود إيفيدنس بأنه الكومبينيشن ما بين الدايتري كومباوند والكانسر دراجز بيعمل سينرجستيك أنتي كانسر إفكت، وبالتالي الحصول على علاجات أكثر فعالية وأكثر أمان. منهجية الدراسة: تلخصت منهجية الدراسة بعدة خطوات، أولها البريباريشن والإكستراكشن للأوليف ليفز باستخدام نوعين من السولفنت هما الديستلد ووتر و80% ميثانول، من ثم تحضير الستوك سوليوشن من المركبات الكيميائية والمستخلصات. بعدها عملنا سيل كلتشر وسيدنج والتريتمنت بتراكيز مختلفة من السنجل والكومبايند دراجز. من ثم عملنا من ثم قيمنا السيلفيابيليتي من خلال الامتي تي اس اي، وبعدها عملنا تحليل لنتائج الكومبينيشن من خلال الكمبيوسين سوفت وير. والكشف عن اي ساينز للابوبتوسيس عملنا الكروموزومال كوندنسيشن من خلال تجربه الهوتشست ستين. بعدها قمنا بدراسه التوكسيسيتي لهي المركبات على الخلايا الطبيعيه من نوع الليمفوسايت. النتائج أظهرت النتائج إن المركبات 6 و7 و8 كان لها inhibitory effect من ضعيف إلى ضعيف جدا، وكان المركب 9 هو الأفضل من بين هذه المركبات، حيث زاد الانهبيتوري effect من 10.9 إلى 52.5 مايكرومولر بعد التريتمنت ل 24 ساعة، وبعد التريتمنت ل 48 ساعة زاد الانهبيتوري افكت من 18.6 إلى 68%، بينما بالأوليف ليفز extract distilled water، بينما زاد في distilled water olive leaf extract بعد التريتمنت ل 24 ساعة من 9.4 إلى 93.3 في تراكيز متدرجة من 100 إلى 400 مايكروغرام بير مل. وبعد التريتمنت ل 48 ساعة زاد الانهبيتوري افكت من 3.3 إلى 93% في تراكيز متدرجة من 3.125 إلى 100 مايكروغرام بير مل، بينما عند استخدامنا للميثانوليك أوليف ليف إكستراكت زاد الانهبيتوري افكت من 6 إلى 95.3% بعد التريتمنت ل 24 ساعة، وبعد التريتمنت ل 48 ساعة زاد الانهبيتوري افكت من 32.5 إلى 98% على تراكيز متدرجة ما بين 100 إلى 400 مايكروغرام بير مل. بينما فيما يخص نتائج الكومبينيشن وبعد تحليل النتائج من خلال الكمبيوتر سوفت وير، أظهرت النتائج أن جميع النسب المستخدمة في الكومبينيشن ما بين الديستل أولي والمركب 9 أعطت أنتاغونيزم باستثناء النسبة 3 إلى 1، فقد أظهرت سينرجيزم بيزيد مع الوقت عند ارتفاعنا بالتراكيز. بينما أظهرت نتائج الكومبينيشن ما بين المركب 9 والميثانوليك أولي سينرجيزم عند كل التراكيز المستخدمة بنسبة 1 إلى 3. الصورة أمامنا بتوضحنا الكروموزومال كوندنسيشن بعد ما عملنا تريتمنت للخلايا بالسنجل والكومبايند دوزز من الميثانوليك أوليف ليف إكستراكت والمركب 9. بعد ما عملنا تريتمنت من التو دراجز على الخلايا الطبيعية، أظهرت إنه بأكثر التراكيز التي أظهرت inhibitory effect وجدنا إنه هاي الدراجز ما أظهرت أي توكسيسيتي تذكر تجاه خلايا الليمفو بالمقارنة مع الهيلا سيلز. في الكونكلوجن استنتجنا في الدراسة أن جميع المركبات المستخدمة أظهرت أنتي كانسر إفكت من ضعيف إلى متوسط، وكان الأفضل من بين هذه المركبات هو المركب 9 اعتمادا على التايم والدوز. كما أظهرت نتيجة الكومبينيشن ما بين الديستلد ووتر أوليف ليف إكستراكت والمركب 9 أنتاغونيزم إفكت عند جميع النسب المستخدمة باستثناء النسبة 3 إلى 1، فقد ظهر سينرجيزم إفكت عند ارتفاعنا بالتراكيز. كما أظهرت نتيجة الكومبينيشن ما بين الميثانوليك أوليف ليف إكستراكت والمركب 9 سينرجيستيك إفكت من ضعيف إلى متوسط عند جميع التراكيز المستخدمة بنسبة 1 إلى 3 اعتمادا على التايم والدوز. كما أظهرت نتائج التو تريتمنت على الخلايا الطبيعية أن كل من المركب 9 والميثانوليك أوليف ليف إكستراكت سواء السنجل دوز أو الكومبايند لم تظهر أي توكسيسيتي تذكر على الخلايا الطبيعية. في الريكومنديشن أوصت الدراسة بعمل كومبينيشن باستخدام نسب جديدة، كما أوصت باستخدام كلا الدراجز على أنواع أخرى من السيل لاينز، بالإضافة إلى إجراء المزيد من الفحوصات لاكتشاف الميكانيزم المستخدم في السيل ديث، بالإضافة إلى إجراء الدراسة على animal models، إضافة إلى تقييم الأنتي كانسر إفكت لمركبات جديدة. That's it.
Thank you very much, Asma, for a very clear presentation with nice flow of ideas. Any questions? No questions? Do you have any questions, Professor Diamandis?
No questions for the presentation, no.
Okay.
Can you hear me well?
Very difficult name to pronounce. I don't know if I pronounce it the right way or not.
Perfect.
Okay. So Asma, are you online?
Yes.
She's in? No, Asma. Can I ask you a question, Asma?
Yes. تفضل.
Okay. So in future recommendation that you are going to do an animal study on the extract and on the combination between extract and your compound. So how you are going to do that? Are you going to give it orally or I don't know? What's your plan?
ممكن as capsules or anything similar.
But how you think, I mean, you are targeting cervical cancer, isn't it? So do you think that it will be absorbed and then it will go to the cancer cells?
بصراحة بالنسبة بالنسبة للامتصاصية هي في إشكالية عليها في إشكالية بالنسبة للأبزوربشن، إنه حول طريقة الأخذ سواء أورالي أو يعني بدها دراسات، محتاجة دراسات.
Okay, thank you. Okay, thank you very much. So we'll go for the next presentation.
Yeah, okay. Thank you very much. Our next presentation by Dr. Kais Abu Zaitoun. Dr. Kais, he's a fifth year medical student at Najah University. He is interested in the medicine and research. So he's excited to be here for his first ever medical conference. Dr. Kais will present the microbes on the mobile phones of healthcare workers in Palestine. We're going to talk about identification, characterization, and comparison. Dr. Kais, the floor is yours.
Okay, thank you, Dr. Amjad. Thank you, everyone, for being here. My name is Kais Abu Zaitoun. I'm a fifth-year medical student here to talk to you about a research we did. But before we start talking about the research and all the results, discussion, the methodology, I want to ask one question. Why mobile phones? You heard today in the morning, we talked about mobile phones. Now we're talking about mobile phones. But why? Do you know that on average, every one of us uses their mobile phone for 58 times a day? 30 of those times are during working hours. And we might check it for any reason, from taking photos to checking medical information to contacting other medical professionals. But we always forget that these mobile phones may be a source of dangerous microbes or bacteria that can harm us and our patients. Also, this field, this region of studies has been not fully understood in Palestine and around the world in general. So, do mobile phones of healthcare workers present more or carry more pathological bacteria compared to those of non-healthcare workers, with the objectives of investigating the types of bacteria on the mobile phones, to investigate the types of these isolated bacteria and the antibiotic resistance profile for these bacteria. So we can try to link them to hospital-acquired infections, which a lot of patients suffer from. Why our study? Because to the best of our knowledge, we are the first to do a study in this field in the West Bank of Palestine. We're also one of the few studies from around the world that compare the healthcare workers to non-healthcare workers' mobile phones. We are also one of the few studies from around the world that have a questionnaire to try to link some risk factors to the antibiotic resistance and the existence of bacteria on mobile phones. The methodology we adopted was very simple, a study design of a cross-sectional study with the study setting Nablus in Palestine from September 2018 to March 2019. Study population was divided into two groups. Group number one was the group of healthcare workers. It was on any personnel in hospitals, doctors, pharmacists, lab technicians, radio technicians, any personnel working in a hospital. The group two was the group of the non-healthcare workers' mobile phones. It consisted of the engineering students in An-Najah National University. The sample size we calculated was about 300 mobile phones, 200 from the healthcare workers and 100 from the non-healthcare workers. For the healthcare worker group, 100 of these mobile phones were from Hospital A hospital with a good infection control department, and Hospital B was a hospital with a poor infection control department. The data collection consisted of a self-administered questionnaire, which asked about many habits regarding mobile phones, from using mobile phones to cleaning mobile phones. And for the healthcare workers, it had a special section to ask about entry to operating room, using mobile phone next to patients, and why would a healthcare professional use the mobile phone. Then a sterile cotton swab was taken from the mobile screen and transported in a transport media to the lab. In the lab, the identification of the bacteria was very simple. Incubation for 2 days at the right degree on the right agar to plant gram-positive and gram-negative bacteria. Then subculturing every isolate we found. After that, we tested every isolate regarding to the catalase negative or catalase positive, MSA growth test, and a gram stain. From all the isolates we found, we took the gram-positive cocci being coagulase negative or positive cocci, and we did an antibiotic sensitivity test for them. We tested for penicillin, clindamycin, erythromycin, trimethoprim sulfamethoxazole, and cefoxitin. And in case one of these was a cefoxitin resistant bacteria, we did a vancomycin resistancy test. So for a quick recap, we took the bacteria, we isolated every type, and then we did some tests to identify these bacteria. All the coagulase negative and positive staff were taken to an antibiotic sensitivity test. So let's look at our results. First of all, most of our participants were nurses, 45%, followed by medical residents, specialists, technicians, and then the other types of medical professionals. The contamination rate was not significantly different between the healthcare workers group and the non-healthcare workers group, being 87.5, 86 in respect. Males to female ratio was 1.5 to 1, males being more contaminated or having more bacteria on their phones. And there's a very interesting point here that being aware that your phone may carry some harmful bacteria was associated with low microbial growth on these mobile phones. Next, we can look at the non-healthcare workers isolates, 193 isolates, the majority being coagulase negative staph, followed by methicillin sensitive Staphylococcus aureus, followed by other gram-positive cocci and gram-positive bacilli. For the healthcare workers group, again, the majority was coagulase negative staph, followed by methicillin sensitive Staphylococcus aureus, followed by other gram-positive cocci, and then others. Very adverse, a very variety types of bacteria, being 435 isolates. Now, From this presentation, I don't expect anyone to go home remembering that we found 45% nurses and specialists and whatever. But the next slide is the most important one to take home from this. This message we carry here, that the antibiotics we use, penicillin, clindamycin, cefoxitin, erythromycin, and trimethoprim sulfamethoxazole, the resistance was almost doubled in the hospital setting compared to that of non-hospital environment. This is very important to remember when you go home to your husband, to your wife, to your kids, and you give them your phone, that this phone may carry some very dangerous, very harmful bacteria that may harm them. Also, when in hospital or when in the lab, wherever you are, when you want to use your phone, you have to remember that my patient may suffer a lot from my usage of this phone. So is that use necessary or not? We also found some significant correlations, like using mobile phone in the bathroom was associated with contamination with gram-positive bacilli. Entry to the operating room was also associated with a rare frequency of clinic mobile phone, which is very surprising. Healthcare workers' awareness and a low microbial growth from culture swabs was also associated, all being p-value less than 0.05. Also, cefoxitin resistance, or being a MRSA, methicillin-resistant Staphylococcus aureus, was associated with existence of screen breaks, the entry to the operating room, and increased use of mobile phone per day. We have to remember something, that MRSA is a very dangerous type of bacteria. It spreads like wildfires in hospitals, and it's very, very difficult to treat. Erythromycin resistance was associated with entry to the operating room. Trimethoprim sulfa resistance was associated with using mobile phone in the bathroom and being a nurse or a resident in the hospital. No significant findings was found for some factors like type of the phone, existing screen guard, or number of hours spent on the mobile phone per day. So we concluded that more types of organisms were isolated from healthcare workers' mobile phones, and that working in a hospital seems to raise the possibility of antibiotic resistance in these microbes. Increasing this antimicrobial resistance will put more burden on the infection control, also will put us on a higher risk for hospital-transmitted infections. So we can conclude that healthcare workers' mobile phone may be an epidemiological hazard that is dangerous to ourselves, to our patients, to the community, and to our families at home. So we recommend that regular decontamination of phones and hands should always be a habit of us. Also, we should put mobile phones in a sterile, transparent bag while using it next to patients or while using it inside the medical setting. It is also very important to limit the mobile phone use inside our working hours, not just for microbial purposes, but also for productivity purposes. It is also important to have mandatory guidelines for the usage and the cleanage of mobile phones inside the hospital and healthcare settings. I would like to finish by thanking my supervisors and my colleagues, Dr. Hamad Al-Qadi, Dr. Rashid Al-Khayyad, Dr. Muhammad Al-Haj Hamad, Dr. Yazan Naji, Dr. Bisa Marqa, and our amazing lab technicians, Ahmed Musa and Maisa Daqqa. I also like to thank An-Najah National University for providing us with the financial support and the infrastructure needed for the research. Thank you all for being here. Thank you for listening. Thank you for everyone at home. And thank you for organizing this wonderful event.
Thank you for the clear presentation. So if anyone would like to have, yes, please, Dr. Hatem.
يعطيك العافية قيس. Dr. Qais, thank you so much for a very interesting talk. I would like to ask you about, you have said that you collected 200 isolates from 2 different hospitals. You did not show the comparison between the 2 hospitals, because you said also that one of the hospitals were having infection control unit very good, and the other one was loose infection control unit. And how did you decide that this they had a good infection control unit and the other hospital B had a bad infection control unit?
Okay, thank you very much, Dr. Hatem. First of all, I did not show it because, to be honest, there's not enough time to include everything. The difference between 2 hospitals was not very significant, but there was obviously a difference in the types of isolates and the antibiotic resistance between 2 hospitals. The one with the bad or the less active infection control department had more MRSAs and more antibiotic resistance in general compared to the other hospital. As for how did we conclude that this one was better than this one in the antibiotic, in the infection control, well, we looked at multiple aspects of the thing. First of all, the existence of hand hygiene throughout the hospital and always being full and ready to use. Also, the mandatory guidelines of wearing the scrubs inside and the lab coats inside the hospital. Also, specialized clothing for operating rooms, for the ICU, for the ER. These are the criteria we looked at. One hospital that was good with infection control had very, very mandatory guidelines for these things we talked about. The other one didn't really care about what was happening inside the hospital. Thank you, Kahat.
Why you didn't show the results?
Why is it?
You didn't show the question. Yeah.
Yes.
Yeah.
There was no significant difference.
Okay, thank you. Yes.
It would be very nice if you really compare, for example, MRSA, if the people that you investigated, if they can get infection or not, frequent infection from the mobile that they have. I mean, did you take the history of the frequency of infection of these people?
Yes, very good point. Thank you, Dr. Saad. Well, to be honest, this is one of the future plans that we're working on, is trying to link the infections happening to patients with the mobile phones and the microbes on the mobile phones of their physicians or their medical staff working with them. But we know we didn't link it. It was a bit too much for a small research like ours, so it's in the future plans.
How do you think you will link them?
Well,
which way?
There are many options, but the one that's on my mind right now that we can check on the patient, see if he has any infections, and then we can check on the mobile phone of every staff member that went into this patient's room, and we can see if there's any correlation. The only problem with this thing is that you can't really tell which came first, the infection or the mobile phone. But if you want to make it like a time-based event, you need to do it a cohort study, maybe always study the mobile phones regularly, study mobile phones of the physicians and the nurses and etc. And then see if any patient gets infected with any of these microbes.
It wouldn't be an idea to take a swab from these persons that you investigate and see if they have MRSA or not?
From the patient?
Yeah. From the persons, individuals that you, the medical persons or the
yes,
students.
yes, we could do that. But yeah, like I mentioned, the only problem is that it's difficult to know then, did the MRSA came first from the patient or did the mobile phone bring the MRSA to the patient? But yeah, it is a very good idea to start with.
If you check MRSA, it's resistant anyway, it will not change. But if you check and you find that there is difference, and the MRSA in the people is less than on the mobile, then you think, I think that is not from the mobile. So it wouldn't be surprising for me that the mobile or other stuff that you use to be full of microbes.
Yes. Well, that's a very good point, to be honest. We'll work on it, inshallah, in the future.
One more thing.
Yes.
Every day, how many times I have to swap my mobile?
5 times per week. 5 times per week, where the optimal cleaning time for the...
And how?
How? Alcohol wipes were the best method we investigated. Being the easiest to use and the most efficient also.
And the mobile will not?
No, it will not be damaged.
Okay. Thank you.
You're welcome. Any more questions?
Okay. Okay, thank you, Dr. Kais.
You're welcome. Thank you very much.
Thank you.
Our next speaker is Professor Diamantis. He was with us so far the whole conference. His lecture will be about circulating tumor DNA, a promising biomarker in liquid profiling of cancer. Professor, the floor is yours.
Thank you very much. I'm very pleased to participate in the Palestinian International Conference. Can you please start my presentation? I would like to thank the organizers of the 11th International Palestinian Conference on Laboratory Medicine for the kind invitation. For this presentation, I declare no conflict of interest. Circulating free DNA was initially discovered by clinical chemist Dennis Law in the 1990s, who found that in the serum of pregnant women, there is 5 to 10% DNA of fetal origin. As you know, this discovery has led to the application of circulating free DNA for the non-invasive detection of trisomies in fetuses by using maternal blood. Later, Dennis Law and others have identified cell-free DNA in the serum of patients with cancer. They then thought that they will design something known as liquid biopsy for diagnosis and prognosis of cancer. Liquid biopsy involves obtaining blood or other fluids and then analyzing them, usually by molecular techniques. Liquid biopsy is minimally invasive. It can analyze circulating tumor DNA, tumor cells, exosomes, and other components. As you can see from the slide, peripheral blood is the preferred site for the liquid biopsy by obtaining a tube of blood. But other fluids, such as cerebrospinal fluid, saliva, synovial fluid, ascites fluid, stool, and urine can also be used with equal. One would wonder, what is the definition of circulating tumor DNA? Circulating tumor DNA is DNA originating from cancer cells that has been shed into the bloodstream. And you should remember that the amount of circulating tumor DNA is proportional to tumor size. It is also important to note that healthy cells also release what is known as cell-free DNA into the circulation. If you extract circulating free DNA from normal people, you will usually find about 1 to 10 nanograms of DNA. In this slide, we show how the liquid biopsy is performed. Usually, a tube of blood is obtained and DNA is extracted. This DNA can then be used for analysis by using various techniques, including whole genome sequencing, whole exome sequencing, targeted sequencing, or by looking for gene fusions, copy number alterations, and DNA methylation studies. When performing liquid biopsies, it is very important to understand how this works. An important caveat is that blood contains both normal DNA originating from normal tissues and genetically altered DNA that originates from cancer cells. Genetic analysis could discriminate between the normal DNA and the cancerous DNA by using for mutations, epigenetic changes, and other molecular changes. The ratio of cancer to normal DNA as a percent is importantly known as mutant allele fraction. We know that the higher the tumor volume, the higher the mutant allele fraction, and the easier the analysis. We should remember that when the mutant allele fraction is very low, such as less than 0.1%, we need special techniques to analyze the circulating tumor DNA, which is present in minority in comparison to normal DNA. Let us now show some clinical applications of circulating tumor DNA. Circulating tumor DNA is an excellent prognostic factor for cancer. For example, in a 2016 study of 230 stage 2 colon cancer patients, 100% of those who had detectable circulating tumor DNA right after the surgery relapsed. But more than 90% of those who were negative for circulating tumor DNA did not relapse. This shows that circulating tumor DNA carries very important prognostic information for. Like other tumor markers, circulating tumor DNA can also be used to monitor the progression of the disease. And this is an example with breast cancer, who has been treated at various occasions with ebirubicin, letrozole, and ebirubicin. And you can see here, the blue line represents the circulating tumor DNA, which goes down with the treatment and then goes up with relapse. In comparison to CA15.3, the classical breast cancer biomarker, and circulating tumor cells. And you can appreciate here that the circulating tumor DNA is actually a superior monitoring tool in patients with breast and other cancers. A very important application of circulating tumor DNA involves the monitoring the success of treatment. As you can see here, a patient is treated initially with certain therapy, while is monitored by liquid biopsy for mutations and the intensity of the mutations in circulating tumor DNA. In this case, the circulating tumor DNA analysis shows that the mutations have been reduced and the intensity has been reduced, thus indicating that the therapy is working and should continue. On the other hand, for this patient, you can see that there is progression because the intensity and number of mutations is increased, thus alerting the clinicians to select a new therapy. A very important application of circulating tumor DNA. The amount of circulating tumor DNA in the circulation, as I mentioned earlier, correlates quite well with the size of the tumor. And you can see here that larger amounts of circulating tumor DNA are correlating with larger tumors, advanced tumors, or later stage tumors. While the utility of circulating tumor DNA for monitoring success of treatment and for prognosis is unquestionable, there is a debate in the literature if circulating tumor DNA can be used for the big application of early cancer detection. Many of you have probably heard of a company called Grail, which invested billions of dollars in using circulating tumor DNA for early cancer detection. Grail is embarking on a very big project aiming to enroll 10,000 individuals with cancer and 3,000 healthy individuals and analyze their circulating DNA to find differences between the cancer and the non-cancer, thus developing methods for early cancer detection. The techniques that Grail uses to analyze circulating tumor DNA include targeted sequencing of about 500 genes previously associated with cancer, using whole genome sequencing and copy number variations, whole genome bisulfite sequencing to study methylation status, and also using DNA fragmentation to study the sizes of circulating tumor. Academic investigators have also published on detection of early cancer by using circulating tumor DNA, such as the one paper shown here. In this paper, the authors claim sensitivities for detecting cancer in the area of 50 to 60% at 95% specificity, which are good numbers if they can. Unfortunately, these and other studies suffer from the drawbacks that these investigators have used clinically detected cancers with relatively high mutant allele fraction of 0.1 to 1%, as is shown in the figure. Another approach used by my friend Nicholas Papadopoulos includes combination of circulating tumor DNA with classical biomarkers for early detection of cancer. These authors also claim sensitivities between 70 and 90% and 98% specificity, which are good numbers if they can be. Based on this paper, Nicholas managed to develop a company called Thrive and attracted $110 million in investment to develop this as a. I draw your attention here that my group, as you can see from this publication in BMC Medicine, has raised doubts about using circulating tumor DNA for early cancer detection. Our rationale is very simple. We asked the question if there is enough circulating tumor DNA from small tumors to make a reliable. This slide summarizes our calculations that the tumor of 27 millimeters in diameter can yield about 6 genome copies in the circulation with a tube of blood, thus likely being able to make the detection possible. However, as the tumor gets smaller to about 6 millimeters in diameter, the mutant allele fraction is so low that you cannot retrieve even a single genome for molecular analysis, thus making the diagnosis important. Here I draw your attention briefly that not only the sensitivity of a cancer test is important, but also the specificity. And it is now well known that mutations can be found in circulating free DNA from normal people, especially due to a precancerous condition called clonal hematopoiesis. I conclude this presentation by mentioning that if an asymptomatic individual undergoes cancer screening, it is possible that you get a true positive, which is what you want, but it is also possible that you get a false positive, and these false positives can lead to unnecessary interventions for the patient. We predict that the results of many tests will be equivocal without any true conclusion. It could be also false negative, thus reassuring people that they don't have cancer when they actually do. I close this presentation by thanking my students Claire Fiala, Annie Ren, Dorsa, Sohai, and Kaitlin Di Paolo for helping me with preparing this presentation.
Thank you very much, Professor Diamantes. Any questions from the audience? No questions? I have a question. I didn't get the slide that you were talking about AML and MDS. So what was the point?
It is now known that people who appear normal, they have no disease as yet manifest. They may have a disease called clonal hematopoiesis, which is a precancerous situation. When you do liquid biopsy, as we said, you isolate DNA and do mutational analysis. It is possible that you detect mutations that are related to clonal hematopoiesis, which means you're not detecting a cancer patient, and this one is a false positive. So it affects the specificity of the test. It is now very well known that this is a huge problem because about 5% of people, especially older people like me, they have increased incidence of clonal hematopoiesis. If you look at the literature, there is a huge amount of recent literature, and we have authored a review, if somebody wants to see, addressing the issue of clonal hematopoiesis, but also addressing the issue that now people believe that a lot of normal people carry mutations in their blood and in some tissues like the esophagus without actually having cancer. So the presence of a mutation is not necessarily equivalent to a person having cancer.
Okay. And we heard many presentations today about, and yesterday about liquid biopsies, but most of them are research. Could you elaborate more? Which of the tests already routinely used in medicine or in hospitals for diagnosis?
Yes, as I said before, the liquid biopsy is very valuable for prognosis, for assessing response to therapies, and is now offered to patients on a on a selected basis, because at the end of the day, it depends on who pays for it. So there are private companies who actually offer the test on a fee for service, like Natera and so on. You can send them the samples and they do the analysis, because the analysis is not easy to do. And selected big cancer centers are doing it in-house. Obviously, you're not going to find a liquid biopsy in a peripheral hospital as yet.
But if we use very specific techniques for the low math, like digital droplet PCR, which can pick up and detect one copy of mutation, is that possible to increase the sensitivity of the liquid biopsy?
Yes, the liquid biopsy, especially for early detection, are using the best, the most sensitive technologies for sequencing, for detecting mutations, like digital droplet PCR, as you mentioned, and other techniques. You cannot see anything. But my point, which is raised in the review that we published, and I recommend it for people to scrutinize it, is that if you take a tube of blood and there is not enough DNA that is coming from the tumor, you will not be able to retrieve any DNA that is coming from the tumor. So no matter what you use, if the DNA is not there because of the tumor is very small, you're not going to find anything, no matter what technique you will use. You agree with me that if it's not there, you will not find it.
Yeah, okay.
This is what our elaborate calculations have shown, that the lowest tumor diameter you can see with this technology is now between 6 and 10 millimeters, which is very close to the sensitivity of imaging. So we will see now the UK government has contracted a company called Thrive to run 200,000 tests on the British population to see if they can detect cancer early. Grail, sorry, they gave a contract to Grail, multi-million-dollar, to screen 200,000 UK population, and you will see how many true positives they will find, and most importantly, how many false positives, because as you know, with the screening asymptomatic individuals, specificity of the test is very important, because even if the specificity is 99%, if you do the calculations, you will see our papers, the so-called positive predictive value is very low at 1% or 2%. So we'll see what the results of this investigation will show very soon.
Okay, thank you very much for your information.
Thank you for inviting me.
Okay, thank you very much. Our next presenter, Dr. Mariam العريفي. الأستاذة مريم رائد الريفي، نطلع ريفي سوري، بكالوريوس وماجستير التحاليل الطبية من الجامعة الإسلامية بغزة. نشرت العديد من الأبحاث حول مقاومة البكتيريا للمضادات الحيوية. كانت تعمل في الجامعة الإسلامية وحاليا محاضر بجامعة الإسراء. البرزنتيشن موضوعها Antibiogram of Bacterial Isolates from Clinical Specimens at Al-Aqsa Hospital, Gaza, Palestine. Dr. Mariam, the floor is yours. معنا online هي.
خلال جائحة كورونا وما بعد. بحثنا بعنوان antibiogram of bacterial isolated from clinical specimens at الأقصى Hospital Gaza, Palestine. نبدأ بمقدمة بسيطة عن حقائق لعدوى المستشفيات ومقاومة البكتيريا للمضادات الحيوية. مشكلة مقاومة البكتيريا للمضادات الحيوية لا تكمن فقط في تطورها وزيادة هذه المقاومة، وإنما بانتقال هذه السلالات المقاومة من شخص لشخص، خصوصاً في مرضى الرعاية الصحية. Healthcare associated infection or infection acquired in healthcare setting هي أكثر الأحداث السلبية شيوعاً في تقديم الرعاية الصحية، ليس فقط في فلسطين أو قطاع غزة خاصة، وإنما في جميع أنحاء العالم. هذه المشكلة بتسبب وفيات كبيرة وبتسبب خسائر عالمية عالية سنويا. لو بدنا نقارن نوع الأكوايرد أو الانفكشن أكوايرد in healthcare setting بالدول المتطورة والدول النامية، حنلاقي إن الدول المتطورة أكثر انفكشن منتشرة هي الUTI، أما في الدول النامية وأيضا في قطاع غزة بسبب ظروف الحروب اللي موجودة فيها، فإنه السيرجيكال سيت انفكشن هي أكثر شيوعاً. الICU acquired infection في الدول النامية بتكون عالية ب3 أضعاف بالمقارنة للدول المتطورة. الأنتي مايكروبيال ريزيستنس في قطاع غزة يزداد من سنة لأخرى حسب الدراسات المنشورة مؤخرا على عدد من المستشفيات من قبل مختلف الجامعات في قطاع غزة. يرجع هذا السبب لعدة أسباب مثل uncontrolled use, misuse and overuse of antimicrobial. أيضا يرجع للممارسات لمكافحة العدوى السيئة. The poor infection control practices in healthcare system. لذلك دعت الحاجة لمثل هذه الدراسة، فالهدف الأساسي لهذه الدراسة كان investigate the susceptibility pattern of bacteria isolated from different bacterial infections to commonly used antimicrobial from Al-Aqsa Hospital in Gaza, Palestine, and determining the most common bacterial pathogen from the various infection at Al-Aqsa Hospital. طريقة الشغل لهذه الدراسة استهدفت مستشفى الأقصى بدير البلح، وهي مستشفى مركزية لمدينة دير البلح التي تقع في جنوب القطاع. يستهدفها جميع مواطنين دير البلح وعدد من المخيمات الواقعة في جنوب القطاع. نوع الدراسة cross sectional study ضمت العينات ما بين سنة 2018 ل 2020. كانت عدد العينات 8062 عينة. تم نقل هذه العينات لمختبر الميكروبيولوجي في مستشفى الأقصى والتعرف على البكتيريا في العديد من الفحوصات مثل جرام ستين كاتاليز كواجوليز molastic activity and the API quantity and other. فرقنا ما بين البكتيريا جرام بوزيتيف اند جرام نيجاتيف. بعدها عملنا فحص السسبتابيليتي تيست في المولر هنتون اجار واختيار المضادات الحيويه المناسبه حسب CLSI guideline. طبعا حللنا النتائج باستخدام SPSS وتم اخذ الموافقه الاخلاقيه من مركز البحوث في الجامعه الاسلاميه في غزه. الريزلت عدد العينات كما أسلفنا سابقاً 8062. 43.6 كانت للأدلت، للتشايلد 40%، الإنفانت 16%. نسبة البوزيتيف كلتشر لمجموع العينات ككل كانت 22.1%، أي 1781 عينة. كانت مختلفة ما بين ستول، يورين، باس، ear, eye, nose, swab and CSF. أعلى نسبة بوزيتيف كانت لصالح eye, ear, nose, swab and الباس، وأقل نسبة للبوزيتيف كانت للCSF. بعد التعرف على البكتيريا قسمنا العينات البوزيتيف حسب العزلات إلى 4 أقسام. أول قسم الانتيروبكتيرياسي وهي أعلى نسبة في العزلات. أعلى سبيسي كانت الشيشة كولاي تقريبا 38.2 والكليبسيلا 14.2. المجموعة الثانية السودوموناس والنون فيرمنتر، أعلى عزلة منها كانت السودوموناس سبيسي وتليها الأسنيتوباكتر. المجموعة الثالثة كانت الستافيلوكوكس، أعلى عزلات فيها كانت لصالح الستافيلوكوكس أوريوس بنسبة 9.4. والمجموعة الرابعة للستريبتوكوكس أند الانتيروكوكس كانت الستريبتوكوكس فيريدانس هي أعلى نسبة في هذه المجموعة وأقل نسبة الانتيروكوكس. and other وهي المجموعة الأخيرة ضمت اليست الهيموفيلس سبيسي and النيستيريا. الفحص الأخير كان هو فحص الحساسية. وجدنا إنه الأموكسيسيلين للانتيروبكتيرياسي نسبة المقاومة كانت عالية بنسبة 99.3، أما للسودوموناس والنون فيرمنتر كانت 94.1. الأموكسيسيلين نسبة الريزيستنس أيضا عالية 94.8، أما للسودوموناس فهي كانت 100%. الأوجمنتين كانت 78.5 بالنسبة للانتيروبكتيرياسي، أما للسودوموناس والنون فيرمنتر فكانت 88.3 أيضا نسبة عالية. بالنسبة للميروبينيم أيضا كانت نسبة الريزيستنس عالية بالنسبة للانتيروبكتيرياسي 55.2، ونوعا ما قليلة للسودوموناس والنون فيرمنتر فكانت في نسبة 26.3. والتتراسايكلين كانت مقاومة 100% للسودوموناس والنون فيرمنتر. نيجي للجرام بوزيتيف بكتيريا وهي الستافيلوكوكس سبيسي والستريبتو والانتيروكوكس سبيسي. الاموكسيسيلين نسبة الريزيست 89.5، أما للستريبتوكوكس فكانت 100%. السيفتازيديم كانت 73.3 للستافيلوكوكس سبيسي. لو بنلاحظ البانكمايسين نسبة السنسيتيف لعزلات الستافيلوكوكس كانت تقريبا 89.2، وهي تقريبا نسبة مبشرة بالخير نوعا ما بمقارنة مع مقاومة المضادات الحيوية الأخرى. بالنهاية من خلال نتائج هذا البحث نوصي ببعض التوصيات. نوصي بوضع سياسات صارمة بشأن استخدام المضادات الحيوية داخل المستشفيات. أيضا دعم الأطباء في الاختيار العقلاني للعلاج بالمضادات الحيوية. تحديث قائمة الأدوية باستمرار وأخذها من مصادر موثوقة. وأخيرا يجب وضع برامج مثل الستروشيب بروجرام لمتابعة المضادات الحيوية، وهذه مش موجودة في قطاع غزة للأسف. فوائدها إنها بتقلل استخدام المضادات الحيوية وبتقلل هذه المشكلة بشكل عام. Thank you والسلام عليكم ورحمة الله وبركاته.
Thank you very much. شكرا جزيلا دكتورة مريم. نفتح الباب للأسئلة إذا حدا عنده سؤال. أوكي. إيش معناه؟ أوكي شكرا. أوكي.
Our next speaker is Noor Hashashiyah. She is a pharmacist, and she is now a second-year resident in specialized in toxicology at Shakir Al-Hadi University Hospital in Tunisia. Noor, the floor is yours.
Good afternoon, everybody, and welcome to my presentation. This is a great honor to be here with you and to have this great opportunity for oral presentation. Before beginning, let me introduce myself. My name is Noor Hashashiyah. I'm from Tunisia. I'm currently a resident in pharmacy. My specialty is toxicology. The topic of my presentation is clinical toxicology. Today, I would like to talk with you about acute methanol poisoning report of 7 cases of death. I've divided my presentation into 4 main parts. First of all, I'll make a short introduction. Second, we'll look at the methods. Then I'll show you the results and explain the discussion. And finally, the conclusion. So let's get started. Methanol is a toxic alcohol that is found in various household and industrial agents. Methanol exposure can be extremely dangerous, with significant morbidity and mortality if left untreated. We can find methanol in several products: windshield washer fluid, in perfumes, copy machine fluid, in food warming fuel and other types of fuel, in carburetor cleaner, in gasoline and seafoods. The toxic effects of methanol are mainly due to its 2-formaldehyde and format metabolism. Our study includes 7 cases of methanol poisoning. Now let's move to methods. This is a retrospective study about 7 diseases. Several samples, such as whole blood and urine, were collected and analyzed at the hygiene laboratory of Teddy Shaker in Sfax. The first sample, whole blood. In whole blood, the determination of total alcohol was carried out by the Cordoba method. The rapid detection of methanol was made by colorimetric reaction. In fact, the formation of a violet blue ring in the presence of formaldehyde, product of oxidation of methanol by potassium permanganate in presence a sulfuric or phosphoric medium. The second sample is the urine. The urine level of ethanol is calculated by the method ADH enzymatic automated on Cobas Integra 400. Now, moving on to results and discussion. Results: socio-demographic data. The gender: 7 methanol poisoning cases declared between 2020 and 2021. Patients were predominantly male with a sex ratio equal 6. Age: patients' age ranging between 26 years and 61 years, with an average 43 years, plus and minus 14 years. Poisoning circumstances. Our study includes 7 cases of methanol poisoning. Sorry for the S. The poisoning was by oral injection. It was accidental for 6 cases, whereas for 1 case, the ingestion was probably intentional. Suicide attempt after a family conflict and driving the car in high speed. Background: all patients were rural consumers. Pathological history: 1 consumer had the past psychiatric history. No significant medical history was notified. Marital status: only 2 consumers were single. Death circumstances: for the 7 studied cases, 1 died in a public highway accident, while 1 case by cardiovascular arrest in the coma pictures, and the others died in sudden death pictures. methanol and co-occurring illicit and illicit drug use. Co-ingestion ethanol with methanol was reported in 2 cases. Urine ethanol concentration was 0.19 grams per liter and 0.32 grams per liter. For another case, alcohol was consumed with amphetamine. Poisoning circumstances. This graph highlights the different poisoning circumstances. Poisoning is most often due to accidental ingestion or intentional ingestion, and epidemic poisoning due to distilling and fermenting errors and the beverage contamination. The dermal absorption or inhalation is rare. Discussion. Toxic effects of methanol. Methanol is rarely absorbed into the body. The metabolism of methanol is carried out in liver by the enzyme alcohol dehydrogenase. It can be metabolized to highly toxic compounds, formaldehyde and formic acid, that are responsible for the acidosis and the blindness characteristic of methanol poisoning and even death. Let me expand on this point. Several studies have described death from methanol poisoning. In Turkey 2020, at least 44 deaths from bootleg drink made with methanol around the country. In Italy, 1986, the methanol-tainted wine scandal was a fraud perpetrated by adulterating table wine with methanol, poisoning hundreds of people with 19 hospitalized, 23 deaths, and many others heavily injured, blindness and neurological damages. And many other countries have reported methanol death states such as Australia, Brazil, India, Libya, etc. I'll put you the link so that you can exit the site. Before we finish, I would like to leave you with one final thought, that public education about the consequences of methanol consumption and legislative control should be emphasized. So that brings me to the end of my presentation. Thank you very much for your attention and your time.
Thank you very much, Dr. Noor. Any questions? مش موجودة؟
Okay, our last but not least presentation for this session, Dr. Adnan Al-Khatib. Dr. Adnan, he got his MSc in 1991 from the University of Newcastle, UK. He specialized in clinical pathology. He's the founder and chief executive officer of Al-Khatib Medical Laboratory in Damascus, senior lecturer for postgraduate trainee. He's concerned in laboratory association. Dr. Adnan presentation is about vitamin D. What's the cutoff of vitamin D? The floor is yours, Dr. Adnan.
I would like to thank you to thank Dr. Osama Najjar for inviting me to participate in this great event, المؤتمر الفلسطيني الدولي الفلسطيني الحادي عشر للطب المخبري. My talk will be about vitamin D. What's the cutoff point of vitamin D? The awareness of vitamin D deficiency started around 2005, and this article appeared in the Daily Express by Victoria Fletcher raise the awareness of vitamin D deficiency and the importance of the sunshine. The old stone man were of a lifestyle depend on the exercise and exposure to sun, while we are now living in offices with no exercise, which would give an idea why previously they did not have the vitamin D deficiency, while in these recent days, the vitamin D deficiency is really very common. Of course, the iceberg to reflect the issue or the problem of the vitamin D deficiency, what we know is really a little about it. The well-known things were the rickets and the osteomalacia with symptoms, while many things asymptomatic like cancer, autoimmune, cardiovascular, and all listed disorders here are asymptomatic, and it's hidden, and it has got really a big relation to vitamin D deficiency. If we look at what should be measuring here, all these compounds can be measured for vitamin D, but really the one which is really important is the 25-hydroxyvitamin D, which include vitamin D2 and D3. These reference ranges really are well known by many experts of vitamin D and accepted by most of the labs. If we look here, that the deficiency are below 10 nanogram, while the normal or optimal level is from 30 to 70. But what really is the optimal level of vitamin D deficiency? This study showed that the best calcium absorption are from the intestine are done when the vitamin D level are about or above 32 nanogram per ml. Also, the balance of PTH and vitamin D level become disturbed when the vitamin D goes below 30. The vitamin D level the PTH start to rise. So these two most important things, the calcium absorption, the PTH level with its relation to vitamin D, would give us the idea that really the cutoff or the reference range should be around 30. But if we look at these diseases, the things know and which we don't know, actually here it's above 20 are enough, but the others we should look at them. So really here, as I said, rickets and osteomalacia, this study showed that they happen and we would have symptoms when vitamin D level are really below 15 nanogram. 93% of vitamin D deficient would have a level below 15 nanogram per ml. Fracture and falls, the incidence are rise in vitamin D below 30. Bone mineral density, to get a very good bone mineral density, we should have a level about 40 nanogram per ml. So this is all about bone, but is vitamin D limited to bone only? No, it has many other disorders. As I mentioned, all of these has got a relation to vitamin D disorder. Cancer, autoimmune, all these things. Now we are going to see what's this relation. So we should conclude here that the vitamin D cutoff is not as clear cut as this apple. And from that picture, I don't think it's fair to think that all these people should have one cutoff for vitamin D. This man who could be a fat and could be a diabetic, different from this little girl who should be we should be looking for not to care for her not to have rickets, for instance. So it's unfair to think that one cutoff is enough. Vitamin D and its relation to coronavirus, here this study concluded that low vitamin D related to severe presentation and mortality. And from another study, the result divided the patient of coronavirus to 3 groups. People were admitted to ICU had a median level of 14.4, while the other group, 22.4, admitted to hospital but not to ICU, and the other who had a mild non-respiratory syndrome, they had a median 30. So vitamin D has got a big relation with its level to the severity of coronavirus. Blood pressure, pregnant women, and it's the vitamin D relation. If we look at these common things in pregnancy, hypertension, gestational diabetes, and bacterial vaginosis, and we consider the level of 25 as normal for the pregnant, if we push that level to the 40, we would lower the incidence of this disease. We would lower the hypertension by 83%, we would lower the gestational by 33%. So the recommended reference range for the pregnant is between 40 and 60. Myocardial infarction, if we get a level of below 15 nanogram, we would have a 142% increase. Multiple, as I said, autoimmune and diabetes, type 1 and multiple sclerosis, with its relation to vitamin D. In Finland, they have the highest incidence rate. They have 65 per 100. So when they reduced the dose from 4,400, they have got 4 times higher incidence of type 1 diabetes. This study showed when they administered 2,000 over 31 years, they have got a reduction in diabetes type 1 to 78%. As I said, multiple sclerosis, the demyelination of the nerve, also this observation would give us a hint that low exposure to sun, you are 5 times more likely to get multiple sclerosis in Europe and North America, prevalence of MS twice in 37 parallel, exposure to sun below age 15 would make you liable to multiple sclerosis. If you look at this chart, the red represent the multiple sclerosis, the blue line represent the vitamin D level, and you would notice when the vitamin D at the lowest, the multiple sclerosis at the highest. Cancer and vitamin D, it's really these 17 cancer are related to vitamin D level, and when we get better vitamin D level, we get reduction on these cancers. Allergies, when we get a level above 30 nanogram per ml, we get a reduction in allergy. Obesity, obesity is really when we have a low vitamin D level, this leads to insulin resistance and diabetes, overweight. When the vitamin D level between 50 and 70, we get a lower incidence of diabetes in obese patients. So really cutoff depend on how you look at it. We should look at like a system things. I mean, you get rickets and osteomalacia when level of vitamin D below 10, you get false fracture 20 when we would have a cardiovascular protection and mortality, we should have about 40, cancers and autoimmune should be above 50. So if we conclude at that chart, the blue line here represents rickets. So we would get 99% reduction in rickets when the level are around 20 of vitamin D. If you look at the breast cancer, we would get a reduction when we push the level up from 30 to 83 to 50. We will get a reduction in breast cancer in the incidence by 83%. So it's actually this slide would conclude that when levels are around above 10, we would avoid rickets. When it's above, when calcium and endocrine function would be around 30, blood pressure around 32, reduced risk for cancer above 40, reduced flu above 30, reduced periodontal disease. So really we should move reference range to above from 40 to 90, for instance. So it's the message we should convey that really the level of protection depends on the disease. So if we want to protect people from cancer, we should have a level about 50. If we want to protect people from rickets, we should have a level of 20 to 25. This, I would like to thank the Palestinian syndicate for inviting me to do this lecture with many thanks. Thank you.
Thank you very much for the interesting information. Unfortunately, Dr. Adnan is not with us, so we'll go directly to the break till 4 o'clock. There is no break.
Hello. Hello. هذاك مش شغال. Okay. The last session. Now we will have Dr. Hanin Noor. Dr. Hanin Noor is an assistant professor of hematology and immunology. She obtained her PhD from Brussels. She has been awarded Zamala in Belgium and Erasmus International Credit Mobility in Italy, and scholarships and granted, and she got a scholarship, a grant, sorry, from the Palestinian Ministry of Higher Education. Dr. Hanin is a head of Medical Laboratory Sciences Department at Hebron University. The floor is yours, Dr. Hanin.
Thank you. It's my pleasure to start with you the last session with a short and quick presentation about the evaluation of gestational diabetes mellitus among pregnant Palestinian women in the West Bank and the related risk factors. Gestational diabetes mellitus is a condition occurs to pregnant women during pregnancy. It is characterized by high level of glucose in the blood sugar. So it is defined precisely as any degree of glucose intolerance with the onset or first detection during pregnancy. There are two types of gestational diabetes mellitus. Type 1, which has abnormal OGTT with normal glucose level, and this type is modified or is controlled by diet modification and exercise, while type 2, we had abnormal OGTT with abnormal glucose level. And this type is treated with insulin or oral medications. Gestational diabetes is caused by pregnancy hormones, mainly the hormone called human placental lactogen, which acts as anti-insulin, and it decreases insulin sensitivity. Together with cortisol and growth hormones with progesterone, altogether they increase insulin resistance that causes high glucose level in the mother. This high glucose travels across the placenta to reach the fetus and cause what is called hyperinsulinemia. This causes baby to put on extra weight, so we end up with neonate with macrosomia and hypoglycemic neonates. There are several risk factors, including the obesity, multiple pregnancy, increased maternal age, history of gestational diabetes, history of cesarean birth, family history of type 2 diabetes, polycystic ovarian syndrome, history of large baby, macrosomia, history of stillbirth, of abortion, and other factors. There are two main tests to screen and diagnose gestational diabetes. GCT, which is a glucose challenge test, and OGTT, which is oral glucose tolerance test. These two tests, based on giving the pregnant women a specific dose of glucose, such as 50 grams for the first one, which is GCT test, and 75 or 100 grams of oral glucose to the second test, which is called OGTT. And then the blood samples will be drawn at regular intervals. The diagnosis of gestational diabetes occurs between the 24th to 28 weeks of gestation by giving this oral glucose and then testing of gestational diabetes. Now, if the result of the blood glucose is higher or equals to 140 milligrams per deciliter, then this woman is diagnosed as gestational diabetes mellitus. There are many guidelines worldwide, such as American Diabetic Diabetes, as shown in the table, WHO, and other international guidelines. In Palestine, we have also different protocols and criteria to diagnose gestational diabetes. For example, some of these criteria will take the cutoff value for fast blood sugar to be more than 85, others more than or equals 92, others more than or equals 95. Some of the physicians go to the 50 gram GTT, others to 75 gram OGTT, and others to 100 gram OGTT. So what do you think? What is the most convenient test to be confirmed here in Palestine? There are many studies according to gestational diabetes, which studied the prevalence, the risk factors around the world, such as Saudi Arabia and others. And I precisely said Saudi Arabia to see what are the studies that in the neighboring countries. However, we found one study in Gaza Strip which describes the risk factor of gestational diabetes mellitus in refugee population, and it is a case control study. However, this study, the sample was chosen by having an already diagnosed gestational diabetes women. depending on occurrence of diabetes in the previous pregnancies. In our study, the situation is different. Now, the prevalence of gestational diabetes mellitus worldwide, it's around 7 to 10%, and the prevalence of gestational diabetes mellitus, according to Palestinian Ministry of Health in 2020, was 6%. Lastly, the prevalence of gestational diabetes mellitus, according to UNRWA in 2020, 11.8%. Therefore, we aimed in our study to determine the prevalence of gestational diabetes mellitus among pregnant Palestinian women. But which women? The women who were requested to perform glucose confirmation test. Then to study the risk factors related to gestational diabetes, such as age and fast blood sugar. Finally, to assess the gold standard test for screening, diagnosis, and confirmation of gestational diabetes. So the methodology we followed is a retrospective study, which was conducted among 839 pregnant women. The data were collected between October 2020 and January 2021 from 3 different public and private clinics. We aimed to comprise the geographical coverage in Palestine, especially, of course, our study was conducted in West Bank. The records were collected from UNRWA clinics, about 374 pregnant women, Palestinian Red Crescent, 306 women, and private clinics in Hebron, 159 women. The risk factors, including fast blood sugar and confirmation test type, which was either GCT or OGTT, and the pregnant women age were studied in relation to gestational diabetes mellitus. We use different statistical tests, such as frequency and percentages, and the chi-square test, Kruskal-Wallis test, and Spearman's correlation. All our statistical analysis were performed using SPSS, and the value below 0.05 was considered as significant. Now, the results of this retrospective study, first of all, we should describe our study sample. So we took samples from different regions of the West Bank. We started from Hebron because we collected the recorded data from Red Crescent and from private clinics. Then after that, we took the approval from UNRWA. So we widened our sample to be 4.6% from the north and 17% from the middle. And of course, the majority of our sample was located in Southwest Bank, which was 78%. Now, the age of these pregnant women were divided into 4 categories. Less than 20 years, between 20 and 30 years, between 31 and 40, and then more than 40 years. Of course, the fertile age of the women is between 20 and 30. That's why the majority of the age was in this category. It was 65%. Fasting blood sugar is an important criteria in this study. That's why we divided the values of the fasting blood sugars into 5 categories. The first one is less than 85 milligram per deciliter, and then between 86 and 95 milligram per deciliter, followed by 96 to 105, then 106 to 115, and lastly 116 to 125. Any fast blood sugar value above 125 milligram per deciliter were excluded from this study. And here, as we see from the results, the majority of the fasting blood sugar measured for these women was less than 85 milligram per deciliter. The confirmation test that was used for these women, as we said before, we have 3 confirmation tests: 50-gram GCT, 75 gram OGTT and 100 gram OGTT. The majority of the physician asked for 75 gram OGTT. Now, the result of the confirmation test were classified according to a cutoff value. It's 140 milligram per deciliter. So if the blood sugar after doing the confirmation test was less than 140 milligram per deciliter, and which is the majority, 87.7% of this sample, these were diagnosed as non-gestational diabetic women. While the value more than or equals 140 milligram per deciliter, which comprises 12.3%, this category is diagnosed as gestational diabetes mellitus. Now, this percentages was calculated, and I just put the percentages to give you an overview of our percentage. So 12.3% is an important percentage because later on we will see that this is the prevalence of our study. Now, how do we plan to do this this collecting of recorded data? We collected the confirmation test value, and we said that gestational diabetes mellitus will be more than or equals 140 milligram per deciliter for the blood glucose test, and non-gestational diabetes will be less than 140 milligram per deciliter. This is the core. We compared and see if there is association between the three risk factors in our study. Of course, there are many risk factors, but what we have in this study is the type of confirmation test, the age of pregnant women, and the fasting blood sugar. We will see the association with confirmation test value with each of these risk factors. And lastly, number 4, we will see the correlation between the age and the confirmation test value with fasting blood group by using Spearman's correlation. Now, we found that there was a significant difference between the age of pregnant women and the results of the confirmation test. This significance between the age group among the women diagnosed with gestational diabetes and non-gestational diabetes. To understand this significant difference, we performed the Kruskal-Wallis test. The principle of this statistical test is to have a grand median, which has a blue color, and to see the median of each group, if it's above this blue line or below. If we have a median above and below, this will describe and explain the significant differences that we have got from the chi-square. So for Kruskal test, as you see, the first group, which is less than 20, the median is under the grand median, and also the second group, but the third group and fourth group have median above the grand median. So we have a significant difference between the first two groups with the last two groups. The prevalence of gestational diabetes, as we see from the percentages on above each bar, is increased with increasing the maternal age, especially after 31 years old, which had the highest percentage for having gestational diabetes by 21% and around 27%. We also found a significant relation between fasting blood sugar and confirmation results value. In this Kruskal-Wallis test, we found that the first group, the median of the first group is under the grand median, while the other groups, the rest groups will have the median above the grand median. It means that fast blood sugar less than or equals 85 milligram per deciliter has a significant difference in the results of the confirmation tests between the age groups in the women diagnosed with gestational diabetes and non-gestational diabetes. And more likely, this result is consistent to UNRWA protocol in diagnosing of gestational diabetes, because in the UNRWA protocol, any woman that has a fast blood sugar above than 85, she will go and do the confirmation test. And this is important slide because we have to highlight the first two groups. And I put the percentage of gestational diabetes also above each bar. And we found that the first group, which is neglected by many physicians, we have found 4.5% of this group has gestational diabetes. And for the second group, 12.4% of these pregnant women that has fasting blood glucose between 86 and 85 has gestational diabetes. And this is important. In addition to that, pregnant women who had fasting blood sugar between 106 and 115, and the last group, 116, 125, had more possibility to develop gestational diabetes by 25% and 60%. The type of confirmation test was studied also with the confirmation result value. We found here that there is a significant difference between the 50-gram GCT with the OGTT, whether the OGTT is 75 or 100 gram. This means that for the physician, and according to our study and to our data, 75-gram OGTT is not significantly different than 100-gram OGTT. So this can be, we can ask the pregnant women to take less glucose than giving her more glucose and facing more stress with this high glucose. Lastly, the Spearman's correlation was done because we have here three variables: fasting blood sugar concentration value, confirmation test value, and age by year. And as we see here, we found that we have significant differences. It means that we have correlation with these three variables. But the correlation is around 0.2 and 0.3, so it is less than 0.6, which means that this significance has a weak positive correlation. Still, we have a significant correlation, but with a weak positive correlation between these three variables. In conclusion, from all the results, that by the age, the values of fast blood sugar and confirmation test increased, which would increase the susceptibility of developing gestational diabetes in aged groups. This table will summarize our data. We put in this table fasting blood sugar and age group. And as we see here from this group, if we see the last line, vertical, and the last line horizontal, we found that by age, the incidence and the gestational diabetic cases increases. And by increasing the fasting blood sugar for these women, also the gestational diabetes mellitus increased. So the prevalence of our study was, we found 103 pregnant women with gestational diabetes out of 839 women. So this is the prevalence of our study, but it's not the prevalence for Palestine, for the whole Palestine. And also we highlighted the importance to look at the fasting blood sugar, which is less than or equals 85%, because we found 16 pregnant women out of 356 had gestational diabetes, which is around 4.5% of the first group. And if we calculate this percentage according to the total sample, we found it's around 2% of the total sample, which has low fasting blood sugar, low or equals to 85, will get the gestational diabetes mellitus. So our conclusion from this study is screening of gestational diabetes by using fast blood sugar and its confirmatory tests remains a good tool to identify gestational diabetes in pregnant women. Our recommendation is more investigations regarding the association of risk factors with gestational diabetes mellitus development in Palestine are necessary. Why? Because this will provide early interventions measures and can improve pregnancy outcomes for both maternal and neonatals. And lastly, we should outline the approach to screening and diagnosis of gestational diabetes mellitus in Palestine, and this should be a priority. I would like to thank my colleagues, Wafa Abu Sbah from the UNRWA clinics in Hebron, and my students, Ragad Saafin and Nejma Dadoua, for their help in doing the statistical analysis. Thank you all, and I'm ready for any questions.
Thank you, Dr. Haneen, for the very nice presentation and informative also presentation. The floor is open for questions. Any questions?
Of course, it is a preliminary study. We started to look at gestational diabetes mellitus because we didn't find any articles about this issue except in Gaza Strip. And yesterday there was a presentation from one of the presenters about gestational diabetes mellitus. So it's an important
What I have a small question, Dr. Hani. What could be the risk factors for gestational diabetes?
As I mentioned, there are several risk factors and they should be studied. Here in our study, this was the limitation because it is a retrospective study and we have all these data. We cannot, such as like Red Crescents, we have only the age and fasting blood sugar and the confirmation test value. So we couldn't obtain other demographic data. While in the UNRWA,
the age is a risk factor.
Yes, the age is a risk factor. And here in our study, we included age and fasting blood sugar with the confirmation test. But we couldn't know if the women had multiple pregnancies before, or if they had history of diabetes mellitus, except for the UNRWA clinics, which have all these information computerized. So I hope that in future we had the same thing at the Ministry of Health, that all these data will be computerized when I want to see all these data about the women, the weight, also the obesity, because it has also...
The Ministry of Health percentage was 6%, and their samples must have been a very large number. Like why there is a big difference between UNRWA and your study and Ministry of Health?
Because in the Ministry of Health, they don't have one protocol. Each physician, each has his own school. Let's say there are different schools.
Okay.
Some will ask for the 50-gram GCT, others will ask for 75 OGTT or 100.
So they should stick to a proper protocol.
So we have to stick to accurate protocol in order to measure the accurate prevalence in Palestine. So that's why for UNRWA, the prevalence in 2020 is higher than in the Ministry of Health. Because all the clinics from the north to the south, they use the same procedure. And they consider the first two groups, which are neglected by many of the physicians. That's why the incidence, or sorry, the prevalence for the UNRWA calculations was more.
Thank you so much, Dr. Hani.
شكرا دكتور على very nice lecture. I have a very small question. انت you said بانه anyone who's above ال FPS تبعه فوق ال 126 was excluded from the study.
125.
Yes. طب إذا كانت أو if it was her second pregnancy and her first pregnancy was normal, would you exclude her or would you take her first pregnancy alone? Because sometimes gestational diabetes, as you know, can continue on after delivery. So maybe a patient you excluded having, let's say, 150 FPS, used to be a normal woman, but had at her first pregnancy gestational diabetes, which persisted at type 2 diabetes later on. Do you think this is a limitation to the study, or did you take this into consideration? Thank you.
Of course, all the data about the patient or the pregnant woman should be taken. So the physician should know if it's the first pregnancy or there was other pregnancies before. This is an important, and it doesn't mean that if the woman has like gestational diabetes for once, it should have the same for the second pregnancy and vice versa. So no, we have only this data, the recorded data. We used all the population that we had provided from these clinics, and we use the already prepared data. So we didn't design, we didn't design for this research. So in future, we can design and try to include more risk factors and more history about the pregnant women.
Thank you, Dr. Hanin.
But here we excluded this value because it's pre-gestational diabetic. So we don't want pre-gestational diabetic. We want to see if we have from this data gestational diabetes mellitus or not. Okay, thank you.
The most age internal that you think the most risky?
By increasing in age, we will have the high risk. 31 or more, according to our study, of course. According to our study, 31 years old or more, it's in the risk period.
Thank you. في سؤال تاني, what time is any it's okay. قديم, sorry, okay. Thank you, Dr.
So our next lecture is from Bisan Abu Abid. She holds a master's degree in the medical laboratory sciences from the Islamic University, and she works as a lab technician in the military medical services. Where is Bisan? They will present her research.
السلام عليكم ورحمة الله وبركاته. يسعدني أن أكون من ضمن المشاركين في المؤتمر الدولي الفلسطيني 11 للطب المخبري. محدثتكم بيسان أبو عبيد، حصل على درجة الماجستير في العلوم الطبية المخبرية من الجامعة الإسلامية بغزة. دراستي بعنوان Immunomodulatory Capability of Adipose Tissue Derived Mesenchymal Stem Cells. Introduction. Adipose mesenchymal stem cells are attractive candidates for treating immune-mediated disease, and they have potent immunomodulatory activities due to their efficiency, flexible application, and relative ease of isolation. Mesenchymal stem cells have found their ways in hundreds of clinical trials for treatment of numerous different diseases. Mesenchymal stem cells have emerged as a promising candidate in cell immunotherapy and regenerative medicine, owing to their unique advantages in transduction capacity, immunomodulatory function, homing, and paracrine effects. يتم عزل الخلايا الجذعية من عدة مصادر، من ضمنها البون مارو، umbilical cord, adipose tissue, dental bulb, and peripheral blood. ويعتبر المصدر الرئيسي لعزل الخلايا الميزنكايمال stem cells هو الاديبوز tissue، وذلك لعدة أسباب، ومن ضمنها accessibility, abundance, flexibility, easy isolation and culture, and possessing a limited amount of MHC class 1 that makes no immunogenicity and allow its allogenic transplantation. Significance لهذه الدراسة to isolate adipose mesenchymal stem cells and test their immunosuppressive capacity. in Gaza Strip, no previous studies have been conducted on either isolation of adipose mesenchymal stem cell or in testing the immunomodulatory potential of those cells. It's hoped that the result of this work will open the way for further research and the clinical applications of human mesenchymal stem cells. A diagrammatic illustration of mesenchymal stem cell isolation sources and characterization on the surface of mesenchymal stem cell and the transdiffusion, homing, and paracrine effects. Objectives of the study. The general objective is to assess whether adipose mesenchymal stem cells treatment with interferon gamma influence their immunosuppressive potential. And the specific objectives: 1, to isolate the adipose mesenchymal from lipoaspirate adipose tissue of healthy donor. 2, to verify the nature of adipose mesenchymal stem cell by detection the expression of different markers such as هناك العديد من الماركرز التي تكون على أسطح الخلايا الجذعية ومن ضمنها CD ماركر 105 CD 73 و CD 90. أيضا تنقص لوجود بعض الماركرز such as CD 45 والذي يعتبر hematopoietic antigen. 3, to assess the immunomodulatory potential of adipose mesenchymal stem cells after interferon gamma treatment by measuring the expression of IDO molecules. 4, to evaluate the immunosuppressive effect of co-culturing licensed adipose mesenchymal stem cells with the lymphocyte. الميثودولوجي اللي تم استخدامها في هذه الدراسة هي عبارة عن الكومون انزيماتيك بروتوكول. تم استخدام انزيم الكولاجينيز تايب 1 and incubation at درجة حرارة 37 لمدة 90 دقيقة. ثم بعد ذلك تم فلترة هذه الخلايا بواسطة نايلون مش، وبعد ذلك تم التخلص من السوبرنيتنت والاحتفاظ بالخلايا وإضافة الإريثروسايت لايسيس بفر للتخلص من باقي الشوائب ومن ضمنها الRBCs. ثم بعد ذلك تم زراعتها في أطباق مخصصة بواسطة الميديا DMEM على درجة حرارة 37 ولمدة يوم كامل 24 ساعة. أيضا كان الإنكوبيتر مزود بالCO2 بتركيز 5%. بعد الحصول على الخلايا تم متابعة العمل وتطبيق باقي التجارب من ضمنها عملية الكرايوبريزرفيشنز اوف سيلز، أيضا لايسنسينج للخلايا بواسطة استخدام انترفيرون جاما بتركيز 50 نانوغرام لكل مل. أيضا استخدام تقنية الMTT ولمتابعة الفيابيليتي والبروليفريشن بعد التريتمنت بالانترفيرون جاما. 5 detection of specific surface markers on adipose mesenchymal stem cells بواسطة PCR angel electrophoresis. 6 تطبيق تجربة الميجريشن وقدرة الخلايا على عملية الميجريشن بعد ما يصير لها تريتمنت بالانترفيرون جاما. الخطوة 7 isolation and activation of peripheral blood mononuclear cells. أيضا co-culture this cells with adipose mesenchymal stem cells. أيضا الخطوة الأخيرة real time PCR for measuring the expression of IDO and CD3. الريزلت اللي حصلنا عليها من هذه الدراسة morphology and growth of adipose mesenchymal stem cell، وتمت متابعة الخلايا لمدة 28 يوم بشكل متتابع، حيث أظهرت هذه الصور أن الخلايا تزداد نموها مع الأيام، وأيضا يجب الحصول على كونفلونس في الطبق لتطبيق باقي التجارب. تم الكشف عن وجود بعض من سيل سيرفيس على أسطح سيل سيرفيس سي دي ماركر على أسطح هذه الخلايا، ومن ضمنها سي دي ماركر 73 الذي يظهر في لين 2 أيضا في الصورة الأولى، أيضا سي دي 90 الذي يظهر في لين 4 وسي دي 105 الذي يظهر في لين 6. بالنسبة لسي دي 45 والذي لم يظهر على أسطح هذه الخلايا في الصورة الثانية، حيث أنه لم يكن هناك أي إكسبريشن لسي دي 45 على أسطح الخلايا الجذعية، والذي هو يعتبر سي دي ماركر مخصص للهيماتوبيتيك ستيم سيلز. بعد ما تم تطبيق التريتمنت بالانترفيرون جاما بتركيز 50 نانوغرام لكل مل، تم تطبيق تقنية الام تي تي والتي تستخدم لفحص البروليفريشن والفيابيليتي للخلايا، حيث أظهرت هذه النتائج أنه لا يوجد أي تأثير لاستخدام الانترفيرون جاما للخلايا على الخلايا، وذلك لمدة عدة أيام متتالية منذ اللحظة الأولى من استخدام العلاج الانترفيرون جاما حتى 9 أيام، حيث لم تظهر أي تأثير على هذه الخلايا. أيضا تم تطبيق تجربة المايجريشن والتي تعرف بالهومينج بعد معالجة الخلايا، حيث كانت هناك مقارنة ما بين الخلايا المعالجة والخلايا التي لم يتم معالجتها، وتم التقاط صور لمدة 3 أيام، حيث أظهرت النتائج أنه لا يوجد أي تأثير عند معالجة الخلايا بالإنترفيرون جاما، أنه لا يوجد أي تأثير على قدرة الخلايا بأنها تعمل مايجريشن، وبالتالي الانترفيرون جاما لا يوجد له أي تأثير سلبي على قدرة الخلايا إنها تعمل مايجريشن. النتيجة الخامسة اللي حصلنا عليها اللي هي قدرة الخلايا إنها تفرز مركب الآيدو، وأوضحت النتائج باستخدام الجل إلكتروفوريسيس إنه الخلايا الجذعية لها القدرة على إنها تفرز مركب الآيدو حتى بدون علاج الانترفيرون جاما، ولكن عند علاجها بالانترفيرون جاما فإنه يزيد من الإكسبريشن. في لين 2 في الصورة الأولى هو عبارة عن الخلايا المعالجة، وفي لين 3 الخلايا التي لم يتم معالجتها، وهناك أيضا إكسبريشن واضح في هذه الخلايا. في الصورة الثانية أوضحت أنه باستخدام طبعا ريال تايم بي سي آر أنه هناك وجود إكسبريشن للآيدو، ولكن بنسب بسيطة مقارنة مع بالخلايا طبعا المعالجة الغير معالجة مقارنة مع الخلايا التي تم معالجتها، حيث أوضحت هذه النتائج أن هناك زيادة، ولكن هذه الزيادة لم تكن ذو دلالة إحصائية. في النتيجة الأخيرة وهي لب الموضوع، حيث تم زراعة الخلايا الجذعية المعالجة مع خلايا التيلومفوسايت، وخلايا الجذعية التي لم يتم معالجتها مع الخلايا التيلومفوسايت مقارنة مع البوزيتيف كنترول اللي هو التيلومفوسايت، ولمقارنتهم طبعا بانخفاض في مستوى السي دي 3، حيث هناك كان انخفاض في السي دي 3 بالخلايا المعالجة بالانترفيرون جاما مع خلايا التي تم زراعتها مع خلايا التيلومفوسايت، ولكن هذا الانخفاض أو الديكريزنج لم يكن ذو دلالة إحصائية. طبعا تم زراعة هذه الخلايا لمدة 5 أيام، وتم تطبيق هذه الفحوصات، ولم تكن هذه الانخفاض لم يكن ذو دلالة إحصائية. Conclusions. بالبداية أظهرت النتائج أن هناك يوجد إكسبريشن على أسطح الخلايا مثل سيدي 105 و73 و90، كمان نيجاتيف لسيدي ماركر 45. أيضا أظهرت النتائج أنه اللايسنسنج للخلايا الجذعية بتركيز 50 نانوغرام لكل مل من الانترفيرون جاما لم يعني ما عمل أي فاريشن على البروليفريشن اند فيابيليتي مقارنة مع الخلايا التي لم يتم معالجتها. أيضا استخدام نفس التركيز من الانترفيرون جاما لم يؤثر على قدرة الخلايا إنها تعمل مايجريشن. وأيضا رقم 4 أظهرت النتائج أنه هناك إفراز من الأيضو يعتبر كونسستيفلي من الخلايا قبل ما يصير لها تريتمنت أي يعني بري لايسنسنج، وبالتالي هناك زيادة في محتوى الأيضو بعد ما تصير عملية اللي هو التريتمنت أو اللايسنسنج بالإنترفيرون جاما. كمان هناك النتيجة الأخيرة اللي هو عبارة عن انخفاض في مستوى او الاكسبريشن للسي دي ماركر 3 في حين زراعه كو كلتشر تي ليمفوسايت مع الخلايا الجذعيه التي تم معالجتها، ولكن هذا الانخفاض لم يكن ذو دلاله احصائيه. نوصي recommendations بانه يتم استخدام further strategies to more investigate the properties of adipose mesenchymal stem cell, for example using flow cytometry to investigate CD45 marker and IDO expression. أيضا نوصي examination additional soluble molecules are secreted by mesenchymal stem cell and performing different concentration of interferon gamma licensing. Thank you ويعطيكم ألف عافية، وسعيدة جدا بمشاركتي في هذا المؤتمر الدولي.
And for your nice presentation, which was clear and informative. And I don't know if there is any question. Yes.
Thank you, Wissam, for the nice presentation. I don't have a question, but I have the first one is using PCR to detect for the stem cells markers is not a good idea, I think, because you cannot discriminate, or you don't know even if you have a contaminating in your plate. I would rather use a flow cytometry. The stem cell that you are looking for. And second, in your presentation, you said that the IDO and CD3 were decreased, and you relied on the conventional PCR results, but you did also real-time PCR, and they were not influenced. So I would say they have no effect, because real-time PCR is more precise than the conventional PCR. That's only 2 remarks. Thank you.
I have a small question for Bisan regarding what Dr. Saad said. In this type of experiments, how could you have the quality control inside your lab? How can you keep the quality control of your work? Because you are working with tissue culture and you differentiated cells into mesenchymal stem cells. So this work needs more accuracy and quality control. Do you have any methods for that in your lab?
يعطيك العافية. بالنسبة للكواليتي كنترول أثناء فحوصات الBCR تم استخدام الجاب دي اتش. أما بالنسبة للكواليتي كنترول أثناء الكالتشرينج كان يتم متابعة الخلايا بشكل يومي وملاحظتها إذا كان في نمو لأي شيء غريب مثلا، وكان شكل الخلايا الطبيعي بما يتم يعني نشره على يعني بما يتم نشر صور للخلايا كان تم يعني يتم متابعتها بشكل يومي، وكان ما كنتش ألاحظ أي مشاكل يعني عليها.
Did you check or have a test for mycoplasma contamination?
Yes, أنا واجهت هاي المشكلة بالبداية، إنه كان في نمو لبعض الفطريات واستخدمت إلها أنتي فانجس في الميديا يعني.
Okay, thank you.
يعطيك العافية.
Okay. Our last presenter in the last session will be Safa El-Hitto. Safa has a degree, a master degree from Islamic University of Gaza. She works at the as a medical technologist at Al Auda Hospital. Safa, please.
من العلماء والباحثين في المؤتمر الدولي الفلسطيني 11 للطب المخبري، وسأقدم بحث بعنوان Cholesterol Resistance of Enterobacteriaceae Isolated from Clinical Samples in Gaza Strip بإشراف الأستاذ الدكتور عبد الرؤوف المناعمة ومشاركة كل من الدكتور محمد القاضي والدكتورة رشا خياط. على مدى العقود الثلاث الماضية كان تصنيع أعداد كبيرة من المضادات سبباً رئيسياً في زيادة خطر مقاومة البكتيريا، حيث أصبحت مقاومة للمضادات كنتيجة كروموسومال تشينج أو exchange of genetic material بواسطة بلازميدز والترانسبوزرز. وهناك العديد من الانتيروبكتيرياسيا أورجانيزم وممبرز من السودوموناس والمسببة للدياريا والسبسس واليوتي آي أصبحت الآن مقاومة لمعظم المضادات الحيوية القديمة. أما عن أسباب نشوء مقاومة البكتيريا فهي إما overprescribing of antibiotics, patients not taking antibiotic as prescribed, unnecessary antibiotic used in agriculture, poor infection control in hospitals and clinics, poor hygiene and sanitation practice, and lack of rapid laboratory tests. الكوليستين سلفات هو عبارة عن بوليميكسين with bactericidal activity استخدم منذ خمسينات القرن الماضي في علاج العدوى الناتجة عن الإصابة بمالتي دراج ريزيستنس جرام نيجاتيف بكتيريا. لكن مقاومة البكتيريا للكوليستين انتشرت حول العالم وتهدد الآن فعالية الكوليستين في علاج المالتي دراج ريزيستنس جرام نيجاتيف بكتيريا. آليات البكتيريا في مقاومتها للكوليستين تتمثل ب specific modification of outer membrane pores and reduction in the overall negative charge of the lipopolysaccharide, or over suppression of efflux pump systems, or over production of capsule polysaccharide. Primary objective of this study to investigate the presence of cholesterol resistance among Enterobacteriaceae isolated from clinical sample in Gaza Strip, and the specific objectives to determination of the resistance profiles of Enterobacteriaceae isolated for other antibiotics correlate between cholesterol resistance and other antibiotics resistance profile. تنبع أهمية الدراسة من عزل وتشخيص الانتيروبكتيرياسيا ودراسة خصائصها المقاومة، والذي يؤدي لمعرفة توزيع السلالات المقاومة في البشر. تم جمع 100 عزلة من انتيروبكتيرياسيا من مختبرات الميكروبيولوجي الخاصة بمستشفيات وزارة الصحة الفلسطينية في قطاع غزة، بواقع 20 عزلة من كل من مستشفى الشفاء والمستشفى الأوروبي ومجمع ناصر الطبي، مستشفى الأقصى ومستشفى الأندونيسي، من ديسمبر 2018 وحتى مايو 2019. After purification streak, each isolate was subjected to conventional biochemical test, triple sugar iron agar, simon citrate, urease, methyl red test, sulfide indole motility, oxidase test, and the gram. Each isolate was subjected to antimicrobial susceptibility testing using the disk diffusion in accordance to the procedures and guidance of Clinical Laboratory Sciences Institute, CLSI. Commercial antibiotics discs were placed onto the surface of a pre-swabbed molar Hinton agar plates with a 0.5 McFarland calibrated inoculum of the test organism. Plates incubated overnight at 37 degrees centigrade. Interpretation of the result were done according to antimicrobial disk manufacturer tables. About the cholesterol MIC, microbroth dilution method using 96 microtiter plates was employed. Serial dilutions of pure cholesterol were tested against a standardized bacterial inoculum. After 16 to 20 hours of incubation, a 20 international unit of tetrazolium chloride was added to each well and incubated for 15 minutes. MIC was calculated based on the color development. The collected enterobacteria E. coli by 51%, Klebsiella species 19%, Proteus group 19%, Serratia species 7%, and Enterobacteriaceae species 4%. E. coli was isolated mainly from urine sample by 74%, followed by pus, while Proteus group were isolated mainly from pus by 47%, followed by urine sample. In general, urine culture constituted the major source of the isolated 58%, followed by pus 31%. Antimicrobial resistance of clinical Enterobacteriaceae isolate. Varying degrees of susceptibility were observed for the isolated against the tested antimicrobials, even within member of the same antimicrobial class. Amikacin was the most effective drug with 74%, followed by chloramphenicol 48%, fosfomycin and gentamicin 45%. High resistance was recorded against trimethoprim 85% and tetracycline 83%. Concentration of more than 2 milligrams per liter or higher are classified as resistance. Only 59% of the tested isolated were interpreted as susceptible, while 41% were classified as resistance. The highest resistance to colistin was found to be among the Proteus group, 63%, followed by Serratia, 57%. The lowest resistance was observed among Klebsiella isolated, 31%. Despite variation in resistance among the different genera, no statistical difference was detected. P-value was 0.154. Colistin resistance among carbapenem resistance Enterobacteriaceae. Colistin being used as last choice for carbapenem resistant Enterobacteriaceae was therefore resistance against colistin was compared to that of imipenem and meropenem. Only 39% of meropenem resistant Enterobacteriaceae were susceptible to colistin, while 45% of imipenem resistant Enterobacteriaceae were susceptible to colistin. Overall resistance to colistin was high, 41% among tested clinical isolates. This limits and complicates the treatment option of infection caused by Enterobacteriaceae and Gaza strep. This calls for immediate action to control and monitor the use of antimicrobials general and colistin in particular. We recommended that further research is required to evaluate the genotypic characteristic of colistin resistance strains of Enterobacteriaceae to reduce the antimicrobial resistance of bacteria. It's necessary to use antibiotic wisely and based on culture and susceptibility results. Immediate action should be taken to control and monitor antimicrobial use in general and colistin in particular. Thank you.
Thank you. Thank you, Safa. Is Safa with us? Thank you so much, Safa, for the nice and interesting presentation. Any question from the audience? Okay, Safa. I want to ask Safa. Safa, okay, I will ask you just a couple of questions, please. Can you hear me? Safa? Safa, can you hear me? Okay.
تمام دكتور سامعنا.
Okay, Safa. You have you said that the highest resistance was for Proteus and Serratia, and Proteus and Serratia are actually they have an intrinsic resistance to colistin. They have a natural resistance. Most of the isolates, like not all, of course, 100%. No, most of the isolates are naturally resistant to colistin. So this might have increased the very high percentage of resistance in your study. Isn't it?
صحيح هي البروتيوس معروفة إنها resistance، بس قصدك يعني إنه كان ممكن نستثنيها وما نحطهاش في الإحصائية ولا كيف؟ مش فاهم السؤال بالضبط.
لا يعني you got about 41% resistance and most of them were for Proteus and Serratia. If you exclude Serratia and Proteus, which they have intrinsic resistance to colistin, the percentage might drop drastically. Okay, Safa. The next question: why you did not use this diffusion method for colistin? Why you use micro dilution method?
احنا استخدمنا في البداية ديسك ديفيوجن، بس كان في توصيات من CLSI بأنه الكوليستين نتائجه مش دقيقة في الديسك ديفيوجن، فآخر دراسة كانت إنه المايكرو ديليوشن نتائجها أدق، عشان هيك إحنا استخدمنا الطريقة الثانية واعتمدنا النتائج عليها.
Why like for this diffusion the results are not accurate? What is the reason?
ما بعرف، هي الخلل في الديسك نفسها وهيك كانت الفاريشن يعني كبيرة هيك، والنتائج يعني خلال الشغل فيها بتحس إنه هي مش كتير دقيقة، فعشان هيك كان في توصيات إنه إحنا نستخدم المايكرو ديليوشن، وتم استخدامها بتركيز مختلفة واعتمدنا النتائج بناء عليها، بناء على توصيات من CLSI.
Thank you so much, Safa. Thank you. يعطيك العافية.
شكرا، الله يعافيك يا رب.
يعني قول إنه نشكر جميع
اوكي. اوكي، يعطيكم العافيه جميعا. طبعا هذه كانت لاست برزنتيشن في اللاست سيشن، ونشكر جميع الحضور وطبعا اللي استمروا معنا لاخر لحظه. شكرا جزيلا للجميع ويعطيكم الف عافيه.
شكرا جزيلا للحضور كلكم.
السلام عليكم ورحمة الله وبركاته. والنهايات تشبه البدايات، وكما بدأنا بقوة ننهي مؤتمرنا هذا بخط حروفه على إنجازات نقابتنا الشامخة. هذا المؤتمر الذي سعينا فيه لاستغلال وقتنا بأمور تفيدنا في مهنتنا ومستقبلها، آملين من الله أن يكون حقق أهدافه وغاياته التي سطرت له، ونلتمس منكم العذر إن ورد منا بعض التقصير، فالكمال لله وحده، ويبقى عزاؤنا أنها تجربتنا الأولى وسنسعى لتطويرها آخذين في الاعتبار كل الملاحظات والتوصيات، ولأنه من لم يشكر القليل لم يشكر الكثير. باسمكم جميعا نرسل آيات الشكر والتقدير إلى القائمين على هذا المؤتمر من حرصوا على إنجاحه وتحقيق أهدافه. أترككم مع الكلمة الختامية مع كلمة رئيس المؤتمر الدكتور أسامة النجار، فليتفضل.
بسم الله الرحمن الرحيم. الزميلات والزملاء أعضاء مجلس النقابة، الأخوة الحاضرين في القاعة الذين نكن لكم كل الشكر والتقدير على استمراركم بالبقاء، وخاصة دكتور روبين، دكتور حاتم عيدي، دكتور سعد، دكتورة نوار، دكتورة حنين، دكتور أمجد. شكرا لكم على استمراركم في البقاء حتى اللحظة الأخيرة في هذا المؤتمر الذي ننهي اليوم 3 أيام كانت نتاج عمل استمر لأكثر من 6 شهور سابقا حتى نصل إلى هذا اليوم الذي ننهي فيه هذا المؤتمر بنجاح وبتميز، كما تعودنا نحن في نقابة الطب المخبري من أجل هذه المهنة والعاملين فيها. وبالرغم من الإشكاليات التي حدثت في بداية المؤتمر في قضايا التواصل وفتح التسجيلات أو المنصة، لكن استطعنا أن نتغلب عليها بالتعاون ما بين كافة الزملاء والجميع، وبالتالي كانت هناك المشاركة الفاعلة بالحضور من الجميع لهذه الجلسات جميعها. وكان هذا التواصل العربي والدولي الذي شاهدتموه جميعا عبر هذه المنصة التي أثبتت أننا قادرون حتى في ظل جائحة كورونا أن نتخطى الصعاب وأن نعقد هذا المؤتمر بدوريته كما تعودنا منذ أكثر من 20 عاما على عقد مثل هكذا مؤتمرات. فهذا هو المؤتمر ال11، وإن شاء الله يكون المؤتمر ال12 يكون مؤتمرا وجاهيا كما يرغب الجميع، لأن الجميع يتشوق إلى اللقاء وإلى أن يكون مؤتمر وجاهيا. وفي هذه القاعة التي باتت تحتضن كافة مؤتمرات الطب المخبري على مدار السنوات ال10 الماضية، وبالتالي ما نأمله أن تنتهي هذه الجائحة خلال الفترة القليلة القادمة، وأن نكون نحن القادة والجنود في إنهاء هذه الجائحة التي نلعب فيها دورا رئيسيا في تخطي هذه الجائحة من ناحية التشخيص والمتابعة والمراقبة وكل ما هو يرتبط بهذه الجائحة. ونحن كما قلنا في البداية أن الطب المخبري يواجه كل التحديات الطبية الطارئة التي تواجهه، وهو لديه القدرة على ذلك، وفي نفس الوقت أيضا هو لديه القدرة على الامتداد والتواصل لما بعد جائحة كورونا، وهذا ما ركزنا عليه من خلال الأوراق العلمية المتعددة لهذا المؤتمر. وبالتالي هي مسيرة مستمرة بإذن الله للمؤتمرات العلمية بشكل دائم، وبعد فترة من الزمن سنبدأ بالتحضير للمؤتمر الثاني عشر حتى يكون أيضا قصة نجاح إضافية كما تعودنا في نقابة الطب المخبري، وأن يكون مؤتمرا وجاهيا كباقي المؤتمرات السابقة، واستمرارا لنمط ونظام التعليم المستمر الذي تستمر به نقابة الطب المخبري وتتميز فيه في هذا الوطن عن كافة النقابات. فلا يوجد نقابة حتى الآن لديها برنامج منظم للتعليم المستمر سوى نقابة الطب المخبري. هذا البرنامج الذي لن يتوقف وسيستمر ويتطور بما هو أفضل لخدمة أعضاء النقابة وللمهنة والعاملين فيها. في الختام رسالة شكر لكل الذين ساهموا بنجاح هذا المؤتمر، بدءا من اللجنة العلمية التي بذلت كل الجهد في ترتيب هذا المؤتمر العلمي من الناحية العلمية، وعلى رأسها الدكتورة رانيا أبو سير التي لم تدخر جهدا في أن تقدم كل وقتها وجهدها من أجل إنجاح هذا المؤتمر، وليكون أيضا قصة نجاح تضاف إلى هذه المهنة والعاملين فيها. وإلى كل فرد في اللجنة العلمية أيضا قدم وساهم بما يستطيع في مجاله حتى يكون هذا المؤتمر على هذا القدر من الأهمية العلمية والمسؤولية أيضا في مسؤولية المهنة من ناحية التشخيص وعلاقتها بمستوى الصحة في فلسطين. أيضا الشكر موصول أيضا لزملائي أعضاء مجلس النقابة الذين أيضا ساهموا بكل ما أوتي وبكل القدرات الموجودة لديهم أيضا على إنجاح هذا المؤتمر، ويسروا عملية نجاح هذا المؤتمر بكل الإمكانيات التي استطعناها والتي استطعنا أن نعمل على توفيرها خلال فترة زمنية قصيرة. شكر للشركات الراعية لهذا المؤتمر التي أصبحت ليس مجرد رعاة حقيقيين، هم أصبحوا شركاء فعليا، شركاء فاعلين لدينا في النقابة، وأعضاء دائمين أيضا لدينا في النقابة على الجهد الذي بذل بشكل كبير جدا. شكر أيضا للشركة التي أدارت الملف الإلكتروني لهذا المؤتمر والصفحة الإلكترونية لهذا المؤتمر، شركة ماركوم، اللي أيضا بذلت جهد كبير جدا على أن يخرج المؤتمر بالصورة التي تليق بفلسطين والتي تليق بنقابة الطب المخبري الفلسطينية بشكل كبير جدا. شكر خاص من كل أعضاء مجلس نقابة الطب المخبري ومن هيئتها العامة لدينامو الذي نظم كل الإجراءات العملية لهذا المؤتمر، اللي هي الست اللي قاعدة قدامنا مديرة مكتبي كمان يعني لانا نزال، اللي فعليا من 3 أيام وهي تقوم بعملية متابعة لكل وقائع المؤتمر من اليوم الأول لليوم الثالث. هذا ناهيك عن الترتيبات المسبقة خلال عملية التحضير لانطلاق فعاليات هذا المؤتمر، كانت حاضرة على مدار الساعة، وحتى أنه يعني أنا كنت يمكن أروح كانت تكمل هي ورانيا في التأخر في النقابة حتى ساعة متأخرة من الليل في عملية تنظيم وتجهيز كل ما يتعلق بهذا المؤتمر. شكر لكل زملائي أعضاء الهيئة العامة الذين وثقوا في هذه النقابة وبقيادتها وشاركوا في هذا المؤتمر وتأكدوا أن فعالياته ستنجز كما هو مطلوب وكما هو معلوم، وآمنوا بقدرة هذه النقابة على عقد مثل هكذا مؤتمرات، وبيقين تام أننا سنستمر على عقد هذه المؤتمرات بنفس الصيغة وبنفس القدرة. الشكر دائما لجمعية الهلال الأحمر، الهلال الأحمر الفلسطيني كما يقولون لنا وكما نقول لهم نحن دائما أيضا، نحن لا نأتي هنا لنستأجر مكان لنعمل فيه، نحن نأتي إلى بيتنا الثاني، نأتي إلى مقر من مقراتنا كنقابة طب مخبري لنقوم بنشاط في داخل هذا المقر. هكذا نتعامل معهم وهكذا هم ينظرون إلينا في التعامل مع كل الخدمات التي تقدم لنا في جمعية الهلال الأحمر الفلسطيني. شكرا كثيرا لكم على كل الجهد الذي بذل معنا في هذا الموضوع. شكرا أيضا لكل من لم نستطع شكره أو لو ربما لم يصبه شكرنا ولا نعلم، نقدم كل شيء يستطيعه من أجل إنجاح هذا المؤتمر، آملين أن يبقوا شركاء دائمين معنا في هذا المؤتمر. الجميع يعلم أيضا أن في كل مؤتمر من مؤتمراتنا هناك جوائز علمية. لدينا جائزة عميد الطب المخبري، جائزة رشماوي، هذه وجائزة أفضل بوستر، وجائزة نقيب الطب المخبري. هذه الجوائز تعودنا كنمط أن نقوم بإعطائها في نهاية كل مؤتمر، لأننا نؤمن أن البحث العلمي يجب أن يكرم ويجب أن يكافأ، ويجب أن نشجع الباحثين والعلماء على الاستمرار في أبحاثهم، ليس مجرد فقط من أجل جائزة مالية أو هناك، وإنما لإبراز دورهم وتحفيز الآخرين على الإنتاج والإبداع العلمي، وهذا ما نسعى له دائما في النقابة. الشكر خاص حقيقة لعائلة رشماوي التي منذ بدء انطلاق هذه الجائزة، وهي جائزة عميد الطب المخبري، كأقدم شخص عمل في مهنة الطب المخبري في فلسطين، والدهم اللي أقروا إلى هذه الجائزة باسم لتكون أفضل جائزة تقدم لأفضل بحث علمي يقدم في المؤتمرات التي تعقدها نقابة الطب المخبري بشكل دائم، بالإضافة إلى جائزة أفضل بوستر يعرض في هذا المؤتمر، وجائزة النقيب التي تمنح لشخص من النقابة قدم خدمات جليلة للنقابة، يعني فوق المعيار المطلوب منه بعمله. يعني مثلا رئيس لجنة فرعية مطلوب منه 1 2 3 ما بنعطاش الجائزة لأنه هذا شغله، بينما واحد مش شغله وأعطي هذه الجائزة هي تكريم له على عمل قام به في النقابة لم يكن جزءا من مهماته النقابية المطلوبة. لذلك اليوم وخلال الأيام الماضية تم الاطلاع على كل الأوراق العلمية المقدمة من ناحية منهجية البحث، ومن ناحية موضوع البحث، ومن ناحية طريقة العرض للبيانات والنتائج، ومن ناحية الأهمية الطبية والعلمية للمجتمع الفلسطيني للبحث المقدم، الريليفنسي والإمبورتنس والحداثة في البحث المقدم. بعد الاطلاع على كل هذه الأمور وبالاستئناس بالتقييم الذي قامت به اللجنة العلمية للأوراق العلمية قبل إقرارها، أنا تقدم لنا أكثر من 80 ورقة علمية، أقر منها 44 ورقة علمية على ما أظن، وبالتالي بناء على ذلك فقد وجدت اللجنة أن الجوائز تمنح لما يلي: جائزة عميد الطب المخبري قسمت إلى 3 فئات، الفئة الأولى والفئة الثانية والفئة الثالثة. الفئة الأولى وهي الجائزة الأولى وهي بقيمة $3000 ودرع وشهادة حصل عليها البحث المقدم من دكتورة نوار القطب وزملائها في الجامعة العربية الأمريكية في جنين بعنوان Genomic Epidemiology of the First Epidemic Wave of Severe Acute Respiratory Syndrome Coronavirus 2. شكرا دكتورة نوار، وهي موجودة بيننا اليوم ومستمرة معنا. المستوى الثاني وقيمة الجائزة $2000 ودرع وشهادة أيضا، وقد فازت بها الباحثة دكتورة داليا أبو هلال وزملائها من جامعة القدس عن بحثها المقدم للمؤتمر بعنوان Micro Satellite Instability and Mismatch Repair Genes Variation Testing for the Identification of Lynch Syndrome among Palestinian Colorectal Cancer Patients. المستوى الثالث من جائزة رشماوي وهو بقيمة $1000 ودرع وشهادة، وقد فازت بها أيضا دكتورة هدير أبو وردة من قطاع غزة وزملائها من الجامعة الإسلامية بغزة عن بحثها المقدم بعنوان Investigating Aneuploidy Inducing Effect of Meniere, Roger and Derspan in Human Peripheral Blood Lymphocyte Cultures. أما جائزة أفضل ملصق علمي فقد تم منحها للباحثة الدكتورة حنين نور، موجودة الدكتورة حنين، المقدم بعنوان Hematological Findings and Abnormalities Among Patients with COVID-19 Admitted to Al-Ahli Hospital in Hebron, Governorate Palestine. أما جائزة نقيب الطب المخبري والتي كانت قد حجبت على مدار المؤتمرين السابقين، وجدنا أن هذا المؤتمر هناك من عمل لهذه النقابة بكل جد واجتهاد، وهذه الجائزة ربما لا تكفيه حقه، وبالتالي قرر مجلس النقابة منحها إلى الدكتورة رانيا أبو سير من جامعة القدس على جهودها وعطائها الدائم في نقابة الطب المخبري وخدماتها المميزة للمهنة والبحث العلمي، مدركين دكتورة رانيا أن هذه الجائزة لا تعطيك حقك الكامل فيما تقدميه من تعاون دائم معنا في نقابة الطب المخبري وفي مجالات البحث العلمي، وحتى التعليم في مجال الطب المخبري والتعليم المستمر معنا في النقابة. جهودكم مشكورة دائما، آملين أن نلتقي وجاهيا المؤتمر القادم وفي هذا المكان، وأن تكونوا جميعا تنعمون بوافر الصحة والعافية إن شاء الله، وأن تكون جائحة كورونا قد انتهت إلى غير رجعة، وإن شاء الله شعبنا يكون بأفضل حال خالصا مخلصا من الاحتلال أيضا، وأن نكون بحرية واستقلال. يعطيكم ألف عافية وشكرا لكم. طبعا سيكون هناك احتفال خاص سندعوكم عليه لتوزيع هذه الجوائز وبحضور شخصيات مهمة في مكان آخر. طبعا سنلتقي جميعا بدعوات خاصة لتوزيع هذه الجوائز وتسليمها، آملين أن عندما نوزع هذه الجوائز في الاحتفالية قريبة جدا لن تكون بعيدة أن نراكم موجودين بيننا، لأنكم أيضا تستحقون التكريم جميعكم مع زملائكم الذين حصلوا على هذه الجوائز. آملين أن تكون دافع ومحفز للجميع للبحث العلمي في مجال الطب المخبري، لأن أعتقد أنه من أوسع المجالات التي يمكن أن يكون فيها نتائج ويكون فيها تجارب ناجحة في هذه النتائج التي تخرج من هذه الأبحاث. يعطيكم العافية وشكرا لكم جميعا.
الجبال شالوا الحمال والمجد بيدو حياهم، خاضوا الشدة والأهوال والله بعينه يرعاهم.
يبطال المختبرات يلا تحدوا الأزمات، لكورونا تصدوا بثبات والله معكم الله.
يبطال المختبرات يلا تحدوا